Welcome to this introductory course on data analytics, the first in a series of courses designed to prepare you for a career as a junior data analyst. To quote a Forrester Consulting report on the power of data to transform business, businesses today recognize the untapped value in data and data analytics as a crucial factor for business competitiveness. To drive their data and analytics initiatives, companies are hiring and upskilling people. They're expanding their teams and creating centers of excellence to set up a multi-pronged data and analytics practice in their organizations. Combined to this is the significant supply and demand mismatch in skilled data analysts, making it a highly sought-after and well-paid profession. You can choose to master data analytics as a career path or leverage it as a stepping stone to branch out into other data professions, such as data science, data engineering, business analytics, and business intelligence analytics. This course is for you if you're a fresh graduate from any stream, a working professional considering a mid-career transition, a data-driven decision maker, or in any analytics-enabled role. The course introduces you to the core concepts, processes, and tools you need to gain entry into data analytics, or even to strengthen your current role as a data-driven decision maker. It will equip you with an understanding of the data ecosystem and the fundamentals of data analysis, such as data gathering, wrangling, mining, analysis, and data visualization. You'll also get the feel of a day in the life of a data analyst. Practicing data analysts share their experience in gaining entry into this field, career options and learning paths you can consider, and what employers look for in a data analyst. They also share their knowledge and best practices about some of the aspects of the data analysis process. What lies ahead is truly exciting, both for the field and for you as a data analyst. So, congratulations on choosing to be on this journey, and good luck! To quote a Forbes 2020 report on data in the coming decade, the constant increase in data processing speeds and bandwidth, the nonstop invention of new tools for creating, sharing, and consuming data, and the steady addition of new data creators and consumers around the world ensure that data growth continues unabated. Data begets more data in a constant virtuous cycle. A modern data ecosystem includes a whole network of interconnected, independent, and continually evolving entities. It includes data that has to be integrated from disparate sources, different types of analysis and skills to generate insights, active stakeholders to collaborate and act on insights generated, and tools, applications, and infrastructure to store, process, and disseminate data as required. Let's start with the data sources. Data is available in a variety of structured and unstructured datasets, residing in text, images, videos, clickstreams, user conversations, social media platforms, the Internet of Things or IoT devices, real-time events that stream data, legacy databases, and data sourced from professional data providers and agencies. The sources have never before been so diverse and dynamic. When you're working with so many different sources of data, the first step is to pull a copy of the data from the original sources into a data repository. At this stage, you're only looking at acquiring the data you need, working with data formats, sources, and interfaces through which this data can be pulled in. Reliability, security, and integrity of the data being acquired are some of the challenges you work through at this stage. Once the raw data is in a common place, it needs to get organized, cleaned up, and optimized for access by end users. The data will also need to conform to compliances and standards enforced in the organization. For example, conforming to guidelines that regulate the storage and use of personal data such as health, biometrics, or household data in the case of IoT devices. Adhering to master data tables within the organization to ensure standardization of master data across all applications and systems of an organization is another example. The key challenges at this stage could involve data management and working with data repositories that provide high availability, flexibility, accessibility, and security. Finally, we have our business stakeholders, applications, programmers, analysts, and data science use cases all pulling this data from the enterprise data repository. The key challenges at this stage could include the interfaces, APIs, and applications that can get this data to the end users in line with their specific needs. For example, data analysts may need the raw data to work with. Business stakeholders may need reports and dashboards. Applications may need custom APIs to pull this data. It's important to note the influence of some of the new and emerging technologies that are shaping today's data ecosystem and its possibilities. For example, cloud computing, machine learning, and big data, to name a few. Thanks to cloud technologies, every enterprise today has access to limitless storage, high-performance computing, open-source technologies, machine learning technologies, and the latest tools and libraries. Data scientists are creating predictive models by training machine learning algorithms on past data. Also, big data. Today, we're dealing with datasets that are so massive and so varied that traditional tools and analysis methods are no longer adequate, paving the way for new tools and techniques and also new knowledge and insights. We'll learn more about big data and its influence in shaping business decisions further along in this course. Today, organizations that are using data to uncover opportunities and are applying that knowledge to differentiate themselves are the ones leading into the future. Whether looking for patterns in financial transactions to detect fraud, using recommendation engines to drive conversion, mining social media posts for customer voice, or brands personalizing their offers based on customer behavior analysis, business leaders realize that data holds the key to competitive advantage. To get value from data, you need a vast number of skill sets and people playing different roles. In this video, we're going to look at the role data engineers, data analysts, data scientists, business analysts, and business intelligence or BI analysts play in helping organizations tap into vast amounts of data and turn them into actionable insights. It all starts with a data engineer. Data engineers are people who develop and maintain data architectures and make data available for business operations and analysis. Data engineers work within the data ecosystem to extract, integrate, and organize data from disparate sources, clean, transform, and prepare data, design, store, and manage data in data repositories. They enable data to be accessible in formats and systems that the various business applications, as well as stakeholders like data analysts and data scientists, can utilize. A data engineer must have good knowledge of programming, sound knowledge of systems and technology architectures, and in-depth understanding of relational databases and non-relational data stores. Now let's look at the role of a data analyst. In short, a data analyst translates data and numbers into plain language so organizations can make decisions. Data analysts inspect and clean data for deriving insights, identify correlations, find patterns, and apply statistical methods to analyze and mine data, and visualize data to interpret and present the findings of data analysis. Analysts are the people who answer questions, such as, Are the user's search experiences generally good or bad with the search functionality on our site? Or what is the popular perception of people regarding our rebranding initiatives? Or is there a correlation between sales of one product and another? Data analysts require good knowledge of spreadsheets, writing queries, and using statistical tools to create charts and dashboards. Modern data analysts also need to have some programming skills. They also need strong analytical and storytelling skills. And now let's look at the role data scientists play in this ecosystem. Data scientists analyze data for actionable insights and build machine learning or deep learning models that train on past data to create predictive models. Data scientists are people who answer questions such as, how many new social media followers am I likely to get next month? Or, what percentage of my customers am I likely to lose to competition in the next quarter? Or, is this financial transaction unusual for this customer? Data scientists require knowledge of mathematics, statistics, and a fair understanding of programming languages, databases, and building data models. They also need to have domain knowledge. Then we also have business analysts and BI analysts. Business analysts leverage the work of data analysts and data scientists to look at possible implications for their business and the actions they need to take or recommend. BI analysts do the same, except their focus is on the market forces and external influences that shape their business. They provide business intelligence solutions by organizing and monitoring data on different business functions and exploring that data to extract insights and actionables that improve business performance. To summarize in simple terms, data engineering converts raw data into usable data. Data analytics uses this data to generate insights. Data scientists use data analytics and data engineering to predict the future using data from the past. Business analysts and business intelligence analysts use these insights and predictions to drive decisions that benefit and grow their business. Interestingly, it's not uncommon for data professionals to start their career in one of the data roles and transition to another role within the data ecosystem by supplementing their skills. Data analysis is the process of gathering, cleaning, analyzing, and mining data, interpreting results, and reporting the findings. With data analysis, we find patterns within data and correlations between different data points. And it is through these patterns and correlations that insights are generated and conclusions are drawn. Data analysis helps businesses understand their past performance and informs their decision-making for future actions. Using data analysis, businesses can validate a course of action before committing to it, saving valuable time and resources, and also ensuring greater success. We'll explore 4 primary types of data analysis, each with a different goal and place in the data analysis process. Descriptive analytics helps answer questions about what happened over a given period of time by summarizing past data and presenting the findings to stakeholders. It helps provide essential insights into past events. For example, tracking past performance based on the organization's key performance indicators or cash flow analysis. Diagnostic analytics helps answer the question, why did it happen? It takes the insights from descriptive analytics to dig deeper to find the cause of the outcome. For example, a sudden change in traffic to a website without an obvious cause, or an increase in sales in a region where there has been no change in marketing. Predictive analytics helps answer the question, what will happen next? Historical data and trends are used to predict future outcomes. Some of the areas in which businesses apply predictive analysis are risk assessment and sales forecasts. It's important to note that the purpose of predictive analytics is not to say what will happen in future. Its objective is to forecast what might happen in the future. All predictions are probabilistic in nature. Prescriptive analytics helps answer the question, what should be done about it? By analyzing past decisions and events, the likelihood of different outcomes is estimated on the basis of which a course of action is decided. Self-driving cars are a good example of prescriptive analytics. They analyze the environment to make decisions regarding speed, changing lanes, which route to take, etc. Or airlines, automatically adjusting ticket prices based on customer demand, gas prices, the weather, or traffic on connecting routes. Now let's look at some of the key steps in any data analysis process. Understanding the problem and desired result. Data analysis begins with understanding the problem that needs to be solved and the desired outcome that needs to be achieved. Where you are and where you want to be needs to be clearly defined before the analysis process can begin. Setting a clear metric. This stage of the process includes deciding what will be measured, for example, number of product X sold in a region, and how it will be measured, for example, in a quarter or during a festival season. Gathering data. Once you know what you're going to measure and how you're going to measure it, you identify the data you require, the data sources you need to pull this data from, and the best tools for the job. Cleaning data. Having gathered the data, the next step is to fix quality issues in the data that could affect the accuracy of the analysis. This is a critical step because the accuracy of the analysis can only be ensured if the data is clean. You will clean the data for missing or incomplete values and outliers. For example, a customer demographics data in which the age field has a value of 150 is an outlier. You will also standardize the data coming in from multiple sources. Analyzing and mining data. Once the data is clean, you will extract and analyze the data from different perspectives. You may need to manipulate your data in several different ways to understand the trends, identify correlations, and find patterns and variations. Interpreting results. After analyzing your data and possibly conducting further research, which can be an iterative loop, it's time to interpret your results. As you interpret your results, you need to evaluate if your analysis is defendable against objections and if there are any limitations or circumstances under which your analysis may not hold true. Presenting your findings. Ultimately, the goal of any analysis is to impact decision-making. The ability to communicate and present your findings in clear and impactful ways is as important a part of the data analysis process as is the analysis itself. Reports, dashboards, charts, graphs, maps, case studies are just some of the ways in which you can present your data. In this video, we will listen to several data professionals talk about how they define data analytics and what this term means to them.
I define data analytics as the process of collecting information and then analyzing that information to confirm various hypotheses. To me, data analytics also means storytelling with data, using data to clearly and concisely convey the state of the world to the people around you.
Data analysis is the use of information around you to make decisions. Just like you get up every morning, you watch the news, the weather report will tell you the temperature for the day, whether it's going to rain. That may dictate what you're going to wear or what activities you can do. So data analysis isn't an abstract concept. It's something that we do naturally, but it has a technical name, and now people are being paid to do it in a much larger or grander experience, but really it's not that complicated.
The way I put it is that you've got a problem and you need to use facts to test your hypothesis. That's where data analytics comes into play. The process starts from defining the problem, and then you need to create your own hypothesis. And to test that, you need to collect data, clean data, analyze data, and then present it to the key stakeholders.
Data analytics is really any sets of data that you can use to review information, anything that's going to help you to understand what is going on. In my case, as a CPA, I am always looking at financial statements, and I'm always analyzing data to predict where someone's been, where they are right now, and where they're headed. And so that data helps me to see further and almost predict the future of any company that I'm working with.
So data analytics is the collecting, cleansing, analyzing, presenting, and ultimately sharing of data and your analysis to be able to help communicate exactly what's going on with your business, what's going on in the data, so that you can help make better decisions.
I would define data analytics as a process, or better yet, a phenomenon of taking information gathered from a relevant population, maybe your customers or your social audience, and breaking that information down into subsets and using that data to make decisions about products or services that you want to offer, or in cases of the digital environment that we're in, making decisions about certain pieces of content that you want to publish so that it appeals to your target audience.
While the role of a data analyst varies depending on the type of organization and the extent to which it has adopted data-driven practices, there are some responsibilities that are typical to a data analyst role in today's organizations. These include acquiring data from primary and secondary data sources, creating queries to extract required data from databases and other data collection systems, filtering, cleaning, standardizing, and reorganizing data in preparation for data analysis, using statistical tools to interpret data sets, using statistical techniques to identify patterns and correlations in data, analyzing patterns in complex data sets and interpreting trends, preparing reports and charts that effectively communicate trends and patterns, creating appropriate documentation to define and demonstrate the steps of the data analysis process. Corresponding to these responsibilities, let's look at some of the skills that are valuable for a data analyst. The data analysis process requires a combination of technical, functional, and soft skills. Let's first look at some of the technical skills that you need in your role as a data analyst. These include expertise in using spreadsheets such as Microsoft Excel or Google Sheets, proficiency in statistical analysis and visualization tools and software such as IBM Cognos, IBM SPSS, Oracle Visual Analyzer, Microsoft Power BI, SAS, and Tableau. Proficiency in at least one of the programming languages such as R, Python, and in some cases C++, Java, and MATLAB. Good knowledge of SQL and ability to work with data in relational and NoSQL databases. The ability to access and extract data from data repositories, such as data marts, data warehouses, data lakes, and data pipelines. Familiarity with big data processing tools, such as Hadoop, Hive, and Spark. We will understand more about the features and use cases of some of these programming languages, databases, data repositories, and big data processing tools further along in the course. Now let's look at some of the functional skills that you require for the role of data analyst. These include proficiency in statistics to help you analyze your data, validate your analysis, and identify fallacies and logical errors. Analytical skills that help you research and interpret data, theorize, and make forecasts. Problem-solving skills, because ultimately the end goal of all data analysis is to solve problems. Probing skills that are essential for the discovery process, that is, for understanding a problem from the perspective of varied stakeholders and users, because the data analysis process really begins with a clear articulation of the problem statement and desired outcome. data visualization skills that help you decide on the techniques and tools that present your findings effectively based on your audience, type of data, context, and end goal of your analysis. Project management skills to manage the process, people, dependencies, and timelines of the initiative. That brings us to your soft skills as a data analyst. Data analysis is both a science and an art. You can ace the technical and functional expertise, but one of the key differentiators for your success is going to be soft skills. This includes your ability to work collaboratively with business and cross-functional teams, communicate effectively to report and present your findings, tell a compelling and convincing story, and gather support and buy-in for your work. Above all, being curious is at the heart of data analysis. In the course of your work, you will stumble upon patterns, phenomena, and anomalies that may show you a different path. The ability to allow new questions to surface and challenge your assumptions and hypotheses makes for a great analyst. You will also hear data analysis practitioners talk about intuition as a must-have quality. It's essential to note that intuition in this context is the ability to have a sense of the future based on pattern recognition and past experiences. In this video, we will listen to practicing data professionals talk about the qualities and skills required to become a data analyst.
The qualities and skills of a data analyst: a person who's curious naturally, someone who has attention to detail and enjoys working with computers. A curious person will look to find answers even sometimes when there isn't a question, or they don't mind researching and looking in areas that may not have been thought of before. Attention to detail or looking for patterns. Do you walk into a room and just count naturally people, how the room is set up, paying attention to close details, and then enjoying computers. Because technology is moving so fast, something or a skill that you learn today in 2 to 3 years may not be applicable. So you need to be able to develop new skills and learn new software depending on how the market or the industry has changed.
Definitely both the technical skills and soft skills are required. Technical skills include Python, SQL, R, Tableau, and Power BI. And the soft skills or interpersonal skills mean whether you know what's the right data to utilize and what's the right tool to use and how to present the data to the key stakeholders. And these skill sets require the business acumen and the presentation skills.
You have to be very detail-oriented, you have to love numbers, you have to love information, and be willing to look at that information and not just look at it on the surface, but dive deeper. So for example, in what we do, I can't just take a bank statement at face value. I have to actually look at it and compare it. Does the seal look right? Especially in today's world, there's a lot of fraud and miscommunication. So to be, and people that are trying to take your information and fraudulently use it. So a good data analyst should be able to compare last year's information to this year's information to see if it looks right. You have to have that eye and that mindset and not just take things at face value.
There are many qualities and skills required to be a data analyst, and I'd break them down into two buckets, basically, soft skills and technical skills. I think the most important soft skills for a data analyst is to be really curious, to ask a lot of good questions, to be really thoughtful, and to listen carefully and understand both the user perspective and your coworkers' perspective and what they most need from the data, and always be willing to learn, because analytics is a fast-moving field, so you have to constantly be learning and reading to stay on top of it. There are many technical skills required to be a data analyst. The most important technical skill for any new data analyst to learn is SQL. It's by far the most widely used, and anytime you're extracting data from a database, you're going to need to know SQL. And there is nothing quite like a data analyst with really, really good SQL skills. I think sometimes people get ahead of themselves and try a bunch of very complicated technologies before getting the basics of SQL down, and I think that's a really big mistake. I think it's always nice to know Python and R, which are the two main programming languages used to do data analysis. I think as a new data analyst, you don't need to be proficient in both, or really either, but starting to get good at one or the other is going to be really useful for your career. Another important technical skill to have for a data analyst is to be really good at least one data visualization tool and to understand general principles of data visualization.
Today, the end-to-end skill set of a data analyst is far more dynamic than what it used to be. So a data analyst needs to know what problem they're trying to solve with the data, pull that data as they need it in, the structure they need it in, using SQL from the data lake that it's sitting in. There'll be many different tables and they'll need to figure out how to join them and then pull the data, clean it up, wrangle, manipulate it, mine it, so that they're able to kind of glean insights out of it, present those insights concisely, clearly, using good visualizations and dashboards, and in other words, be able to tell a good story with that data.
A day in the life of a data analyst can include a number of possibilities, from acquiring data from varied data sources to creating queries for pulling data from data repositories, foraging through rows of data to look for insights, creating reports and dashboards, and interacting with stakeholders for gathering information and presenting the findings. It's a spectrum. And yes, the big one: cleaning and preparing the data so that the findings have a credible basis, which, by the way, is a large part of what any data analyst may find themselves doing in their jobs. But if I had to walk you through any one type of day, I'm going to pick one which has me foraging through data looking for insights. This is the part of my job that I am totally in awe of. Hi, I am Sivaram Jaladi. I work as a data analyst with Fluent Grid, a smart grid technology solutions company based in Visakhapatnam in India. Fluent Grid is an IBM partner and the recipient of IBM Beacon Awards for its solutions in the areas of smart energy and smart city industry segments. We offer integrated operations center solutions for power utilities and smart cities, leveraging our actionable intelligence platform known as Fluent Grid Actilligence. Our client, a power utility company in South India, has been noticing a spike in complaints regarding overbilling, and the frequency of these complaints seems to suggest there is something more to it than random occurrences. So, I'm asked to look at the complaints and the billing data and see if I can spot something. I start by taking stock of what I have. Some of the obvious places that I know I am going to be looking into is the complaint data, the subscriber information data, and the billing data. That's going to be my starting point. Before I dive into the specifics of the data, I'm going to make a list of questions, initial hypotheses that I'm going to start with, such as 1. The usage pattern of subscribers reporting this issue. Is there a consumption range for which overbilling is occurring more than others? 2. Area-wise concentration of complaints. Are the complaints concentrated in specific localities within the city? 3. Frequency and occurrence of complaints based on individual subscribers. Are the same subscribers reporting overbilling repetitively? If yes, what is the frequency of occurrence in repeat cases? If a subscriber is overbilled once, does the overbilling occur every month from the first occurrence? Or are repeat occurrences sporadic or not at all? As I get clear on my initial hypotheses and the set of questions I'm going to start with, I identify the data sets that I'm going to isolate and analyze to validate or refute my hypotheses. I pull out the average annual, quarterly, and monthly billing amounts of the complainants and look for a range in which the complaints are falling more than others. I then pull up the location data of the complainants to see if there is a connection between overbilling and zip codes. Here I see what seems to be a concentration of complaints in certain areas. This looked like it could add up to something. So, instead of moving to the third hypothesis, I decide to get a little deeper into this data. Next, I pull out the date of connection data. More than 95% of the complainants had been our subscribers for more than 7 years, though not all subscribers over the 7-year mark were facing this complaint. So now, we see some area-wise concentration, and we see a significant concentration of complaints based on the date of connection. Next, I pull out the make and the serial number of the meters. And there it is. The serial numbers belonged to the same batch of meters provided by the same supplier. The concentration of these meters and therefore the complaints was coming from areas in which these meters were installed. At this stage, I feel confident in presenting these findings to the stakeholders. I'm also going to share the data sources and my process of arriving at this analysis. That always goes a long way in lending credibility to the findings. This could be the end of this project, or it may very well come back. Maybe the same complaints with different commonalities, or a completely different set of complaints for which we need to find answers.
In this video, practicing data professionals talk about some of the applications of data analytics in today's world.
The applications of data analytics in the world today is everywhere. Every commercial that you see, someone had to analyze and identify, either from the consumer or for the company, what information they wanted to share. So, 4 out of 10 dentists, or you'll see information related to calorie counts or reactions to certain things. All of that required analysis. This isn't something that should be thought of separate and apart from. It's what we do every day in our lives. Even people monitoring their sugar level with diabetes. There's always analysis going on, so the applications are universal.
So the great thing with analytics in this day and age is that it's very widely applicable. Every industry, every vertical, every function within a given organization can benefit from data and analytics. Whether you're doing sales pipeline analysis, whether you're doing financials at the end of the month, creating predefined and standardized formatted reports, or if you're doing something like headcount planning or headcount review. All of these across every vertical, as I said, whether it's airlines, pharmaceuticals, banking, all these and the functions within them can benefit from analytics.
And in this climate that we're in right now with the pandemic, there are companies who are paying close attention to their customers' buying habits. Obviously, they may have varied from what these companies expected these habits to be. And so now data analytics is more important because they need to make sure they can pivot and keep up with the demand and really be able to cater to what their clients and their customers want.
I can talk about applications of data analytics in finance. These years, we have seen more and more applications of alternative data analytics in the finance world. For example, we can use sentiment analysis of tweets and news stories to supplement traditional financial analysis and to inform better investment decisions. Besides, the satellite imagery data can be used to track the development of industrial activities, and the geolocation data can be used to track the store traffic and to predict the sales volume.
A A data analyst's ecosystem includes the infrastructure, software, tools, frameworks, and processes used to gather, clean, analyze, mine, and visualize data. In this video, we will go over a quick overview of the ecosystem before going into the details of each of these topics in subsequent videos. Let's first talk about data. Based on how well defined the structure of the data is, data can be categorized as structured, semi-structured, or unstructured. Data that follows a rigid format and can be organized neatly into rows and columns is structured data. This is the data that you see typically in databases and spreadsheets, for example. Semi-structured data is a mix of data that has consistent characteristics and data that doesn't conform to a rigid structure. For example, emails. An email has a mix of structured data, such as the name of the sender and recipient, but also has the contents of the email, which is unstructured data. And then there is unstructured data, data that is complex and mostly qualitative information that is impossible to reduce to rows and columns. For example, photos, videos, text files, PDFs, and social media content. The type of data drives the kind of data repositories that the data can be collected and stored in, and also the tools that can be used to query or process the data. Data also comes in a wide-ranging variety of file formats being collected from a variety of data sources, ranging from relational and non-relational databases to APIs, web services, data streams, social platforms, and sensor devices. This brings us to data repositories, a term that includes databases, data warehouses, data marts, data lakes, and big data stores. The type, format, and sources of data influence the type of data repositories that you can use to collect, store, clean, analyze, and mine the data for analysis. If you're working with big data, for example, you will need big data warehouses that allow you to store and process large volume, high velocity data, and also frameworks that allow you to perform complex analytics in real time on big data. The ecosystem also includes languages that can be classified as query languages, programming languages, and shell and scripting languages. Querying and manipulating data with SQL to developing data applications with Python and writing shell scripts for repetitive operational tasks. These are important components in a data analyst's workbench. Automated tools, frameworks, and processes for all stages of the analytics process are part of the data analyst's ecosystem. From tools used for gathering, extracting, transforming, and loading data into data repositories, to tools for data wrangling, data cleaning, analysis, data mining, and data visualization. It's a very diverse and rich ecosystem. Spreadsheets, Jupyter Notebooks, and IBM Cognos are just a few examples. We will cover some of the data analytics tools in greater detail in subsequent sections of the course. Data is unorganized information that is processed to make it meaningful. Generally, data comprises of facts, observations, perceptions, numbers, characters, symbols, and images that can be interpreted to derive meaning. One of the ways in which data can be categorized is by its structure. Data can be structured, semi-structured, or unstructured. Structured data has a well-defined structure or adheres to a specified data model, can be stored in well-defined schemas such as databases, and in many cases can be represented in a tabular manner with rows and columns. Structured data is objective facts and numbers that can be collected, exported, stored, and organized in typical databases. Some of the sources of structured data could include SQL databases and online transaction processing, or OLTP, systems that focus on business transactions, spreadsheets such as Excel and Google Sheets, online forms, sensors such as global positioning systems, or GPS, and radio frequency identification, or RFID tags, and network and web server logs. You can also easily examine structured data with standard data analysis tools and methods. Semi-structured data is data that has some organizational properties but lacks a fixed or rigid schema. Semi-structured data cannot be stored in the form of rows and columns, as in databases. It contains tags or elements or metadata, which is used to group data and organize it in a hierarchy. Some of the sources of semi-structured data could include emails, XML and other markup languages, binary executables, TCP or IP packets, zippered files, and integration of data from different sources. XML and JSON allow users to define tags and attributes to store data in a hierarchical form and are used widely to store and exchange semi-structured data. Unstructured data is data that does not have an easily identifiable structure and therefore cannot be organized in a mainstream relational database in the form of rows and columns. It does not have any particular format, sequence, semantics, or rules. Unstructured data can deal with the heterogeneity of sources and has a variety of business intelligence and analytics applications. Some of the sources of unstructured data could include web pages, social media feeds, images in varied file formats such as JPEG, GIF, and PNG, video and audio files, documents and PDF files, PowerPoint presentations, media logs, and surveys. Unstructured data can be stored in files and documents, such as a Word document, for manual analysis, or in NoSQL databases that have their own analysis tools for examining this type of data. To summarize, structured data is data that is well organized in formats that can be stored in databases and lends itself to standard data analysis methods and tools. Semi-structured data is data that is somewhat organized and relies on meta tags for grouping and hierarchy. And unstructured data is data that is not conventionally organized in the form of rows and columns in a particular format. In the next video, we will learn about the different types of file structures. As a data professional, you will be working with a variety of data file types and formats. It is important to understand the underlying structure of file formats along with their benefits and limitations. This understanding will support you to make the right decisions on the formats best suited for your data and performance needs. Some of the standard file formats that we will cover in this video include delimited text file formats, Microsoft Excel Open XML Spreadsheet, or XLSX, Extensible Markup Language, or XML, Portable Document Format, or PDF, JavaScript Object Notation, or JSON. Delimited text files are text files used to store data as text in which each line or row has values separated by a delimiter, where a delimiter is a sequence of one or more characters for specifying the boundary between independent entities or values. Any character can be used to separate the values, but most common delimiters are the comma, tab, colon, vertical bar, and space. Comma-separated values, or CSVs, and tab-separated values, or TSVs, are the most commonly used file types in this category. In CSVs, the delimiter is a comma, while in TSVs, the delimiter is a tab. When literal commas are present in text data and therefore cannot be used as delimiters, TSVs serve as an alternative to CSV format. Tab stops are infrequent in running text. Each row, or horizontal line, in the text file has a set of values separated by the delimiter and represents a record. The first row works as a column header, where each column can have a different type of data. For example, a column can be of date type, while another can be a string or integer type data. Delimited files allow field values of any length and are considered a standard format for providing straightforward information schema. They can be processed by almost all existing applications. Delimiters also represent one of various means to specify boundaries in a data stream. Microsoft Excel Open XML Spreadsheet, or XLSX, is a Microsoft Excel Open XML file format that falls under the spreadsheet file format. It is an XML-based file format created by Microsoft. In an XLSX, also known as a workbook, there can be multiple worksheets, and each worksheet is organized into rows and columns, at the intersection of which is the cell. Each cell contains data. XLSX uses the open file format, which means it is generally accessible to most other applications. It can use and save all functions available in Excel and is also known to be one of the more secure file formats as it cannot save malicious code. Extensible Markup Language, or XML, is a markup language with set rules for encoding data. The XML file format is both readable by humans and machines. It is a self-descriptive language designed for sending information over the internet. XML is similar to HTML in some respects, but also has differences. For example, an XML does not use predefined tags like HTML does. XML is platform independent and programming language independent, and therefore simplifies data sharing between various systems. Portable Document Format, or PDF, is a file format developed by Adobe to present documents independent of application software, hardware, and operating systems, which means it can be viewed the same way on any device. This format is frequently used in legal and financial documents and can also be used to fill in data such as forms. JavaScript Object Notation, or JSON, is a text-based open standard designed for transmitting structured data over the web. The file format is a language-independent data format that can be read in any programming language. JSON is easy to use, is compatible with a wide range of browsers, and is considered as one of the best tools for sharing data of any size and type, even audio and video. That is one reason many APIs and web servers return data as JSON. As we touched upon in one of our previous videos, data sources have never been as dynamic and diverse as they are today. In this video, we will look at some common sources such as relational databases, flat files and XML datasets, APIs and web services, web scraping, data streams and feeds. Typically, organizations have internal applications to support them in managing their day-to-day business activities, customer transactions, human resource activities, and their workflows. These systems use relational databases, such as SQL Server, Oracle, MySQL, and IBM DB2 to store data in a structured way. Data stored in databases and data warehouses can be used as a source for analysis. For example, data from a retail transaction system can be used to analyze sales in different regions, and data from a customer relationship management system can be used for making sales projections. External to the organization, there are other publicly and privately available data sets. For example, government organizations releasing demographic and economic data sets on an ongoing basis. Then there are companies that sell specific data. For example, point-of-sale data, or financial data, or weather data, which businesses can use to define strategy, predict demand, and make decisions related to distribution or marketing promotions, among other things. Such datasets are typically made available as flat files, spreadsheet files, or XML documents. Flat files store data in plain text format, with one record or row per line, and each value separated by delimiters such as commas, semicolons, or tabs. Data in a flat file maps to a single table, unlike relational databases that contain multiple tables. One of the most common flat file formats is CSV, in which values are separated by commas. Spreadsheet files are a special type of flat files that also recognize data in a tabular format, rows and columns. But a spreadsheet can contain multiple worksheets, and each worksheet can map to a different table. Although data in spreadsheets is in plain text, the files can be stored in custom formats and include additional information such as formatting, formulas, etc. Microsoft Excel, which stores data in an XLS or XLSX format, is probably the most common spreadsheet. Others include Google Sheets, Apple Numbers, and LibreOffice. XML files contain data values that are identified or marked up using tags. While data in flat files is flat or maps to a single table, XML files can support more complex data structures such as hierarchical. Some common uses of XML include data from online surveys, bank statements, and other unstructured data sets. Many data providers and websites provide APIs, or Application Program Interfaces, and web services, which multiple users or applications can interact with and obtain data for processing or analysis. APIs and web services typically listen for incoming requests, which can be in the form of web requests from users or network requests from applications, and return data in plain text, XML, HTML, JSON, or media files. Let's look at some popular examples of APIs being used as a data source for data analytics. The use of Twitter and Facebook APIs to source data from tweets and posts for performing tasks such as opinion mining or sentiment analysis, which is to summarize the amount of appreciation and criticism on a given subject, such as policies of a government, product, a service, or customer satisfaction in general. Stock market APIs used for pulling data such as share and commodity prices, earnings per share, and historical prices for trading and analysis. Data lookup and validation APIs, which can be very useful for data analysts for cleaning and preparing data, as well as for correlating data, for example, to check which city or state a postal or zip code belongs to. APIs are also used for pulling data from database sources, within and external to the organization. Web scraping is used to extract relevant data from unstructured sources, also known as screen scraping, web harvesting, and web data extraction. Web scraping makes it possible to download specific data from web pages based on defined parameters. Web scrapers can, among other things, extract text, contact information, images, videos, product items, and much more from a website. Some popular uses of web scraping include collecting product details from retailers, manufacturers, and e-commerce websites to provide price comparisons, generating sales leads through public data sources, extracting data from posts and authors on various forums and communities, and collecting training and testing datasets for machine learning models. Some of the popular web scraping tools include Beautiful Soup, Scrapey, Pandas, and Selenium. Data streams are another widely used source for aggregating constant streams of data flowing from sources such as instruments, IoT devices and applications, GPS data from cars, computer programs, websites, and social media posts. This data is generally time-stamped and also geotagged for geographical identification. Some of the data streams and ways in which they can be leveraged include stock and market tickers for financial trading, retail transaction streams for predicting demand and supply chain management, surveillance and video feeds for threat detection, social media feeds for sentiment analysis, sensor data feeds for monitoring industrial or farming machinery, web-click feeds for monitoring web performance and improving design, and real-time flight events for rebooking and rescheduling. Some popular applications used to process data streams include Apache Kafka, Apache Spark Streaming, and Apache Storm. RSS, or really simple syndication feeds, are another popular data source. These are typically used for capturing updated data from online forums and news sites where data is refreshed on an ongoing basis. Using a feed reader, which is an interface that converts RSS text files into a stream of updated data, updates are streamed to user devices. In this video, we will learn about some of the languages relevant to the work of data professionals. These can be categorized as query languages, programming languages, and shell scripting. Having proficiency in at least one language in each category is essential for any data professional. Simply stated, query languages are designed for accessing and manipulating data in a database, for example, SQL. Programming languages are designed for developing applications and controlling application behavior, for example, Python, R, and Java. And shell and scripting languages, such as Unix or Linux shell and PowerShell, are ideal for repetitive and time-consuming operational tasks. In the remaining video, we will examine these languages in greater depth. SQL, or Structured Query Language, is a querying language designed for accessing and manipulating information from, mostly, though not exclusively, relational databases. Using SQL, we can write a set of instructions to perform operations, such as insert, update, and delete records in a database, create new databases, tables, and views, and write stored procedures, which means you can write a set of instructions and call them for later use. Here are some advantages of using SQL. SQL is portable and can be used independent of the platform. It can be used for querying data in a wide variety of databases and data repositories, although each vendor may have some variations and special extensions. It has a simple syntax that is similar to the English language. Its syntax allows developers to write programs with fewer lines than some of the other programming languages using basic keywords such as select, insert, into, and update. It can retrieve large amounts of data quickly and efficiently. It runs on an interpreter system, which means code can be executed as soon as it is written, making prototyping quick and easy. SQL is one of the most popular querying languages. Due to its large user community and the sheer volume of documentation accumulated over the years, it continues to provide a uniform platform worldwide to all its users. Python is a widely used, open-source, general-purpose, high-level programming language. Its syntax allows programmers to express their concepts in fewer lines of code as compared to some of the older languages. Python is perceived as one of the easiest languages to learn and has a large developer community. Because of its focus on simplicity and readability and a low learning curve, it's an ideal tool for beginning programmers. It is great for performing high computational tasks in vast amounts of data, which can otherwise be extremely time-consuming and cumbersome. Python provides libraries like NumPy and Pandas, which eases the task by the use of parallel processing. It has inbuilt functions for almost all of the frequently used concepts. Python supports multiple programming paradigms, such as object-oriented, imperative, functional, and procedural, making it suitable for a wide variety of use cases. Now, let's look at some of the reasons that make Python one of the fastest-growing programming languages in the world today. It is easy to learn. With Python, you have the advantage of using fewer lines of code to accomplish tasks, compared to other languages. It is open source. Python is free and uses a community-based model for development. It runs on Windows and Linux environments and can be ported to multiple platforms. It has widespread community support with plenty of useful analytics libraries available. It has several open source libraries for data manipulation, data visualization, statistics, and mathematics, to name just a few. Its vast array of libraries and functionalities also include Pandas for data cleaning and analysis, NumPy and SciPy for statistical analysis, Beautiful Soup and Scrapey for web scraping, Matplotlib and Seaborn to visually represent data in the form of bar graphs, histogram, and pie charts, OpenSea for image processing. R is an open source programming language and environment for data analysis, data visualization, machine learning, and statistics. Widely used for developing statistical software and performing data analytics, it is especially known for its ability to create compelling visualizations, giving it an edge over some of the other languages in this space. Some of the key benefits of R include the following. It is an open source platform-independent programming language. It can be paired with many programming languages, including Python. It is highly extensible, which means developers can continue to add functionalities by defining new functions. It facilitates the handling of structured as well as unstructured data, which means it has more comprehensible data capability. It has libraries such as ggplot2 and Plotly that offer aesthetic graphical plots to its users. You can make reports with the data and scripts embedded in them. Also, interactive web apps that allow users to play with the results and the data. It is dominant among other programming languages for developing statistical tools. Java is an object-oriented, class-based, and platform-independent programming language originally developed by Sun Microsystems. It is among the top-ranked programming languages used today. Java is used in a number of processes all through data analytics, including cleaning data, importing and exporting data, statistical analysis, and data visualization. In fact, most of the popular framework and tools used for big data are typically written in Java, such as Hadoop, Hive, and Spark. It is perfectly suited for speed-critical projects. A Unix or Linux shell is a computer program written for the Unix shell. It is a series of Unix commands written in a plain text file to accomplish a specific task. Writing a shell script is fast and easy. It is most useful for repetitive tasks that may be time-consuming to execute by typing one line at a time. Typical operations performed by shell scripts include file manipulation, program execution, system administration tasks such as disk backups and evaluating system logs, installation scripts for complex programs, executing routine backups, and running batches. PowerShell is a cross-platform automation tool and configuration framework by Microsoft that is optimized for working with structured data formats such as JSON, CSV, XML, and REST APIs, websites, and Office applications. It consists of a command line shell and scripting language. PowerShell is object-based, which makes it possible to filter, sort, measure, group, compare, and many more actions on objects as they pass through a data pipeline. It is also a good tool for data mining, building GUIs, and creating charts, dashboards, and interactive reports. A data repository is a general term used to refer to data that has been collected, organized, and isolated so that it can be used for business operations or mined for reporting and data analysis. It can be a small or large database infrastructure with one or more databases that collect, manage, and store datasets. In this video, we will provide an overview of the different types of repositories your data might reside in, such as databases, data warehouses, and big data stores, and examine them in greater detail in further videos. Let's begin with databases. A database is a collection of data or information designed for the input, storage, search and retrieval, and modification of data. And a database management system, or DBMS, is a set of programs that creates and maintains the database. It allows you to store, modify, and extract information from the database using a function called querying. For example, if you want to find customers who have been inactive for 6 months or more, using the querying function, the database management system will retrieve data of all customers from the database that have been inactive for 6 months or more. Even though a database and DBMS mean different things, the terms are often used interchangeably. There are different types of databases. Several factors influence the choice of database, such as the data type and structure, querying mechanisms, latency requirements, transaction speeds, and intended use of the data. It's important to mention two main types of databases here: relational and non-relational databases. Relational databases, also referred to as RDBMSs, build on the organizational principles of flat files, with data organized into a tabular format with rows and columns following a well-defined structure and schema. However, unlike flat files, RDBMSs are optimized for data operations and querying involving many tables and much larger data volumes. Structured Query Language, or SQL, is the standard querying language for relational databases. Then we have non-relational databases, also known as NoSQL, or Not Only SQL. Non-relational databases emerged in response to the volume, diversity, and speed at which data is being generated today, mainly influenced by advances in cloud computing, the Internet of Things, and social media proliferation. Built for speed, flexibility, and scale, non-relational databases made it possible to store data in a schemaless or free-form fashion. NoSQL is widely used for processing big data. A data warehouse works as a central repository that merges information coming from disparate sources and consolidates it through the extract, transform, and load process, also known as the ETL process, into one comprehensive database for analytics and business intelligence. At a very high level, the ETL process helps you to extract data from the different data sources, transform the data into a clean and usable state, and load the data into the enterprise's data repository. Related to data warehouses are the concepts of data marts and data lakes, which we will cover later. Data marts and data warehouses have historically been relational, since much of the traditional enterprise data has resided in RDBMSs. However, with the emergence of NoSQL technologies and new sources of data, non-relational data repositories are also now being used for data warehousing. Another category of data repositories are big data stores that include distributed computational and storage infrastructure to store, scale, and process very large data sets. Overall, data repositories help to isolate data and make reporting and analytics more efficient and credible while also serving as a data archive. A relational database is a collection of data organized into a table structure, where the tables can be linked or related based on data common to each. Tables are made of rows and columns, where rows are the records and the columns the attributes. Let's take the example of a customer table that maintains data about each customer in a company. The columns or attributes in the customer table are the customer ID, customer name, customer address, and customer primary phone, and each row is a customer record. Now, let's understand what we mean by tables being linked or related based on data common to each. Along with the customer table, the company also maintains transaction tables that contain data describing multiple individual transactions pertaining to each customer. The columns for the transaction table might include the transaction date, customer ID, transaction amount, and payment method. The customer table and transaction tables can be related based on the common customer ID field. You can query the customer table to produce reports such as a customer statement that consolidates all transactions in a given period. This capability of relating tables based on common data enables you to retrieve an entirely new table from data in one or more tables with a single query. It also allows you to understand the relationships among all available data and gain new insights for making better decisions. Relational databases use structured query language, or SQL, for querying data. We'll learn more about SQL later in this course. Relational databases build on the organizational principles of flat files such as spreadsheets, with data organized into rows and columns following a well-defined structure and schema. But this is where the similarity ends. Relational databases, by design, are ideal for the optimized storage, retrieval, and processing of data for large volumes of data, unlike spreadsheets that have a limited number of rows and columns. Each table in a relational database has a unique set of rows and columns, and relationships can be defined between tables, which minimizes data redundancy. Moreover, you can restrict database fields to specific data types and values, which minimizes irregularities and leads to greater consistency and data integrity. Relational databases use SQL for querying data, which gives you the advantage of processing millions of records and retrieving large amounts of data in a matter of seconds. Moreover, the security architecture of relational databases provides controlled access to data and also ensures that the standards and policies for governing data can be enforced. Relational databases range from small desktop systems to massive cloud-based systems. They can be either open source and internally supported, open source with commercial support, or commercial closed source systems. IBM DB2, Microsoft SQL Server, MySQL, Oracle Database, and PostgreSQL are some of the popular relational databases. Cloud-based relational databases, also referred to as database as a service, are gaining wide use as they have access to the limitless compute and storage capabilities offered by the cloud. Some of the popular cloud relational databases include Amazon Relational Database Service, or RDS, Google Cloud SQL, IBM DB2 on Cloud, Oracle Cloud, and SQL Azure. RDBMS is a mature and well-documented technology, making it easy to learn and find qualified talent. One of the most significant advantages of the relational database approach is its ability to create meaningful information by joining tables. Some of its other advantages include flexibility. Using SQL, you can add new columns, add new tables, rename relations, and make other changes while the database is running and queries are happening. Reduced redundancy. Relational databases minimize data redundancy. For example, the information of a customer appears in a single entry in the customer table, and the transaction table pertaining to the customer stores a link to the customer table. Ease of backup and disaster recovery. Relational databases offer easy export and import options, making backup and restore easy. Exports can happen while the database is running, making restore on failure easy. Cloud-based relational databases do continuous mirroring, which means the loss of data on restore can be measured in seconds or less. ACID compliance. ACID stands for atomicity, consistency, isolation, and durability. ACID compliance implies that the data in the database remains accurate and consistent despite failures, and database transactions are processed reliably. Now we'll look at some use cases for relational databases. Online transaction processing. OLTP applications are focused on transaction-oriented tasks that run at high rates. Relational databases are well suited for OLTP applications because they can accommodate a large number of users. They support the ability to insert, update, or delete small amounts of data. And they also support frequent queries and updates as well as fast response times. data warehouses. In a data warehousing environment, relational databases can be optimized for online analytical processing, or OLAP, where historical data is analyzed for business intelligence. IoT solutions, Internet of Things or IoT solutions, require speed as well as the ability to collect and process data from edge devices, which need a lightweight database solution. This brings us to the limitations of RDBMS. RDBMS does not work well with semi-structured or unstructured data, and is therefore not suitable for extensive analytics on such data. For migration between two RDBMSs, schemas and type of data need to be identical between the source and destination tables. Relational databases have a limit on the length of data fields, which means if you try to enter more information into a field than it can accommodate, the information will not be stored. Despite the limitations and the evolution of data in these times of big data, cloud computing, IoT devices, and social media, RDBMS continues to be the predominant technology for working with structured data. NoSQL, which stands for Not Only SQL, or sometimes non-SQL, is a non-relational database design that provides flexible schemas for the storage and retrieval of data. NoSQL databases have existed for many years, but have only recently become more popular in the era of cloud, big data, and high-volume web and mobile applications. They are chosen today for their attributes around scale, performance, and ease of use. It's important to emphasize that the No in NoSQL is an abbreviation for not only, and not the actual word no. NoSQL databases are built for specific data models and have flexible schemas that allow programmers to create and manage modern applications. They do not use a traditional row, column, table database design with fixed schemas, and typically not use the structured query language, or SQL, to query data, although some may support SQL or SQL-like interfaces. NoSQL allows data to be stored in a schemaless or free-form fashion. Any data, be it structured, semi-structured, or unstructured, can be stored in any record. Based on the model being used for storing data, there are 4 common types of NoSQL databases: key value store, document-based, column-based, and graph-based. Key value store. Data in a key value database is stored as a collection of key value pairs. The key represents an attribute of the data and is a unique identifier. Both keys and values can be anything from simple integers or strings to complex JSON documents. Key value stores are great for storing user session data and user preferences, making real-time recommendations and targeted advertising, and in-memory data caching. However, if you want to be able to query the data on specific data value, need relationships between data values, or need to have multiple unique keys, a key value store may not be the best fit. Redis, Memcached, and DynamoDB are some well-known examples in this category. Document-based. Document databases store each record and its associated data within a single document. They enable flexible indexing, powerful ad hoc queries, and analytics over collections of documents. Document databases are preferable for e-commerce platforms, medical records storage, CRM platforms, and analytics platforms. However, if you're looking to run complex search queries and multi-operation transactions, a document-based database may not be the best option for you. MongoDB, DocumentDB, CouchDB, and Cloudant are some of the popular document-based databases. Column-based. Column-based models store data in cells grouped as columns of data instead of rows. A logical grouping of columns, that is, columns that are usually accessed together, is called a column family. For example, a customer's name and profile information will most likely be accessed together, but not their purchase history. So, customer name and profile information data can be grouped into a column family. Since column databases store all cells corresponding to a column as a continuous disk entry, accessing and searching the data becomes very fast. Column databases can be great for systems that require heavy write requests, storing time series data, weather data, and IoT data. But if you need to use complex queries or change your querying patterns frequently, this may not be the best option for you. The most popular column databases are Cassandra and HBase. Graph-based. Graph-based databases use a graphical model to represent and store data. They are particularly useful for visualizing, analyzing, and finding connections between different pieces of data. The circles are nodes, and they contain the data. The arrows represent relationships. Graph databases are an excellent choice for working with connected data, which is data that contains lots of interconnected relationships. Graph databases are great for social networks, real-time product recommendations, network diagrams, fraud detection, and access management. But if you want to process high volumes of transactions, it may not be the best choice for you, because graph databases are not optimized for large volume analytics queries. Neo4j and Cosmos DB are some of the more popular graph databases. NoSQL was created in response to the limitations of traditional relational database technology. The primary advantage of NoSQL is its ability to handle large volumes of structured, semi-structured, and unstructured data. Some of its other advantages include the ability to run as distributed systems scaled across multiple data centers, which enables them to take advantage of cloud computing infrastructure, an efficient and cost-effective scale-out architecture that provides additional capacity and performance with the addition of new nodes, and simpler design, better control over availability, and improved scalability that enables you to be more agile, more flexible, and to iterate more quickly. To summarize the key differences between relational and non-relational databases, RDBMS schemas rigidly define how all data inserted into the database must be typed and composed, whereas NoSQL databases can be schema agnostic, allowing unstructured and semi-structured data to be stored and manipulated. Maintaining high-end commercial relational database management systems is expensive, whereas NoSQL databases are specifically designed for low-cost commodity hardware. Relational databases, unlike most NoSQL, support ACID compliance, which ensures reliability of transactions and crash recovery. RDBMS is a mature and well-documented technology, which means the risks are more or less perceivable as compared to NoSQL, which is a relatively newer technology. Nonetheless, NoSQL databases are here to stay and are increasingly being used for mission-critical applications. Earlier in the course, we examined databases, data warehouses, and big data stores. Now we'll go a little deeper in our exploration of data warehouses, data marts, and data lakes, and also learn about the ETL process and data pipelines. A data warehouse works like a multi-purpose storage for different use cases. By the time data comes into the warehouse, it has already been modeled and structured for a specific purpose, meaning it is analysis ready. As an organization, you would opt for a data warehouse when you have massive amounts of data from your operational systems that need to be readily available for reporting and analysis. Data warehouses serve as the single source of truth, storing current and historical data that has been cleansed, conformed, and categorized. A data warehouse is a multi-purpose enabler of operational and performance analytics. A data mart is a subsection of the data warehouse, built specifically for a particular business function, purpose, or community of users. The idea is to provide stakeholders data that is most relevant to them when they need it. For example, the sales or finance teams accessing data for their quarterly reports and projections. Since a data mart offers analytical capabilities for a restricted area of the data warehouse, it offers isolated security and isolated performance. The most important role of a data mart is business-specific reporting and analytics. A data lake is a storage repository that can store large amounts of structured, semi-structured, and unstructured data in their native format, classified and tagged with metadata. So, while a data warehouse stores data processed for a specific need, a data lake is a pool of raw data where each data element is given a unique identifier and is tagged with meta tags for further use. You would opt for a data lake if you generate or have access to large volumes of data on an ongoing basis, but don't want to be restricted to specific or predefined use cases. Unlike data warehouses, a data lake would retain all source data without any exclusions, and the data could include all types of data sources and types. Data lakes are sometimes also used as a staging area of a data warehouse. The most important role of a data lake is in predictive and advanced analytics. Now we come to the process that is at the heart of gaining value from data, the extract, transform, and load process, or ETL. ETL is how raw data is converted into analysis-ready data. It is an automated process in which you gather raw data from identified sources, extract the information that aligns with your reporting and analysis needs, clean, standardize, and transform that data into a format that is usable in the context of your organization, and load it into a data repository. While ETL is a generic process, the actual job can be very different in usage, utility, and complexity. Extract is the step where data from source locations is collected for transformation. Data extraction could be through batch processing, meaning source data is moved in large chunks from the source to the target system at scheduled intervals. Tools for batch processing include Stitch and Blendo. Stream processing, which means source data is pulled in real time from the source and transformed while it is in transit and before it is loaded into the data repository. Tools for stream processing include Apache Samza, Apache Storm, and Apache Kafka. Transform involves the execution of rules and functions that convert raw data into data that can be used for analysis. For example, making date formats and units of measurement consistent across all source data, removing duplicate data, filtering out data that you do not need, enriching data, for example, splitting full name to first, middle, and last names, establishing key relationships across tables, applying business rules and data validations. Load is the step where processed data is transported to a destination system or data repository. It could be initial loading, that is, populating all the data in the repository. Incremental loading, that is, applying ongoing updates and modifications as needed periodically. Or full refresh, that is, erasing contents of one or more tables and reloading with fresh data. Load verification, which includes data checks for missing or null values, server performance, and monitoring load failures, are important because of this process step. It is vital to keep an eye on load failures and ensure the right recovery mechanisms are in place. ETL has historically been used for batch workloads on a large scale. However, with the emergence of streaming ETL tools, they are increasingly being used for real-time streaming event data as well. It's common to see the terms ETL and data pipelines used interchangeably, and although both move data from source to destination, data pipeline is a broader term that encompasses the entire journey of moving data from one system to another, of which ETL is a subset. Data pipelines can be architected for batch processing, for streaming data, and a combination of batch and streaming data. In the case of streaming data, data processing or transformation happens in a continuous flow. This is particularly useful for data that needs constant updating, such as data from a sensor monitoring traffic. A data pipeline is a high-performing system that supports both long-running batch queries and smaller interactive queries. The destination for a data pipeline is typically a data lake, although the data may also be loaded to different target destinations, such as another application or a visualization tool. There are a number of data pipeline solutions available, most popular among them being Apache Beam and Dataflow.
In this digital world, everyone leaves a trace. From our travel habits to our workouts and entertainment, the increasing number of internet-connected devices that we interact with on a daily basis record vast amounts of data about us. There's even a name for it: big data. Ernst & Young offers the following definition. Big data refers to the dynamic, large, and disparate volumes of data being created by people, tools, and machines. It requires new, innovative, and scalable technology to collect, host, and analytically process the vast amount of data gathered in order to derive real-time business insights that relate to consumers, risk, profit, performance, productivity management, and enhanced shareholder value. There is no one definition of big data, but there are certain elements that are common across the different definitions, such as velocity, volume, variety, veracity, and value. These are the V's of big data. Velocity is the speed at which data accumulates. Data is being generated extremely fast in a process that never stops. Near or real-time streaming, local, and cloud-based technologies can process information very quickly. Volume is the scale of the data, or the increase in the amount of data stored. Drivers of volume are the increase in data sources, higher resolution sensors, and scalable infrastructure. Variety is the diversity of the data. Structured data fits neatly into rows and columns in relational databases, while unstructured data is not organized in a predefined way, like tweets, blog posts, pictures, numbers, and video. Variety also reflects that data comes from different sources: machines, people, and processes, both internal and external to organizations. Drivers are mobile technologies, social media, wearable technologies, geotechnologies, video, and many, many more. Veracity is the quality and origin of data and its conformity to facts and accuracy. Attributes include consistency, completeness, integrity, and ambiguity. Drivers include cost and the need for traceability. With the large amount of data available, the debate rages on about the accuracy of data in the digital age. Is the information real or is it false? Value is our ability and need to turn data into value. Value isn't just profit. It may have medical or social benefits, as well as customer, employee, or personal satisfaction. The main reason that people invest time to understand big data is to derive value from it. Let's look at some examples of the V's in action. Velocity. Every 60 seconds, hours of footage are uploaded to YouTube, which is generating data. Think about how quickly data accumulates over hours, days, and years. Volume. The world population is approximately 7 billion people, and the vast majority are now using digital devices, mobile phones, desktop and laptop computers, wearable devices, and so on. These devices all generate, capture, and store data, approximately 2.5 quintillion bytes every day. That's the equivalent of 10 million Blu-ray DVDs. Variety. Let's think about the different types of data: text, pictures, film, sound, health data from wearable devices, and many different types of data from devices connected to the Internet of Things. Veracity. 80% of data is considered to be unstructured, and we must devise ways to produce reliable and accurate insights. The data must be categorized, analyzed, and visualized. Data scientists today derive insights from big data and cope with the challenges that these massive data sets present. The scale of the data being collected means that it's not feasible to use conventional data analysis tools. However, alternative tools that leverage distributed computing power can overcome this problem. Tools such as Apache Spark, Hadoop, and its ecosystem provides ways to extract, load, analyze, and process the data across distributed compute resources, providing new insights and knowledge. This gives organizations more ways to connect with their customers and enrich the services they offer. So next time you strap on your smartwatch, unlock your smartphone, or track your workout, remember your data is starting a journey that might take it all the way around the world through big data analysis and back to you.
The big data processing technologies provide ways to work with large sets of structured, semi-structured, and unstructured data so that the value can be derived from big data. In some of the other videos, we discussed big data technologies such as NoSQL databases and data lakes. In this video, we are going to talk about 3 open source technologies and the role they play in big data analytics: Apache Hadoop, Apache Hive, and Apache Spark. Hadoop is a collection of tools that provides distributed storage and processing of big data. Hive is a data warehouse for data query and analysis built on top of Hadoop. Spark is a distributed data analytics framework designed to perform complex data analytics in real time. Hadoop, a Java-based open source framework, allows distributed storage and processing of large datasets across clusters of computers. In Hadoop distributed system, a node is a single computer, and a collection of nodes forms a cluster. Hadoop can scale up from a single node to any number of nodes, each offering local storage and computation. Hadoop provides a reliable, scalable, and cost-effective solution for storing data with no format requirements. Using Hadoop, you can incorporate emerging data formats such as streaming audio, video, social media sentiment, and clickstream data along with structured, semi-structured, and unstructured data not traditionally used in a data warehouse. Provide real-time, self-service access for all stakeholders. Optimize and streamline costs in your enterprise data warehouse by consolidating data across the organization and moving cold data, that is, data that is not in frequent use, to a Hadoop-based system. One of the 4 main components of Hadoop is Hadoop Distributed File System, or HDFS, which is a storage system for big data that runs on multiple commodity hardware connected through a network. HDFS provides scalable and reliable big data storage by partitioning files over multiple nodes. It splits large files across multiple computers, allowing parallel access to them. Computations can, therefore, run in parallel on each node where data is stored. It also replicates file blocks on different nodes to prevent data loss, making it fault-tolerant. Let's understand this through an example. Consider a file that includes phone numbers for everyone in the United States. The numbers for people with last names starting with an A might be stored on server 1, B on server 2, and so on. With Hadoop, pieces of this phone book would be stored across the cluster. To reconstruct the entire phone book, your program would need the blocks from every server in the cluster. HDFS also replicates these smaller pieces into 2 additional servers by default, ensuring availability when a server fails. In addition to higher availability, this offers multiple benefits. It allows the Hadoop cluster to break up work into smaller chunks and run those jobs on all servers in the cluster for better scalability. Finally, you gain the benefit of data locality, which is the process of moving the computation closer to the node on which the data resides. This is critical when working with large data sets because it minimizes network congestion and increases throughput. Some of the other benefits that come from using HDFS include fast recovery from hardware failures, because HDFS is built to detect faults and automatically recover. Access to streaming data, because HDFS supports high data throughput rates. Accommodation of large data sets, because HDFS can scale to hundreds of nodes or computers in a single cluster. Portability, because HDFS is portable across multiple hardware platforms and compatible with a variety of underlying operating systems. Hive is an open-source data warehouse software for reading, writing, and managing large dataset files that are stored directly in either HDFS or other data storage systems such as Apache HBase. Hadoop is intended for long sequential scans, and because Hive is based on Hadoop, queries have very high latency, which means Hive is less appropriate for applications that need very fast response times. Hive is not suitable for transaction processing that typically involves a high percentage of write operations. Hive is better suited for data warehousing tasks such as ETL, reporting, and data analysis, and includes tools that enable easy access to data via SQL. This brings us to Spark, a general-purpose data processing engine designed to extract and process large volumes of data for a wide range of applications, including interactive analytics, streams processing, machine learning, data integration, and ETL. It takes advantage of in-memory processing to significantly increase the speed of computations and spilling to disk only when memory is constrained. Spark has interfaces for major programming languages, such as Java, Scala, Python, R, and SQL. It can run using its standalone clustering technology, as well as on top of other infrastructures such as Hadoop. And it can access data in a large variety of data sources, including HDFS and Hive, making it highly versatile. The ability to process streaming data fast and perform complex analytics in real time is the key use case for Apache Spark. At this stage, you have an understanding of the problem and the desired outcome. You know where you are and where you want to be. You also have a well-defined metric. You know what will be measured and how it will be measured. The next step is for you to identify the data you need for your use case. The process of identifying data begins by determining the information you want to collect. In this step, you make decisions regarding the specific information you need and the possible sources for this data. Your goals determine the answers to these questions. Let's take the example of a product company that wants to create targeted marketing campaigns based on the age group that buys their products the most. Their goal is to design reach outs that appeal most to this segment and encourages them to further influence their friends and peers into buying these products. Based on this use case, some of the obvious information that you will identify includes the customer profile, purchase history, location, age, education, profession, income, and marital status, for example. To ensure you gain even greater insights into this segment, you may also decide to collect the customer complaint data for this segment to understand the kind of issues they face, because this could discourage them from recommending your products. To know how satisfied they were with the resolution of their issues, you could collect the ratings from their customer service surveys. Taking this step forward, you may want to understand how these customers talk about your products on social media and how many of their connections engage with them in these discussions. For example, the likes, shares, and comments their posts receive. The next step in the process is to define a plan for collecting data. You need to establish a time frame for collecting the data you have identified. Some of the data you need may be required on an ongoing basis, and some over a defined period of time. For collecting website visitor data, for example, you may need to have the numbers refreshed in real time. But if you're tracking data for a specific event, you have a definitive beginning and end date for collecting the data. In this step, you can also define how much data would be sufficient for you to reach a credible analysis. Is the volume defined by the segment, for example, all customers within the age range of 21 to 30 years, or a data set of 100,000 customers within the age range of 21 to 30? You can also use this step to define the dependencies, risks, mitigation plan, and several other factors that are relevant to your initiative. The purpose of the plan should be to establish the clarity you need for execution. The third step in the process is for you to determine your data collection methods. In this step, you will identify the methods for collecting the data you need. You will define how you will collect the data from your data sources you have identified, such as internal systems, social media sites, or third-party data providers. Your methods will depend on the type of data, the time frame over which you need the data, and the volume of data. Once your plan and data collection methods are finalized, you can implement your data collection strategy and start collecting data. You will be making updates to your plan as you go along because conditions evolve as you implement the plan on the ground. The data you identify, the source of that data, and the practices you employ for gathering the data have implications for quality, security, and privacy. None of these are one-time considerations, but are relevant through the life cycle of the data analysis process. Working with data from disparate sources without considering how it measures against the quality metric can lead to failure. In order to be reliable, data needs to be free of errors, accurate, complete, relevant, and accessible. You need to define the quality traits, the metric, and the checkpoints in order to ensure that your analysis is going to be based on quality data. You also need to watch out for issues pertaining to data governance, such as security, regulation, and compliances. Data governance policies and procedures relate to the usability, integrity, and availability of data. Penalties for non-compliance can run into millions of dollars and can hurt the credibility of not just your findings, but also your organization. Another important consideration is data privacy. Data you collect needs to check the boxes for confidentiality, license for use, and compliance to mandated regulations. Checks, validations, and an auditable trail needs to be planned. Loss of trust in the data used for analysis can compromise the process, result in suspect findings, and invite penalties. Identifying the right data is a very important step of the data analysis process. Done right, it will ensure that you are able to look at a problem from multiple perspectives and your findings are credible and reliable. Data sources can be internal or external to the organization, and they can be primary, secondary, or third-party sources of data. Let's look at a couple of examples to understand what we mean by primary, secondary, and third-party sources of data. The term primary data refers to information obtained directly by you from the source. This could be from internal sources, such as data from the organization's CRM, HR, or workflow applications. It could also include data you gather directly through surveys, interviews, discussions, observations, and focus groups. Secondary data refers to information retrieved from existing sources such as external databases, research articles, publications, training material, and internet searches or financial records available as public data. This could also include data collected through externally conducted surveys, interviews, discussions, observations, and focus groups. Third-party data is data you purchase from aggregators who collect data from various sources and combine it into comprehensive data sets purely for the purpose of selling the data. Now we'll look at some of the different sources from which you could be gathering data. Databases can be a source of primary, secondary, and third-party data. Most organizations have internal applications for managing their processes, workflows, and customers. External databases are available on a subscription basis or for purchase. A significant number of businesses have or are currently moving to the cloud, which is increasingly becoming a source for accessing real-time information and on-demand insights. The web is a source of publicly available data that is available to companies and individuals for free or commercial use. The web is a rich source of data available in the public domain. These could include textbooks, government records, papers, and articles that are for public consumption. Social media sites and interactive platforms such as Facebook, Twitter, Google, YouTube, and Instagram are increasingly being used to source user data and opinions. Businesses are using these data sources for quantitative and qualitative insights on existing and potential customers. Sensor data produced by wearable devices, smart buildings, smart cities, smartphones, medical devices, even household appliances, is a widely used source of data. Data exchange is a source of third-party data that involves the voluntary sharing of data between data providers and data consumers. Individuals, organizations, and governments could be both data providers and data consumers. The data that is exchanged could include data coming from business applications, sensor devices, social media activity, location data, or consumer behavior data. Surveys gather information through questionnaires distributed to a select group of people. For example, gauging the interest of existing customers in spending on an updated version of a product. Surveys can be web or paper-based. Census data is also a commonly used source for gathering household data, such as wealth and income or population data, for example. Interviews are a source for gathering qualitative data, such as the participants' opinions and experiences. For example, an interview conducted to understand the day-to-day challenges faced by a customer service executive. Interviews could be telephonic, over the web, or face-to-face. Observation studies include monitoring participants in a specific environment or while performing a particular task. For example, observing users navigate an e-commerce site to assess the ease with which they are able to find products and make a purchase. Data from surveys, interviews, and observation studies could be available as primary, secondary, and third-party data. Data sources have never been as dynamic and diverse as they are today. They're also evolving continuously. Supplementing your primary data with secondary and third-party data sources can help you explore problems and solutions in new and meaningful ways. In this video, we will learn about the different methods and tools available for gathering data from the data sources discussed earlier in the course, such as databases, the web, sensor data, data exchanges, and several other sources leveraged for specific data needs. We will also learn about importing data into different types of data repositories. SQL, or Structured Query Language, is a querying language used for extracting information from relational databases. SQL offers simple commands to specify what is to be retrieved from the database, the table from which it needs to be extracted, grouping records with matching values, dictating the sequence in which the query results are displayed, and limiting the number of results that can be returned by the query, amongst a host of other features and functionalities. Non-relational databases can be queried using SQL or SQL-like query tools. Some non-relational databases come with their own querying tools, such as CQL for Cassandra and GraphQL for Neo4j. Application Programming Interfaces, or APIs, are also popularly used for extracting data from a variety of data sources. APIs are invoked from applications that require the data and access an endpoint containing the data. Endpoints can include databases, web services, and data marketplaces. APIs are also used for data validation. For example, a data analyst may use an API to validate postal addresses and zip codes. Web scraping, also known as screen scraping or web harvesting, is used for downloading specific data from web pages based on defined parameters. Among other things, web scraping is used to extract data such as text, contact information, images, videos, podcasts, and product items from a web property. RSS feeds are another source typically used for capturing updated data from online forums and news sites, where data is refreshed on an ongoing basis. Data streams are a popular source for aggregating constant streams of data flowing from sources such as instruments, IoT devices and applications, and GPS data from cars. Data streams and feeds are also used for extracting data from social media sites and interactive platforms. Data exchange platforms allow the exchange of data between data providers and data consumers. Data exchanges have a set of well-defined exchange standards, protocols, and formats relevant for exchanging data. These platforms not only facilitate the exchange of data, but they also ensure that security and governance are maintained. They provide data licensing workflows, de-identification and protection of personal information, legal frameworks, and a quarantined analytics environment. Examples of popular data exchange platforms include AWS Data Exchange, Crunchbase, Loadame, and Snowflake. Numerous other data sources can be tapped into for specific data needs. For marketing trends and ad spending, for example, research firms like Forrester and Business Insider are known to provide reliable data. Research and advisory firms such as Gartner and Forrester are widely trusted sources for strategic and operational guidance. Similarly, there are many trusted names in the areas of user behavior data, mobile and web usage, market surveys, and demographic studies. Data that has been identified and gathered from various data sources now needs to be loaded or imported into a data repository before it can be wrangled, mined, and analyzed. The importing process involves combining data from different sources to provide a combined view and a single interface, using which you can query and manipulate the data. Depending on the data type, the volume of data, and the type of destination repository, you may need varying tools and methods. Specific data repositories are optimized for certain types of data. Relational databases store structured data with a well-defined schema. If you're using a relational database as the destination system, you will only be able to store structured data, such as data from OLTP systems, spreadsheets, online forms, sensors, network and web logs. Structured data can also be stored in NoSQL. Semi-structured data is data that has some organizational properties, but not a rigid schema, such as data from emails, XML, zipped files, binary executables, and TCP or IP protocols. Semi-structured can be stored in NoSQL clusters. XML and JSON are commonly used for storing and exchanging semi-structured data. JSON is also the preferred data type for web services. Unstructured data is data that does not have a structure and cannot be organized into a schema, such as data from web pages, social media feeds, images, videos, documents, media logs, and surveys. NoSQL databases and data lakes provide a good option to store and manipulate large volumes of unstructured data. Data lakes can accommodate all data types and schema. ETL tools and data pipelines provide automated functions that facilitate the process of importing data. Tools such as Talend and Informatica and programming languages such as Python and R and their libraries are widely used for importing data. Data wrangling, also known as data munging, is an iterative process that involves data exploration, transformation, validation, and making it available for a credible and meaningful analysis. It includes a range of tasks involved in preparing raw data for a clearly defined purpose, where raw data at this stage is data that has been collected through various data sources in a data repository. Data wrangling captures a range of tasks involved in preparing data for analysis. Typically, it is a 4-step process that involves discovery, transformation, validation, and publishing. The discovery phase, also known as the exploration phase, is about understanding your data better with respect to your use case. The objective is to figure out specifically how best you can clean, structure, organize, and map the data you have for your use case. The next phase, which is the transformation phase, forms the bulk of the data wrangling process. It involves the tasks you undertake to transform the data, such as structuring, normalizing, denormalizing, cleaning, and enriching the data. Let's begin with the first transformation task, structuring. This task includes actions that change the form and schema of your data. The incoming data can be in varied formats. You might, for example, have some data coming from a relational database and some data from web APIs. In order to merge them, you will need to change the form or schema of your data. This change may be as simple as changing the order of fields within a record or dataset, or as complex as combining fields into complex structures. Joins and unions are the most common structural transformations used to combine data from one or more tables. How they combine the data is different. Joins combine columns. When two tables are joined together, columns from the first source table are combined with columns from the second source table in the same row. So each row in the resultant table contains columns from both tables. Unions combine rows. Rows of data from the first source table are combined with rows of data from the second source table into a single table. Each row in the resultant table is from one source table or another. Transformation can also include normalization and denormalization of data. Normalization focuses on cleaning the database of unused data and reducing redundancy and inconsistency. Data coming from transactional systems, for example, where a number of insert, update, and delete operations are performed on an ongoing basis, are highly normalized. Denormalization is used to combine data from multiple tables into a single table so that it can be queried faster. For example, normalized data coming from transactional systems is typically denormalized before running queries for reporting and analysis. Another transformation type is cleaning. Cleaning tasks are actions that fix irregularities in data in order to produce a credible and accurate analysis. Data that is inaccurate, missing, or incomplete can skew the results of your analysis and need to be considered. It could also be that the data is biased or has null values in relevant fields or have outliers. For example, you may want to find out the demographic information on the sale of a certain product, but the data you have received does not capture the gender. You either need to source this data point and merge it with your existing dataset, or you may need to remove and not consider the records with this missing field. We will explore many more examples of data cleaning further on in this course. Enriching the data is the fourth type of transformation. When you consider the data you have, to look at additional data points that could make your analysis more meaningful, you are looking at enriching your data. For example, in a large organization with information fragmented across systems, you may need to enrich the dataset provided by one system with information available in other systems, or even public datasets. Consider a scenario where you sell IT peripherals to businesses and want to analyze the buying patterns of your customers over the last 5 years. You have the customer master and transaction tables from where you've captured the customer information and purchase history. Supplementing your dataset with the performance data of these businesses, possibly available as a public dataset, could be valuable for you to understand factors influencing their purchase decisions. Inserting metadata also enriches data. For example, computing a sentiment score from a customer feedback log, collecting geo-based weather data from a resort's location to analyze occupancy trends, or capturing published time and tags for a blog post. After transformation, the next phase in data wrangling is validation. This is where you check the quality of the data post structuring, normalizing, cleaning, and enriching. Validation rules refer to repetitive programming steps used to verify the consistency, quality, and security of the data you have. This brings us to publishing, the fourth phase of the data wrangling process. Publishing involves delivering the output of the wrangled data for downstream project needs. What is published is the transformed and validated version of the input dataset along with the metadata about the dataset. Lastly, it is important to note the criticality of documenting the steps and considerations you have taken to convert the raw data to analysis-ready data. All phases of data wrangling are iterative in nature. In order to replicate the steps and to revisit your considerations for performing these steps, it is vital that you document all considerations and actions. In this video, we will look at some of the popularly used data wrangling software and tools, such as Excel Power Query or Spreadsheets, OpenRefine, Google Data Prep, Watson Studio Refinery, Trifecta Wrangler, Python, and R. Let's begin with the most basic software used for manual wrangling, spreadsheets. Spreadsheets such as Microsoft Excel and Google Sheets have a host of features and inbuilt formulae that can help you identify issues, clean, and transform data. Add-ins are available that allow you to import data from several different types of sources and clean and transform data as needed, such as Microsoft Power Query for Excel and Google Sheets Query Function for Google Sheets. OpenRefine is an open source tool that allows you to import and export data in a wide variety of formats, such as TSV, CSV, XLS, XML, and JSON. Using OpenRefine, you can clean data, transform it from one format to another, and extend data with web services and external data. OpenRefine is easy to learn and easy to use. It offers menu-based operations, which means you don't need to memorize commands or syntax. Google Data Prep is an intelligent cloud data service that allows you to visually explore, clean, and prepare both structured and unstructured data for analysis. It is a fully managed service, which means you don't need to install or manage the software or the infrastructure. Data Prep is extremely easy to use. With every edition that you take, you get suggestions on what your ideal next step should be. Data Prep can automatically detect schemas, data types, and anomalies. Watson Studio Refinery, available via IBM Watson Studio, allows you to discover, cleanse, and transform data with built-in operations. It transforms large amounts of raw data into consumable, quality information that's ready for analytics. Data Refinery offers the flexibility of exporting data residing in a spectrum of data sources. It detects data types and classifications automatically and also enforces applicable data governance policies automatically. Trifecta Wrangler is an interactive cloud-based service for cleaning and transforming data. It takes messy, real-world data and cleans and rearranges it into data tables, which can then be exported to Excel, Tableau, and R. It is known for its collaboration features, allowing multiple team members to work simultaneously. Python has a huge library and set of packages that offer powerful data manipulation capabilities. Let's look at a few of these libraries and packages. Jupyter Notebook is an open-source web application widely used for data cleaning and transformation, statistical modeling, also data visualization. NumPy, or Numerical Python, is the most basic package that Python offers. It is fast, versatile, interoperable, and easy to use. It provides support for large multidimensional arrays and matrices, and high-level mathematical functions to operate on these arrays. Pandas is designed for fast and easy data analysis operations. It allows complex operations such as merging, joining, and transforming huge chunks of data performed using simple single-line commands. Using Pandas, you can prevent common errors that result from misaligned data coming in from different sources. R also offers a series of libraries and packages that are explicitly created for wrangling messy data, such as dplyr, data table, and JSON-Lite. Using these libraries, you can investigate, manipulate, and analyze data. dplyr is a powerful library for data wrangling. It has a precise and straightforward syntax. Data table helps you aggregate large data sets quickly. JSON-Lite is a robust JSON parsing tool, great for interacting with web APIs. Tools for data wrangling come with varying capabilities and dimensions. Your decision regarding the best tool for your needs will depend on factors that are specific to your use case, infrastructure, and teams, such as supported data size, data structures, cleaning and transformation capabilities, infrastructure needs, ease of use, and learnability. According to Gartner report on data quality, poor quality data weakens an organization's competitive standing and undermines critical business objectives. Missing, inconsistent, or incorrect data can lead to false conclusions and therefore ineffective decisions. And in the business world, that can be costly. Datasets picked up from disparate sources could have a number of issues, including missing values, inaccuracies, duplicates, incorrect or missing delimiters, inconsistent records, and insufficient parameters. In some cases, data can be corrected manually or automatically with the help of data wrangling tools and scripts. But if it cannot be repaired, it must be removed from the dataset. Although the terms data cleaning and data wrangling are sometimes used interchangeably, it is important to keep in mind that data cleaning is only a subset of the entire data wrangling process. Data cleaning forms a very significant and integral part of the transformation phase in a data wrangling workflow. A typical data cleaning workflow includes inspection, cleaning, and verification. The first step in the data cleaning workflow is to detect the different types of issues and errors that your dataset may have. You can use scripts and tools that allow you to define specific rules and constraints and validate your data against these rules and constraints. You can also use data profiling and data visualization tools for inspection. Data profiling helps you to inspect the source data to understand the structure, content, and interrelationships in your data. It uncovers anomalies and data quality issues. For example, blank or null values, duplicate data, or whether the value of a field falls within the expected range. Visualizing the data using statistical methods can help you to spot outliers. For example, plotting the average income in a demographic dataset can help you spot outliers. That brings us to the actual cleaning of the data. The techniques you apply for cleaning your dataset will depend on the use case and the type of issues you encounter. Let's look at some of the more common data issues. Let's start with missing values. Missing values are very important to deal with as they can cause unexpected or biased results. You can choose to filter out the records with missing values or find a way to source that information in case it is intrinsic to your use case. For example, missing age data from a demographics study. A third option is a method known as imputation, which calculates the missing value based on statistical values. Your decision on the course of action you choose needs to be anchored in what's best for your use case. You may also come across duplicate data, data points that are repeated in your dataset. These need to be removed. Another type of issue you may encounter is that of irrelevant data. Data that does not fit within the context of your use case can be considered irrelevant data. For example, if you are analyzing data about the general health of a segment of the population, their contact numbers may not be relevant for you. Cleaning can involve data type conversion as well. This is needed to ensure that values in a field are stored as the data type of that field. For example, numbers stored as numerical data type, or date stored as a date data type. You may also need to clean your data in order to standardize it. For example, for strings, you may want all values to be in lowercase. Similarly, date formats and units of measurement need to be standardized. And there may be syntax errors, for example, white spaces, or extra spaces at the beginning or end of a string is a syntax error that needs to be rectified. This can also include fixing typos or format. For example, the state name being entered as a full form, such as New York, versus an abbreviated form, such as NY in some records. Data can also have outliers, or values that are vastly different from other observations in the dataset. Outliers may or may not be incorrect. For example, when an age field in a voter's database has the value 5, you know it is incorrect data and needs to be corrected. Now, let's consider a group of people where the annual income is in the range of $100,000 to $200,000, except for that one person who earns $1 million a year. While the data point is not incorrect, it is an outlier and needs to be looked at. Depending on your use case, you may need to decide if including this data will skew the results in a way that does not serve your use case. This brings us to the next step in the data cleaning workflow, verification. In this step, you inspect the results to establish effectiveness and accuracy achieved as a result of the data cleaning operation. You need to re-inspect the data to make sure the rules and constraints applicable on the data still hold after the corrections you made. And in the end, it is important to note that all changes undertaken as part of the data cleaning operation need to be documented. Not just the changes, but also the reasons behind making those changes, and the quality of the currently stored data. Reporting how healthy the data is a very crucial step. In this segment, data professionals share what portion of their job involves gathering, cleaning, and preparing data for analysis.
I would say a relatively big proportion of my job involves gathering, preparing, and cleaning data for analysis. I work at a company with a really great data engineering team, so I don't have to do this kind of work as much as some other data scientists do. But still, any person that is working closely with data, be they a data scientist, a data analyst, a machine learning engineer, really needs to get comfortable understanding where the data comes from. And inevitably, no data set is perfect. There's always going to be compromises or small errors. So it's really important to spend a significant portion of your time understanding the underlying data that was used to generate the data set and what some potential problems might be with that data.
My job as a CPA involves a lot of analysis. Financial statements, account activity, assessing processes, and controls. The gathering piece can be pretty simple as long as the accounting information resides in a general ledger system or a central repository where the data is easy to gather.
That's actually probably about 30% of the job is laying everything out. So when you do get into the analytics of it, you can just dive right into the meat and potatoes of it. So you need to prep the data, make sure it's accurate, make sure things are adding up, make sure you have all months of information. So for example, in a financial statement, I need to make sure that people have given me 12 months worth of bank statements and I'm not missing any data. And that if I am, that I have enough information to be able to project or to forecast or even to look back to estimate what was done in that month based on what I had. And so that is definitely helpful.
In this segment, data professionals talk about the steps they take to ensure data is reliable.
One of the essential steps to making sure your data is reliable is to run summary statistics on individual columns in your data and make sure that they're consistent with reality. So for example, if you have a column somewhere that records visits per month to a website and you run summary statistics on that column, you get the minimum, the mean, the median, the max, and you see something funky like 1 month there's negative visits or something like this, you know the data isn't reliable.
Financial information in particular must be reliable. It must be non-biased. It must be free from error. Those are just a few of the many attributes that are necessary for data to be relied upon. So doing what I call a logic check before you get into the details of a transaction. Does it make sense at a high level? If you expected top line revenue to increase, but you see that it has drastically decreased, then figure that part out first. Is my source correct? Am I running a query in the right period? Am I pulling the right general ledger account? So start there. Make sure the basic data integrity questions have been addressed first. Once we know that the data is reliable, then we can start to deep dive into the reviews and form conclusions about the financial performance based on our analysis of the data.
Before we understand statistical analysis, its relation to data analysis, and specifically data mining, let's first examine what statistics is. Statistics is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of numerical or quantitative data. It's all around us in our day-to-day lives, whether we're talking about average income, average age, or highest paid professions, it's all statistics. Today's statistics is being applied across industries for decision-making based on data. For example, researchers using statistics to analyze data from the production of vaccines to ensure safety and efficacy. Or companies using statistics to reduce customer churn by gaining greater insight into customer requirements. Now, let's look at what statistical analysis is. Statistical analysis is the application of statistical methods to a sample of data in order to develop an understanding of what that data represents. It includes collecting and scrutinizing every data sample in a set of items from which samples can be drawn. A sample in statistics is a representative selection drawn from a total population, where population is a discrete group of people or things that can be identified by at least one common characteristic for purposes of data collection and analysis. For example, in a certain use case, population may be all people in a state that have a driving license, and a sample of this population that is a part or subset of the population could be men drivers over the age of 50. Statistical methods are mainly useful to ensure that data is interpreted correctly, and apparent relationships are meaningful and not just happening by chance. Whenever we collect data from a sample, there are two different types of statistics we can run. Descriptive statistics to summarize information about the sample, and inferential statistics to make inferences or generalizations about the broader population. Descriptive statistics enables you to present data in a meaningful way, allowing simpler interpretation of the data. Data is described using summary charts, tables, and graphs, without any attempts to draw conclusions about the population from which the sample is taken. The objective is to make it easier to understand and visualize raw data without making conclusions regarding any hypotheses that were made. For example, we want to describe the English test scores in a specific class of 25 students. We record the test scores of all students, calculate the summary statistics, and produce a graph. Some of the common measures of descriptive statistical analysis include central tendency, dispersion, and skewness. Central tendency is locating the center of a data sample. Some of the common measures of central tendency include mean, median, and mode. These measures tell you where most values in your dataset fall. So, in the earlier example, the mean score, or the mathematical average of the class of 25 students, would be the sum total of the scores of all 25 students divided by 25, that is, the number of students. If you order the above dataset from the smallest score value to the highest score value of the 25 students and pick the middle value, that is, the value with 12 values to the left and 12 values to the right of a score value, that score value would be the median for this dataset. If 12 students have scored less than 75% and 12 students have scored greater than 75%, then the median is 75. Median is unique for each dataset and is not affected by outliers. Mode is the value that occurs most frequently in a set of observations. For example, if the most common score in this group of 25 students is 72%, then that is the mode for this dataset. So, you can see how looking at your dataset through these values can help you get a clearer understanding of your dataset. Dispersion is the measure of variability in a dataset. Common measures of statistical dispersion are variance, standard deviation, and range. Variance defines how far away the data points fall from the center, that is, the distribution of values. When a distribution has lower variability, the values in a dataset are more consistent. However, when the variability is higher, the data points are more dissimilar, and extreme values become more likely. Understanding variability can help you grasp the likelihood of an event happening. Standard deviation tells you how tightly your data is clustered around the mean, and range gives you the distance between the smallest and largest values in your datasets. Skewness is the measure of whether the distribution of values is symmetrical around a central value or skewed left or right. Skewed data can affect which types of analyses are valid to perform. These are some of the basic and most common used descriptive statistic tools, but there are other tools as well, for example, using correlation and scatter plots to assess the relationships of paired data. The second type of statistical analysis is inferential statistics. Inferential statistics takes data from a sample to make inferences about the larger population from which the sample was drawn. Using methods of inferential statistics, you can draw generalizations that apply the results of the sample to the population as a whole. Some common methodologies of inferential statistics include hypothesis testing, confidence intervals, and regression analysis. Hypothesis testing, for example, can be used for studying the effectiveness of a vaccine by comparing outcomes in a control group. Hypothesis tests can tell you whether the efficacy of a vaccine observed in a control group is likely to exist in the population as well. Confidence intervals incorporate the uncertainty and sample error to create a range of values the actual population value is likely to fall within. Regression analysis incorporates hypothesis tests that help determine whether the relationships observed in the sample data actually exist in the population, rather than just the sample. There are various software packages to perform statistical data analysis, such as Statistical Analysis System, or SAS, Statistical Package for the Social Sciences, or SPSS, and StatSoft. Statistics form the core of data mining by providing measures and methodologies necessary for data mining, and identifying patterns that help identify differences between random noise and significant findings. Both data mining, which we will learn more about in this course, and statistics as techniques of data analysis help in better decision making. Data mining, or the process of extracting knowledge from data, is the heart of the data analysis process. It is an interdisciplinary field that involves the use of pattern recognition technologies, statistical analysis, and mathematical techniques. Its goal is to identify correlations in data, find patterns and variations, understand trends, and predict probabilities. You'll hear about patterns and trends frequently in the context of data analysis, so let's first understand these concepts. Pattern recognition is the discovery of regularities or commonalities in data. Consider the log data for logins to an application in an organization. It contains information such as the username, login timestamp, time spent in each login session, and activities performed. When we analyze this data to gain insights into the habits or behaviors of users, for example, the time of the day when maximum users tend to log in, or user roles that typically spend the maximum hours logged into the application, or modules in the workflow application that are being used, we're examining the data, manually or through tools, to uncover patterns hidden in the data. A trend, on the other hand, is the general tendency of a set of data to change over time. For example, global warming. In the short term, like a year-on-year basis, temperatures may remain the same or go up or down by a few degrees, but the overall global temperatures continue to increase over time, making global warming a trend. Data mining has applications across industries and disciplines. For example, profiling customer behaviors, needs, and disposable income in order to offer targeted campaigns. Financial institutions tracking customer transactions for unusual behaviors and flagging fraudulent transactions using data mining models. The use of statistical models to predict a patient's likelihood for specific health conditions and prioritizing treatment. Accessing performance data of students to predict achievement levels and make a focused effort to provide support where required. Helping investigation agencies deploy police force where the likelihood of crime is higher, and aligning supply and logistics with demand forecasts. There are several techniques you can use to detect patterns and build accurate models for discovery, be it descriptive, diagnostic, predictive, or prescriptive modeling. Let's understand some of the most commonly used techniques. Classification is a technique that classifies attributes into target categories. For example, classifying customers into low, medium, or high spenders based on how much they earn. Clustering is similar to classification but involves grouping data into clusters so they can be treated as groups. For example, clustering customers based on geographic regions. Anomaly or outlier detection is a technique that helps find patterns in data that are not normal or unexpected. For example, spikes in the usage of a credit card that can flag possible misuse. Association rule mining is a technique that helps establish a relationship between two data events. For example, the purchase of a laptop being frequently accompanied by the purchase of a cooling pad. Sequential patterns is the technique that traces a series of events that take place in a sequence. For example, tracing a customer's shopping trail from the time they log into an online store to the time they log out. Affinity grouping is a technique used to discover co-occurrence in relationships. This technique is widely used in online stores for cross-selling and upselling their products by recommending products to people based on the purchase history of other people who purchased the same item. Decision trees help build classification models in the form of a tree structure with multiple branches, where each branch represents a probable occurrence. This technique helps to build a clear understanding of the relationship between input and output. Regression is a technique that helps identify the nature of the relationship between two variables, which could be causal or correlational. For example, based on factors such as location and covered area, a regression model could be used to predict the value of a house. Data mining essentially helps separate the noise from the real information and helps businesses focus their energies on only what is relevant. In this video, we will learn about some of the commonly used software and tools for data mining, such as Spreadsheets, R language, Python, IBM SPSS Statistics, IBM Watson Studio, and SAS. Spreadsheets such as Microsoft Excel and Google Sheets are commonly used for performing basic data mining tasks. Spreadsheets can be used to host data that has been exported from other systems in an easily accessible and easy-to-read format. You can pivot tables to showcase specific aspects of your data, which is vital when you have huge amounts of data to sort through and analyze. They also make it relatively easier to make comparisons between different sets of data. Add-ins available for Excel, such as the Data Mining Client for Excel, Excel Miner, and Knowledge Miner for Excel, allow you to perform common mining tasks such as classification, regression, association rules, clustering, and model building. Google Sheets also has an array of add-ons that can be used for analysis and mining, such as text analysis, text mining, and Google Analytics. R is one of the most widely used languages for performing statistical modeling and computations by statisticians and data miners. R is packaged with hundreds of libraries explicitly built for data mining operations, such as regression, classification, data clustering, association rule mining, text mining, outlier detection, and social network analysis. Some of the popular R packages include TM and Twitter. TM, a framework for text mining applications within R, provides functions for text mining. Twitter provides a framework for mining tweets. RStudio is a popularly used open-source integrated development environment, or IDE, for working with the R programming language. Python libraries like Pandas and NumPy are commonly used for data mining. Pandas is an open-source module for working with data structures and analysis. It is possibly one of the most popular libraries for data analysis in Python. It allows you to upload data in any format and provides a simple platform to organize, sort, and manipulate that data. Using Pandas, you can perform basic numerical computations, such as mean, median, mode, and range. Calculate statistics and answer questions regarding correlation between data and distribution of data. Explore data visually and quantitatively. Visualize data with help from other Python libraries. NumPy is a tool for mathematical computing and data preparation in Python. NumPy offers a host of built-in functions and capabilities for data mining. Jupyter Notebooks have become the tool of choice for data scientists and data analysts when working with Python to perform data mining and statistical analysis. SPSS stands for Statistical Process for Social Sciences. While the name suggests its original usage in the field of social sciences, it is popularly used for advanced analytics, text analytics, trend analysis, validation of assumptions, and translation of business problems into data science solutions. SPSS is closed source and requires a license for use. SPSS has an easy-to-use interface that requires minimal coding for complex tasks. It comprises of efficient data management tools and is popular because of its in-depth analysis capabilities and accurate data results. IBM Watson Studio, included in the IBM Cloud Pak for Data, leverages a collection of open-source tools such as Jupyter Notebooks and extends them with closed-source IBM tools that make it a powerful environment for data analysis and data science. It is available through a web browser on the public cloud, private cloud, and as a desktop app. Watson Studio enables team members to collaborate on projects that can range from simple exploratory analysis to building machine learning and AI models. It also includes SPSS modeler flows that enable you to quickly develop predictive models for your business data. SAS Enterprise Miner is a comprehensive graphical workbench for data mining. It provides powerful capabilities for interactive data exploration, which enables users to identify relationships within data. SAS can manage information from various sources, mine and transform data, and analyze statistics. It offers a graphical user interface for non-technical users. With SAS, you can identify patterns in the data using a range of available modeling techniques, explore relationships and anomalies in data, analyze big data, validate the reliability of findings from the data analysis process. SAS is very easy to use because of its syntax and is also easy to debug. It has the ability to handle large databases and offers high security to its users. In this video, we have learned about just a few of the data mining tools available today. Your decision regarding the best tool for your needs will be driven by the data size and structure the tool supports, the features it offers, its data visualization capabilities, infrastructure needs, ease of use, and learnability. It's fairly common to use a combination of data mining tools to meet all your needs. The data analysis process begins with understanding the problem that needs to be solved and the desired outcome that needs to be achieved. And it ends with communicating the findings in ways that impact decision-making. Data projects are the result of a collaborative effort spread across business functions involving people with multidisciplinary skills, with the findings being incorporated into a larger business initiative. The success of your communication depends on how well others can understand and trust your insights to take further action. So, as data analysts, you need to tell the story with your data by visualizing the insights clearly and creating a structured narrative explicitly targeted at your audience. Before you begin to create the communication, you need to reconnect with your audience. Begin by asking yourself these questions. Who is my audience? What is important to them? What will help them trust me? Your audience is mostly going to be a diverse group in terms of the business functions they represent, whether they play an operational or strategic role in the organization, how impacted are they by the problem, and other such factors. Your presentation needs to be framed around the level of information your audience already has. Based on your understanding of the audience, you will decide what and how much information is essential to enable a better understanding of your findings. It's tempting to bring out all the data that you've been working with, but you have to consider what pieces are more important to your audience than others. A presentation is not a data dump. Facts and figures alone do not influence decisions and move people to action. You have to tell a compelling story. Include only that information as is needed to address the business problem. Too much information will have your audience struggling to understand the point you're making. Begin your presentation by demonstrating your understanding of the business problem to your audience. It's easy to fall back on the assumption that we all know what we're here for, But reflecting your understanding of the problem that needs to be solved and the outcome that needs to be achieved is a great first step in winning their attention and starting with trust. Speaking in the language of your organization's business domain is another important factor in building a connection between you and your audience. The next step in designing your communication is to structure and organize your presentation for maximum impact. Reference the data you have collected. Remember that the data, the very basis of everything that you are communicating, is like a black box for the audience. If you're unable to establish the credibility of your data, people don't know that they can trust your findings. Share your data sources, hypotheses, and validations. Work towards establishing credibility of your findings along the way. Don't gloss over any key assumptions made during the analysis. Organize information into logical categories based on the information you have. Do you have both qualitative and quantitative information, for example? Be deliberate in taking a top-down or bottom-up approach in your narrative. Both can be effective, depends on your audience and use case. Be consistent in your approach. It's important to determine what communication formats will be most useful to your audience. Do they need to take away an executive summary, a fact sheet, or a report? How is your audience going to use the information you have presented that should determine the formats you choose? Insights must be explained in a way that inspires action. If your audience doesn't grasp the significance of your insight or are unconvinced of its utility, the insight will not drive any value. A 1,000-word essay will not have the same impact as a visual in creating a clear mental image in the minds of your audience. A powerful visualization tells a story through the graphical depiction of facts and figures. Data visualizations, graphs, charts, diagrams are a great way to bring data to life. Whether you're showing a comparison, a relationship, distribution, or composition, you have tools that can help you show patterns and conclusions about hypotheses. Data has value through the stories that it tells. Your audience must be able to trust you, understand you, and relate to your findings and insights. By establishing credibility of your findings, presenting the data within a narrative, and supporting it through visual impressions, you can help your audience drive valuable insights. In this video, we will listen to data professionals talk about the role storytelling plays in the life of a data analyst.
The role of storytelling in a data analyst's life cannot be overstated. It is super critical to get really good at storytelling with data. I think humans naturally understand the world through stories. So if you're trying to convince anyone to do anything with data, the first thing you have to do is tell a clear, concise, compelling story. I also think it can be really useful for the data analysts to develop a story anytime they're working with a data set to help themselves better understand the underlying data set and what it's doing. There's always going to be a balance between telling a clear, coherent, simple story and making sure you're conveying all the complexities that you might find within the data. And I think finding that balance can be really challenging, but is really critical.
The art of storytelling is significant in the life of a data analyst. It doesn't matter how much or what wonderful information you've come up with. If you can't find a way to communicate that to your audience, whether it's the consumer or a director level or executive level person, then it's for naught. You have to find a way to communicate that, and it's usually best to do it in a visual or through telling a story so that they understand how that information can be useful.
I have to say, storytelling is an essential skill set. It's like the last mile in delivery. A lot of people can handle the technical side through a short period of training. However, the ability to extract value from data and to communicate it is in short supply. If you think about the long-term career, I think it's very critical to know how to tell a compelling story with data.
Storytelling is absolutely crucial to data and analytics. This is how you actually convey your message. Everyone can show numbers, but if you don't have a story around it, if you don't have a compelling reason to act, then ultimately what you're presenting isn't going to resonate with your audience. They did a study at Stanford where they had people present their pitches, and in that pitch they had simply KPIs, numbers, statistics, but they also told a story. The audience members were then quizzed after the fact what they remembered from each of those presentations. And it was those stories that stuck with them. Yes, there were still facts and figures contained within the story, but that is the way that you drive it home. Having that emotional connection to the story, to the understanding, to the data is really how you're going to get people to take the action that you want and need them to take.
Data visualization is the discipline of communicating information through the use of visual elements such as graphs, charts, and maps. Its goal is to make information easy to comprehend, interpret, and retain. Imagine having to look through thousands of rows of data to draw interpretations, and compare that to a visual representation of that same data summarizing the findings. Using data visualization, you can provide a summary of the relationships, trends, and patterns hidden in the data, which, if not impossible, would be very hard to decipher from a data dump. For data visualization to be of value, you have to choose the visualization that most effectively delivers your findings to your audience. And for that, you need to begin by asking yourself some questions. What is the relationship that I am trying to establish? Do I want to compare the relative proportion of the subparts of a whole? For example, the contribution of different product lines in the total revenue of the company. Do I want to compare multiple values, such as the number of products sold and revenues generated over the last 3 years? Or do I want to analyze a single value over time, which in this example could mean how the sale of one specific product has changed over the last 3 years? Do I need my audience to see the correlation between two variables? The correlation between weather conditions and booking in a ski resort, for example. Do I want to detect anomalies in data? For example, finding values in data that could potentially skew the findings. What is the question I'm trying to answer is not just an overarching question in the data visualization design and process. You need to be able to answer this question for your audience with every data set and information that you visualize. You also need to consider whether the visualization needs to be static or interactive. An interactive visualization, for example, can allow you to change values and see the effects on a related variable in real time. So, think about the key takeaway for your audience, anticipate their information needs and the questions they might have, and then plan the visualization that delivers your message clearly and impactfully. Let's look at some basic examples of the types of graphs you can create for visualizing your data. Bar charts are great for comparing related datasets or parts of a whole. For example, in this bar chart, you can see the population numbers of 10 different countries and how they compare to one another. Column charts compare values side by side. You can use them quite effectively to show change over time. For example, showing how page views and user sessions time on your website is changing on a month-to-month basis. Although alike except for the orientation, bar charts and column charts cannot always be used interchangeably. For example, a column chart may be better suited for showing negative and positive values. Pie charts show the breakdown of an entity into its subparts and the proportion of the subparts in relation to one another. Each portion of the pie chart represents a static value or category, and the sum of all categories is equal to 100%. In this example, in a marketing campaign with 4 marketing channels, social sites, native advertising, paid influencers, and live events, you can see the total number of leads generated per channel. Line charts display trends. They're great for showing how a data value is changing in relation to a continuous variable. For example, how has the sale of your product or multiple products changed over time, where time is the continuous variable? Line charts can be used for understanding trends, patterns, and variations in data. also for comparing different but related datasets with multiple series. Data visualization can also be used to build dashboards. Dashboards organize and display reports and visualizations coming from multiple data sources into a single graphical interface. You can use dashboards to monitor daily progress or the overall health of a business function or even a specific process. Dashboards can present both operational and analytical data. For example, you could have a marketing dashboard from which you monitor your current marketing campaign for reach outs, queries generated, and sales conversions in real time. As part of the same dashboard, you could also be seeing how the conversion rate for this campaign compares to the conversion rate of some of the successfully run campaigns in the past. Dashboards are a great tool to present a bird's eye view of the complete picture while also allowing you to drill down into the next level of information for each parameter. Dashboards are easy to comprehend by an average user, make collaboration easy between teams, and allow you to generate reports on the go. Using dashboards, you can see the result of variations in data and metrics almost instantly. And this can help you evaluate a situation from multiple perspectives on the go without having to go back to the drawing board. In this video, we will look at some of the most commonly used data visualization software and tools. These include Spreadsheets, Jupyter Notebook and Python libraries, RStudio and RShiny, IBM Cognos Analytics, Tableau, and Microsoft Power BI. Some of these are end-to-end data analytics solutions, while others are specifically for data visualization, ranging from free open source tools to commercially available solutions. Spreadsheets such as Microsoft Excel and Google Sheets are possibly the most commonly used software to make graphical representations of datasets. Spreadsheets are easy to learn and have a ton of documentation and video tutorials available online for ready reference. Excel provides several chart types ranging from the basic bar, line, pie, and pivot charts to the more advanced options such as scatter charts, trend lines, Gantt charts, waterfall charts, and combination charts, using which you can combine more than one type of charts. Excel also provides recommendations on the best visual representation for your dataset. To make the charts more presentable, you can add a chart title, change colors of the elements, and add labels to data. Google Sheets also offers similar chart types for visualization, though Excel does have more inbuilt formula-based options than Google Sheets. Like Excel, Google Sheets can help you choose the right visualization. All you have to do is highlight the data you wish to visualize and click the Chart button, and you get a list of suggested charts best suited for your data. Charts and reports automatically update in Excel as well as in Google Sheets, as the underlying data is changed. Google Sheets is preferred over Excel where multiple users need to collaborate. Jupyter Notebook is an open-sourced web application that provides a great way to explore data and create visualizations. You don't have to be a Python expert to use Jupyter Notebook. Python provides a host of libraries that are used for data visualization. Let's look at a few of those libraries. Matplotlib is a widely used Python data visualization library. It provides different kinds of 2D and 3D plots and the flexibility to create plots in several different ways. Using Matplotlib, you can create high-quality interactive graphs and plots with just a few lines of code. It has a large community support and cross-platform support as it is an open-source tool. Bokeh provides interactive charts and plots and is known for delivering high-performance interactivity over large or streaming datasets. Bokeh offers flexibility for applying interaction, layouts, and different styling options to visualize. It can also transform visualizations written in some of the other Python libraries, such as Matplotlib, Seaborn, and ggplot. Dash is a Python framework for creating interactive web-based visualizations. Using Dash, you can build highly interactive web applications using Python code. While knowledge of HTML and JavaScript is useful, it is not a requirement. Dash is easily maintainable, cross-platform, and mobile-ready. Using RStudio, you can create basic visualizations such as histograms, bar charts, line charts, box plots, and scatter plots, and advanced visualizations such as heat maps, mosaic maps, 3D graphs, and correlograms. Shiny is an R package that helps build interactive web apps that you can host as standalone apps on a web page. These web apps seamlessly display R objects, such as plots and tables, and can be made live to allow access to anyone. You can also build dashboards using Shiny. The ease of working with Shiny is what popularized it among data professionals. IBM Cognos Analytics is an end-to-end analytics solution. Some of the visualization features provided by Cognos include importing custom visualizations, a forecasting feature that provides time series data modeling and forecasts based on data presented in corresponding visualizations, recommendation for visualizations based on your data, conditional formatting, which allows you to see the distribution of your data and highlight exceptional data points. For example, highlighting high and low sales numbers over a certain threshold. Cognos is known for its superior visualizations and overlaying data on the physical world using its geospatial capabilities. Tableau is a software company that produces interactive data visualization products. Using Tableau products, you can create interactive graphs and charts in the form of dashboards and worksheets with drag-and-drop gestures. Tableau also offers the option to publish results in the form of stories. You can import R and Python scripts in Tableau and take advantage of its visualization features that are far more superior to that of other languages. Tableau's visualization capabilities are easy and intuitive to use. Tableau is compatible with Excel files, text files, relational databases, and cloud database sources such as Google Analytics and Amazon Redshift. Power BI is a cloud-based business and analytics service from Microsoft that enables you to create reports and dashboards. It is a powerful and flexible tool known for its speed and efficiency, and an easy-to-use drag-and-drop interface. Power BI is compatible with multiple sources, including Excel, SQL Server, and cloud-based data repositories, which makes it an excellent choice for data professionals. Power BI provides the ability to collaborate and share customized dashboards and interactive reports securely, even on mobiles. Power BI's dashboard consists of many visualizations on a single page that help you tell your story. These visualizations, called tiles, are pinned to the dashboard. The dashboard is interactive, which means a change in one tile affects the other. When deciding which tools to use, you need to consider the ease of use and purpose of the visualization. In terms of the tools that are available and the visualization capabilities they offer, if you can visualize it, you can create it. In this video, data professionals talk about the visualization tools they rely on the most and why.
The visualization tool that I rely on most in my day-to-day life is Cognos Analytics. There's a few reasons for this. One, it allows me to very quickly import a spreadsheet, connect to a database, and visualize my data, whether that's me understanding what I want to look at and dragging the fields on, or using our AI assistant to present the data to help me understand and explore what might be interesting in there if it's a new data set I've never worked with before. Now, on top of that, I can also go ahead and start to do some more complex things, or even just some more robust analysis with our reporting tool to allow me to build out and schedule reports for delivery. If I wanted my sales team to have their pipeline report or their sales opportunity report every Monday morning, set that up once, use what we call burst key, and then have that sent out automatically every Sunday night. So it's waiting for them in the morning. On top of this, I can start to combine multiple data sources and have the system help me create those joins together and then be able to visualize those all on a single, simple dashboard that's highly interactive, allowing you to filter and sort dynamically, as well as share that out with the rest of my organization so that not every user has to go through the same experience. We've set up the dashboard once, everyone can then have access to it.
In terms of visualization tools, I rely the most on Looker, which is a data visualization tool that sits atop my company's internal database. It's similar to Tableau, which I've also used in the past and find pretty easy to use. And the great thing about these data visualization tools like Looker and Tableau is they let everyone throughout the organization, regardless of whether or not they're data professionals, easily kind of see their data and do basic aggregation or sorting on it. A data visualization tool I really rely on for exploratory data analysis is R. I've been a big convert in recent years to the effectiveness of doing basic data analysis and data visualization in R, particularly using the tidyverse, which is a collection of packages that help you really easily load in your data, aggregate it at different levels, and also quickly and easily visualize it.
Tableau and Power BI, no-brainer. They're easy to pick up and very helpful to demonstrate data. And as more and more companies and people start to utilize them, there are more and more built-in templates and libraries.
I would say the visual cues would probably be Excel and Word, just the Microsoft suite, and just looking at and using the sums and the macros to make sure that the data, before I even dive in, that it's clean and that it makes sense and that it is prepped for what we need it to be.
Data analyst job openings exist across industry, government, and academia. Every industry, be it banking and finance, insurance, healthcare, retail, or information technology, has space for skilled data analysts. These roles are as sought after in large businesses as they are in startups and new ventures. According to Forbes, the global big data analytics market that stood at $37.34 billion in 2018 is expected to grow at a compound annual growth rate of 12.3% from 2019 to 2027 to reach $105.08 billion by the year 2027. Currently, the demand for skilled data analysts far outweighs the supply, which means companies are willing to pay a premium to hire skilled data analysts. There's a wide variety of job roles available for data analysts. To understand the career paths open to you, we will broadly classify the roles into data analyst specialist roles and domain specialist roles. Data analyst specialist roles are for data analysts who want to stay focused and grow in the technical and functional aspects of their role. On this path, you could be starting your career as an associate or junior data analyst and work your way up through analyst, senior analyst, lead analyst, and principal analyst roles. The boundaries between these roles, the years of experience that qualify you for the next level, and the nature of experience you need to gain to move up could vary depending on the industry, the size of the organization, and how big your team is. In smaller teams, for example, you could be gaining experience in all facets of data analysis, from gathering data all the way through to visualizing and presenting your findings to stakeholders. And this may happen within a short span of time. In larger teams and organizations, roles may typically be bifurcated based on activity, which means you could be gaining experience in one specific phase of the process before you move to the next. This helps you hone your skills in one part of the process before you move to the next. On your journey from an associate data analyst to a lead or principal data analyst, you will be continually advancing your technical, statistical, and analytical skills from a foundational level to an expert level. You will be demonstrating your ability to work with a wide-ranging set of tools and platforms, different aspects of the data analysis process, and a wide variety of use cases. In terms of technical skills, you may start off knowing just one querying tool and programming language, any one type of data repository, or a limited set of visualization tools. As you gather more experience, you're expected to learn and demonstrate your ability to work with more and more tools, languages, data repositories, and newer technologies. Your communication skills, presentation skills, stakeholder management skills, and project management skills all need to be honed and taken up a notch progressively. As a lead or principal analyst, you may also be responsible for establishing processes in your team, making recommendations for software and tools the team should work on, upskilling the team, and expanding the team to include more profiles. In some organizations, these responsibilities could be aligned with a manager-level person who has risen through the ranks to manage a team of data analysts. Domain specialists, also known as functional analysts, are analysts who acquire specialization in a specific domain and are seen as an authority in their domain, such as HR, healthcare, sales, finance, social media, or digital marketing. They may not be the most technically skilled people. These roles carry titles such as HR analyst, marketing analyst, sales analyst, healthcare analyst, or social media analyst. And then there are the analytics-enabled job roles. These include roles such as project managers, marketing managers, and HR managers. These are jobs where analytics skills lead to greater efficiency and effectiveness. A fair amount of the data analyst job openings are analytics-enabled, as more and more organizations rely on data for decision-making. As a data analyst, you also have options for exploring and learning new skills to gain entry into other data professions, such as data engineering or data science. For example, if you're starting off as a junior data analyst and really like working with data lakes and big data repositories, you can acquire further expertise in these technologies and evolve your career into becoming a big data engineer. If the business side of things excite you more, you could similarly explore the skills required for making a lateral move into business analytics or business intelligence analytics. While the data analyst career landscape is very vast, the good thing is that you have a plethora of resources available to help you grow. To be successful in your journey as a data analyst, all you need to do is grab the opportunities you want to pursue or the ones that present themselves to you and learn along the way. In this video, we will listen to data professionals talk about how they got into this profession.
My current role as a data professional did not exist before I took the position. I realized that there was a need in our company to provide data in a faster, more efficient manner than going to the IS department, who would have a meeting to discuss the meeting, to have requirements, and then they would have an end product that people weren't satisfied with, but you had to get at the end of the line and go through the whole process again to get what you were looking for. So through filling a need at the company to provide reports in 2 weeks, I put together a company database that has access to more information. We have analysts that are now able to meet that unmet need in the company.
I got into the data professional role by chance. I was actually working on my PhD in economics at University of Illinois, Urbana-Champaign, when a colleague of mine suggested that a master's in statistics would also be an excellent value add. So that's how I got into the statistics program as well in Illinois. But once I started that, I was pretty hooked and there was no going back, so to speak. So in other words, my original goal of becoming an economist actually evolved into a career filled with data, modeling, analytics, insight gathering, communication, visualization, and of course, underlying all of that, data-driven problem solving.
I got into the data analyst role in a financial data company actually by accident. Back then, my company started to hire equity data analysts in mainland China, and I was very lucky to join the team because they are looking for someone with financial analysis skill sets, which I can bring to the table. And after that, my team started to hire someone with technical skill sets like Python, R, and SQL.
I've always had a love of numbers. And one of the things that happens is when you work with numbers so much, they start to tell a story. And the ability to look at those numbers and tell that story is what speaks to me. And so having always had that love of numbers, I have just been always attracted to data analytics. And whether it's Excel spreadsheets or whether it is QuickBooks or any sort of data sets that can help drive the information that we're looking for, especially in the financial industry when we're looking at profit and loss and balance sheet and what happens when one company buys another company. We're always looking at that data to talk to and speak about the company's history and their future.
I got my current role as a data scientist straight out of my grad program, which was a master's in data science. And before my grad program, I worked as both a data analyst and an analytics manager.
In this video, we will listen to data professionals talk about what employers look for in a data analyst.
Employers look for data analysts with integrity. During the hiring process, I will ask, if you had to choose just one, would you rather meet a deadline or get a right answer? And I'm always looking for someone who would say, I want to make sure that the information is right. Missing a deadline isn't as detrimental as a company making a multi-million-dollar decision on wrong information or someone losing their job because it wasn't pulled or it wasn't reported correctly. So it's much more important to have integrity.
I think the number one thing employers look for in data analysts is someone who can communicate clearly. If you do the most brilliant analysis in the world, but you can't communicate it to external stakeholders, then it's really not worth anything. So I think that that skill is really sought after. I think another thing that companies obviously look for when they look for data analysts is fluency with numbers, ability to understand complex analyses, ability to understand A/B tests and what the results of A/B tests are saying and the implication of those results. I also think increasingly employers are looking for data analysts with really strong SQL skills. Another thing employers are looking for in data analysts is a growth mindset and willingness to learn because the industry is changing at a really fast pace.
I think they're looking for the programming skills, including Python, R, SQL, and at the same time, they're looking for some personalities. Whether you are detail-oriented, whether you like working with data, and whether you are a problem solver, so on and so forth.
As an employer, I hire people all the time. What am I looking for? We are looking for people who are detail-oriented and who are somewhat overachievers. They don't just want to do what's in front of them. They want to go further. And so we're looking for people who have higher aspirations and who also are able to think outside the box and aren't just going to, if I say do ABC, they're not just going to do that. They're going to do it plus. They're going to do it plus think and give me some alternatives. People who are able to troubleshoot. If something goes wrong, they're not just going to stop and say, oh my goodness, I need to go talk to my supervisor. They're going to say, here's a problem. Here's my thoughts. Here are two possible solutions on how you can resolve this so that the job and the company can keep moving forward. That's what you want. So not just detail oriented and not just good with numbers, you also have to be someone who can think outside the box and be able to problem solve and troubleshoot. That's what employers are going to be looking for now more than ever.
They look for the ability to know data. And by know data, we mean several things, right? Be comfortable with it in various formats, be able to think about it. And by that, we mean know what kind of data you want to solve the problems that are at hand. So the knowing the data skill is very important. Problem solving is another very key skill, meaning if there is a problem presented to a data analyst, they should be able to know how to tackle that problem using data in whatever format it may be sitting in, and being able to analyze it and present the insights that will then solve the problem. They also need to be very dynamic in that if they are presented with a very different kind of data set suddenly, which looks nothing like it did before, they need to be able to adapt to that change. So that's why the quality of being dynamic and adaptable is also important. They also need to be able to pick up technical skills quickly. And by that we mean if there is one kind of SQL paradigm being used in one setting, they need to be able to operate under a different paradigm. If there is a place that's using RStudio but they know Python, they need to be able to pick up RStudio quickly, and that kind of thing. So being able to learn fast, being dynamic, and knowing data, those are the few things that employers do look for in a good data analyst.
There are various paths you can take to gaining entry into the data analyst field. While some employers may ask for an academic degree as a prerequisite, even if you don't have a degree, you still have several options available to you that can help you gain an entry, or even make a lateral move into the field of data analysis. Let's start with the most obvious path. An academic degree in data analytics, statistics, computer science, management information systems, or information technology management can start you off with a strong advantage. You could alternately enroll in online training programs that can equip you with the required knowledge. Comprehensive online programs for data analysis are multi-course specializations offered by learning platforms such as Coursera, edX, and Udacity. These courses are designed and delivered by some of the world's best domain experts. Since you have a fair idea by now of the technical, functional, and soft skills you need in order to be a data analyst, choosing the right learning path should be fairly straightforward. As you gather more work experience, you can keep advancing your knowledge and skills in specific areas. For example, statistics, spreadsheets, SQL, Python, data visualization, problem solving, storytelling, or making impactful presentations. These courses also give you hands-on assignments and projects, which give you a feel for the real-world application of your knowledge and skills. You can even add these projects to your portfolio. So, if you don't have an academic qualification, these courses can help you gain opportunities at an entry level and work your way up as your experience grows. Now let's look at a scenario where you have a couple of years of experience in a different line of work and want to make a switch into the data analysis field. There's a very good chance that you can do that successfully if you plan well. Since data analysis is a vast field, it would be useful for you to first research the knowledge and skills you need, the various job opportunities that are available, and the growth opportunities available on the path you may be considering. You can tap into online resources, forums, and your network of friends and colleagues to connect with people in this field and gain insights into real-world scenarios. If you're currently working in a non-technical role, you may consider exploring the domain specialist or functional analyst path. If you're in sales, you could consider starting your journey by positioning and skilling yourself for a sales analyst position. You begin with the advantage of industry experience and skill yourself in other areas such as statistics and programming, for example. If you're currently working in a technical role, you have the ability to quickly pick up the tools and software you need for the data analyst role. You're also probably stepping in with the advantage of having a good understanding of the domain or industry you're from. For some of the other skills, such as problem solving, project management, communication, and storytelling, you may already be using these in some capacity in your existing job. You can always enhance these skills through trainings, online courses, communities of practice, and forums. Data analysis is a fast-moving field. If you're curious, open to learning new things, and excited about the field, you will be able to forge a path forward, regardless of the formal qualifications you think you may be missing. In this video, we will listen to practicing data professionals talk about the various career options available in this field.
The whole data-related profession today has also become very colorful, very dynamic, evolving all the time, and it also presents a lot of range of options to anyone who wants to enter the field of being a data professional. So it ranges from, if you were to think of various circles as options, starting with a data analyst, right? From there you can upskill a lot more, become a data scientist. You can also become a statistician, which is what I was when I first started off. You can then further specialize yourself in a specific direction of data in order to become a data engineer, or you can start by being a BI analyst or a specialist and then go to become a data engineer. So in other words, either you can do a track of data analyst and data scientist, or you can do a track of a BI analyst and a data engineer. So those are kind of parallel tracks within the data profession. You can then also go to the other extreme where you can become a machine learning engineer, an AI engineer, and so on. So there are many such roles, many such roles that anyone interested in the field of data can really take on.
A few of the most common career options available to data analysts is to get deeper into the weeds with machine learning and engineering, and become a data scientist or a machine learning engineer that focus more on machine learning modeling. Another career option available to data analysts is to dive deeper into the business they're in and to inform top-level company strategy. I think that role is really important and interesting and has really evolved in recent years. Another path for a data analyst is to start to become a people manager and manage other data analysts and work to triage what gets worked on, because there's always going to be more questions in the organization that can be answered with data than there are people to answer them. So a data manager role can be really interesting and critical in terms of making sure the most important pieces of work actually do get worked on.
You can be a bookkeeper, you can be an accountant, you could be a CPA, you could be a stockbroker, or a financial analyst for the government, or a lot of large companies. You could be a real estate broker. Lots of people are great data analysts, but to do that, you do have to really like numbers and you have to be really detail oriented. If that's not you and numbers don't jump off the page at you, data analyst might not be the right thing for you.
In this video, we will listen to data professionals giving advice to aspiring data analysts.
One piece of advice I'd give to aspiring data analyst is keep learning and don't get discouraged. There is more that's been written about analytics than you could ever learn in a lifetime. So don't try to learn everything at once, but take your time and make sure every week, every month, every year, you're constantly learning something new. And I think that'll serve you well. One piece of advice I've been given in my career that I found to be really, really helpful is to consider your career like an uppercase T. And you should have broad knowledge. The top of the T represents kind of that you should have broad knowledge in a number of different areas, although it doesn't have to be deep. You should know a little bit, at least, about A/B testing, about machine learning, about data visualization, about SQL, about Python, about R. And then the bottom part of the T is you should go really deep on at least one area. So there should be one area among the ones I just mentioned where you have a really deep, rigorous understanding of it.
It is use every job that you have to your advantage, meaning something can be found from everything. So whether it is looking at your parents' budget or asking your parents if you can see the checkbooks, or if you work at a fast food restaurant, looking at the numbers. How many people are coming in? How many dollars are being turned over? Talk to the manager about what's next, what the numbers actually mean. When you're talking to potential employers, have your examples ready. So it doesn't have to necessarily be just work experience, but your life experience. How have you used analytics even in your personal life? So if you can tell me and talk to me about what you've done personally or professionally and how it relates to what we're doing, that will take you a very, very long way.
One piece of advice I'd give to aspiring data scientists is to build out a professional portfolio that showcases your data science or data analytics skills. And you can do this by looking up fun data sets online and analyzing those data sets. You can also do that within your job. Even if your current job isn't to be a data analyst, look for opportunities where you can crunch numbers, and then that'll just kind of naturally lead you to a nice portfolio or nice wins in terms of data analyst projects.
My advice to an aspiring data analyst is to follow your passion. Find a job that meets your needs and gives you joy during doing it. There's nothing worse than waking up every morning and hating to go to your place of employment. There are so many data analyst jobs in various industries, departments. There's just so many options that there's no need to take a job just to have a job. Find something that really fuels your passion and gives you something to get up every morning for.
In this video, we will listen to women share their experience of being a data professional and their advice to women aspiring to enter this field.
As a woman in data science, I still run up against the stereotype that this is a man's job. I've walked into meetings and had people look disappointed or confused. I take that as an opportunity to prove them wrong. This isn't a job just for men. It's for a person who has the insight, the ability, and the drive to get the job done. And as long as you possess those skills, then there's no reason why anyone can't do anything that they put their mind to. Whether you're a male or a female, whether you're white or black, you have the opportunity to prove people wrong by the work that you produce.
I would say it can be tough, but you have to find your voice and don't be afraid to use it. A lot of times as women, we're not able to find our voice or speak up, or we're afraid of how people are going to treat us if we speak up. But, it's more important that you be heard and seen, not just being loud and wrong, but if you have the data to back it up, if you have good content and things you want to say, don't be afraid to raise your hand and let people know that you are a thinker and that you can get this done, because that's going to be important as you progress. And the only real way to get ahead is drive, and people don't know you have drive if you're too quiet. And so if you're just quietly working away in the corner, a lot of times people can't see it. So speak up. Make sure your voice is being heard. Make sure you are being seen as a woman who knows how to grow and how to help in the data science field.
When I started, it was mostly men in my class, especially back in grad school. But now I'm seeing that data teams, both data science and data engineering teams, are filled with a lot of women as well. So I would advise women to continue upskilling, so that they're able, if they are fond and if they like, a career filled with programming, data, and problem solving, then they should continue building their technical skill set so that they can represent themselves in the landscape of a data professional as strongly as is possible.
Don't allow your gender to be a crutch. Still go hard, put in the work, and show the world your amazing talents. There are no roles that are set aside for specific genders. If you're fortunate enough to work in a profession that you thoroughly enjoy, then go for it.
To learn how to use spreadsheets and start analyzing data using Excel. This course from IBM is designed to help you work with Excel and gives you a good grounding in the cleaning and analyzing of data, which are important parts of the skill set required to become a data analyst. You will not only learn data analysis techniques using spreadsheets, but also practice using multiple hands-on labs throughout the course. In Module 1, you will learn about the basics of spreadsheets, including spreadsheet terminology, the interface, and navigating around worksheets and workbooks. In Module 2, you will learn about selecting data, entering and editing data, copying and autofilling data, formatting data, and using functions and formulas. In Module 3, you will learn about cleaning and wrangling data using a spreadsheet, including the fundamentals of data quality and data privacy, removing duplicated and inaccurate data, removing empty rows, removing data inconsistencies and white spaces, and using the flash fill and text-to-columns features. In Module 4, you will learn about analyzing data using spreadsheets, including filtering data, sorting data, using common data analysis functions, creating and using pivot tables, and creating and using slicers and timelines. At the end of this course, in Module 5, you will complete a series of hands-on labs which will guide you on how to create your first deliverable as a data analyst. This will involve you understanding what the business scenario is, cleaning and preparing your data, and analyzing your data. You will follow 2 different business scenarios throughout the course, with each using their own data set. These different scenarios and data sets will be used in the lesson videos and in the hands-on labs. After completing this course, you will be able to understand how spreadsheets can be used as a data analysis tool, understand when to use spreadsheets as a data analysis tool and their limitations, create a spreadsheet and explain its basic functionality, perform data wrangling and data cleaning tasks using Excel, analyze data using filter, sort, and pivot table features within Excel spreadsheets. You will also perform some intermediate level data wrangling and data analysis tasks to address a business scenario. The course team and other peers are available to help in the course discussion forums in case you require any assistance. Let's get started with your next video where you will get an introduction to spreadsheets. In this first video of the course, We will list some of the common spreadsheet applications available, learn about key capabilities of spreadsheets, and discuss why spreadsheets might be a useful tool for a data analyst. There are several spreadsheet applications available in the marketplace. Some of them are more widely known and used than others, and some are free, while others need to be paid for. By far, the most commonly used spreadsheet application, and the most fully featured of them all, is Microsoft Excel. The desktop version comes in a paid form as part of the Office suite and some Microsoft 365 subscriptions. But there is also a web-based cut-down version called Excel for the Web, also known as Excel Online. The online version is free to users with a Microsoft account, but does not offer all the advanced features that the desktop version provides. The next most popular is Google Sheets, which offers a lot, though not all, of the features that Excel provides, and is free with a Google account. This is a web-based application, and it integrates nicely with other Google apps, such as Google Forms, Google Analytics, and Google Data Studio. Then there is LibreOffice Calc, a totally free and open-source desktop spreadsheet application that offers more basic functionality than Excel or Google Sheets, but still has a lot of the tools you need for data analysis, such as charts, conditional formatting, and pivot tables. Other spreadsheet apps include Zoho Sheet, a fully featured web-based application that is comparable with Google Sheets, OpenOffice Calc, Quip for Salesforce, Smartsheet, which is predominantly for project management, and Apple Numbers, which is included with Apple devices such as Mac computers and is also available on the App Store for other Apple devices. So there are many spreadsheet application options open to you, from fully featured to basic, from cloud-based to desktop apps, from paid-for to free versions. It's up to you to decide which one fits your needs and your budget. Spreadsheets provide several advantages over manual calculation methods. For example, once you have your formulas correctly written, you can be assured that your calculations are accurate and that the calculations will be performed automatically for you. Spreadsheets also help keep your data organized and easily accessible. Your data can be easily formatted, filtered, and sorted to suit your needs. If you do make mistakes in your data entry or your calculations, you can easily edit them, undo them, or use error-checking tools to help remedy those mistakes. And lastly, you can analyze data in spreadsheets and create charts, graphs, and reports to help visualize your data analysis. Since spreadsheet software for personal computers first appeared on the market in the 1970s with VisiCalc on the Apple II PC, spreadsheets have come a long way in terms of the capabilities and features they now offer businesses. From uncomplicated tables and relatively simple computations to powerful tools for analysis, management, and visualization of enormous sets of data. The most common business uses for spreadsheet applications include the following: data entry and storage, comparing large data sets, modeling and planning, charting, identifying trends, flowcharts for business processes, tracking business sales, financial forecasting, statistical analysis, profit and loss accounting, budgeting, forensic auditing, payroll and tax reporting, invoicing, and scheduling. And away from the business side of things, other typical uses include personal expenses, household budgeting, recipe library, fitness tracking, calorie counting and weight monitoring, sports leagues such as fantasy football, cataloging music libraries, and even contact lists, shopping lists, and Christmas card lists. As a data analyst, you can use spreadsheets as a tool for your data analysis tasks, including collecting and harvesting data from one or more distributed and different sources, cleaning data to remove duplicates, inaccuracies, errors, and resolve missing values to improve the quality of the data, analyzing data by filtering, sorting, and interpreting it to determine what useful information can be gleaned from it, and visualizing data to help you tell a story about your data analysis findings to key business stakeholders and any other interested parties within your organization. In this video, we had an introduction to spreadsheets. We learned about some common spreadsheet applications, what the main capabilities of spreadsheets are, and why spreadsheets might be a useful tool for a data analyst. In the next video, we will look at the basics of spreadsheets, including common spreadsheet terminology. Now that we have a basic understanding of what spreadsheet software is available and why spreadsheets might be a useful tool for a data analyst, let's get started on looking at some of the basics of using a spreadsheet application. In these videos, we will be using the full desktop version of Excel, but the majority of the tasks that we will perform can also be done using Excel Online and other spreadsheet applications such as Google Sheets. Let's first cover some basic spreadsheet terminology. When you open Excel, you have the option of creating a new blank workbook or opening an existing workbook. We're going to choose New and then Blank Workbook. Workbooks are the highest level component in Excel and are represented as a .xlsx file. So when you open an existing workbook or create a new workbook, you are in fact working with a .xlsx file. The workbook contains all your data, calculations, and functions, and contains several other underlying elements that make up a workbook. A workbook consists of one or more worksheets, each of which is represented by a tab in Excel. Each worksheet is given a name which is displayed on the corresponding tab for the worksheet. By default, each tab is named Sheet 1, then Sheet 2, and so on. To make these worksheet tabs more meaningful, it is usual to rename them so they make more sense in relation to the worksheet's purpose. For example, you might call a worksheet January Sales, or perhaps the name of a region or store, or even an office or department. To do this, right-click the tab and choose Rename. Instead of right-clicking to rename, you can also just double-click the name of a worksheet tab to rename it. Essentially, worksheet tabs can be named anything you want to fit your particular needs to make it easier to understand what that worksheet represents. Note that a worksheet that is highlighted as the Tire Sales Worksheet tab is here is referred to as the active worksheet. If you want to order your worksheets in a different way, that is very simple to do. Either drag a worksheet tab to the left or right and drop it in the place you want, which is represented by the little black arrow. Or if you are not comfortable with dragging and dropping, then the longer way of doing that is to right-click the worksheet tab, select Move or Copy, and then in the list titled Before Sheet, select where you want your worksheet tab to be placed and click OK. Every worksheet is made up of a lot of rectangular boxes called cells. These cells will contain your data, which may be text, numbers, formulas, or calculation results. Cells are organized in columns, which run vertically down the screen and use a letter system. This is column B, for instance. And rows, which run horizontally across the screen and use a numeric system. This is row 7, for example. Each cell is represented by a cell reference, which is essentially just a column letter and row number. For example, if we click somewhere near the center of this worksheet, we now have the cell M20 selected. This is usually referred to as the active cell. This is not only indicated by the highlighted edges of the cell, but also if you look in the top left corner of the worksheet, you will see its cell reference is noted in the little box. Here you can see it says M20. One important thing to note here is that cells are always referenced by their column letter first, then their row number. So column M and row 20. The last element of a workbook I want to mention is a cell range. This identifies a collection of several cells selected together that could mean a few cells in the same row or the same column, or it could mean several rows and columns together. This can either be done using the mouse by selecting the first cell, then dragging down or across to include other cells, or you can use Shift plus arrow keys. This range of cells is often referred to as an array, and it's most commonly used as a reference in calculations and formulas. For example, if you want to add up all the values in a column between cells D9 and D19, you would specify this cell range within a formula. Note that cell ranges are notated using a full colon between the cell references. So in this example, it would be D9 colon D19. Or to specify a few cells in the same row, it might be D9 colon H9. Or to select several rows and columns, it might be D9 colon H19. We will see this notation in use later in the course when we start looking at calculations and formulas. These cell ranges could even be a reference point to cells contained on another worksheet. This is usually referred to as a 3D reference. We can now close this workbook, and we don't need to save it. In this video, we learned about some of the basic terminology of spreadsheet elements. In the next video, we will discuss how to navigate around a spreadsheet, how to use the ribbon and menus, and how to select data. Now that we have a basic understanding of the main elements that make up a worksheet, let's see how to move around a spreadsheet, get familiar with the ribbon and menus, and learn how to select data in a worksheet. To open a sample file, we click File. This opens Backstage View. Here you can create a new workbook, or open, save, or print a workbook. You can also access Excel options. Now we want to open our sample file, so we click Open and either select it from My Recent list or click Browse to find the data file we want. The first thing we should do is get acquainted with the ribbon and menus. Notice that on the ribbon at the top we have several tabs. Some of these tabs may be familiar to you with other Office products, such as the Home, Insert, and View tabs, while others might be new to you, such as Formulas, Data, and Power Pivot. To make a little more workspace for ourselves, we can hide this ribbon by double-clicking any tab, and to unhide it, we do the same. The other option is to use the shortcut key, Ctrl plus F1. The ribbon is organized into groups of buttons to make them easier to find. So on the Home tab, we have groups for font, alignment, number, styles, and so on. Some of these groups contain all the available buttons on the ribbon when viewing in full screen, such as styles and cells, but other ribbon groups have more options, which we access by clicking the little arrow icon in the bottom right corner of the group, as can be seen here on the number group, for example. The next item I want to point out is the Quick Access toolbar at the top of the screen above the ribbon. As the name suggests, this is where you can quickly access the tools you use most often. You can see we already have some tools in this toolbar, such as Save, Undo, Redo, New, and Open. But we can add other tools to the toolbar if we wish. So if we click the drop-down arrow in the toolbar and then select a tool we use a lot, such as Sort Ascending, that will be added. And we will also add the Sort Descending button. Now we need to be comfortable with moving around a worksheet. You can simply use the arrow keys to move left, right, up, and down one cell at a time. But you can also use page down and page up to move around a bit faster, which is especially useful if you have lots of rows of data. And to move even quicker up or down a large data sheet, use the vertical scroll bar. And to move left or right, use the horizontal scroll bar. Again, these can be very useful when you have a large data set. There are also some useful shortcuts you can use. Ctrl plus Home key, for example, takes you back to the start of the worksheet, that is, cell A1. Ctrl plus End takes you to the cell at the end of your data in the worksheet. Ctrl plus Down arrow takes you to the end of the column you're in, while Ctrl plus Up arrow takes you back to the top of that column. So a quick way to find out how many rows of data you have in your worksheet is to go to the first cell in your data and press Ctrl plus Down arrow to see the last row of data. So here you can see we have 160 rows. Now, how do we go back to the top again? Control plus Home will do it. So far, we have seen how to navigate around our worksheet and its data. Now we need to look at how we select data. This is very important because you often need to select data to move it, copy it, or select it in a formula. The simplest selection is a single cell, usually done with a mouse or maybe a directional arrow key. The next step up is to select multiple cells together, and this can be done either with a mouse by dragging from one cell to additional adjoining cells, or you can use the Shift key with directional arrow keys. Next up is selecting a single column or row, which is done simply by selecting the letter at the top of the column or the number on the left of a row. Then we can progress to selecting multiple columns and rows by clicking the mouse button, holding it down, and dragging across more columns. Or if you are not comfortable with dragging, you can also select the column first, then hold Shift plus arrow keys to select multiple columns. The same applies to rows too. However, if you have data in non-continuous rows or columns, that is, not next to each other, you can select the first column, then use the Control key to select another unconnected column, such as columns C and F here. The largest thing you might want to select is the whole worksheet, which you can do by clicking in the top left corner of the cells. However, this selects the entire worksheet, including all the empty rows and columns. So if you only want the data in your worksheet, you can use the shortcut Control plus A. A word of warning when selecting data in cells, rows, and columns. There are 3 types of cross symbols that you might see when working with selected cells. The first one is the large white cross that you see when you select a cell, as can be seen here in cell A4. This is the select cross that we have been using already in this video to select cells. The second type you might see is when you hover over the bottom edge of a cell and see a thin black cross-type symbol with arrows on each point. This is the move symbol and would move the cell data to another location. The last type is the small thin black cross that is seen when you hover over the bottom right corner of a cell. This is the fill handle or copy symbol, and it fills or copies the cell data to another location. In this video, we learned how to move around a spreadsheet, become familiar with the ribbon and menus, and learned how to select data in a worksheet. In the next videos, we will discuss how to enter data, how to copy and paste data, and how to format data in a spreadsheet. In this video, we will listen to several data professionals discuss the advantages and limitations of using spreadsheets as a tool for data analysis. Let us start with, what are the benefits and advantages of using spreadsheets as a tool for data analysis?
My experience using spreadsheets as a tool for data analysis is somewhat mixed. I think they can be really, really useful in the right context, but using spreadsheets definitely has its limitations. So the big pro of using spreadsheets is you can see all the data cleanly laid out in front of you in a table. So I think it's very clear to anyone looking at a spreadsheet exactly what the data is, what format it comes in, all of that. You can just easily visually inspect it.
As a CPA, I use Microsoft Excel on a daily basis, and I have done so for the duration of my career. The functionalities, the pivot tables, the charts, etc., but also being able to use formulas. My personal favorite is index match for using a pretty simple way to take just thousands of lines of information and sift through all of that to find specifically what you're looking for. Excel is really that one-stop shop where you can perform calculations, analyze financial ratios, and even export reports out of the ERP that I spoke of earlier to customize it as you need.
My experience is using spreadsheets is that they're great for simple analysis.
I will say spreadsheets over the years, the process itself has just improved. As systems improve, as technology improves, spreadsheets are the way to go. Spreadsheets overall, when you do have probably anywhere from 0 to 20,000 lines of data, it's a good way to go. You can really pull out the data, whether I'm trying to see how much a client's making per month, but they may have 1,000 transactions. All of that's helpful. I can use this spreadsheet to whittle down what is actually going on per month, or if I want to do a sum if, or if this happens, give me this number. It's really helpful to be able to dig in and wrap your hands around it and take something that seems on the surface, 20,000 lines seems almost unmanageable. But if I take it and I massage it, put it in a spreadsheet, and then sort it, filter it, make it pretty, put it in a pivot table, I can get what I need. It's just all about not looking at it as being this intimidating thing, but making it more manageable and breaking it down into bite-sized chunks.
Spreadsheets are the easiest way to analyze data and present data. We don't need any fancy tools or additional software for spreadsheets. It's like the commonly utilized language to communicate.
Thank you for that insight. But let's move on to look at the other side of the coin. What are the drawbacks and limitations of using spreadsheets as a tool for data analysis?
I think one of the big cons in terms of analyzing data within spreadsheets is it's really hard to reproduce state. So in other words, if you load in some data and you filter out some bad values, or you impute some missing values, there's no way to tell your colleagues or your future self exactly the different steps you took to create that data set or to modify that data set.
It's almost a dilemma because of the plethora of options available within Excel and all of the functions that are there supposedly to make your life easier, but it's nearly impossible to know everything. And you can find yourself in what we accountants call analysis paralysis when you're looking at something for too long, or you're not well versed in a particular Excel function. So you may spend a lot more time, energy, and effort trying to figure that one thing out. And had you done it a different way, or maybe a manual way, you probably could have gotten to the solution a lot easier.
And the downside of using spreadsheets is that if you have complex formulas, VLOOKUPs, if statements, at times they just stop working and you have to rebuild them. So I have found that it's better to use Excel just for simple analysis and for a download of information.
I love a good spreadsheet. I love using Excel and pivot tables to get to the data. But I find that if I start to get over 10, 20,000 lines of data, it gets a little tricky. And sometimes the spreadsheets will crash. So that's when we might move to Access and some of the other tools that we use.
It's very difficult to handle the extremely large data set in spreadsheet. Besides, spreadsheet has less flexibility for complicated analysis and presentation.
Now that you have learned basic spreadsheet terminology and how to navigate your way around worksheets and select data in Excel, it's now time to start entering some data. First, we will look at some of the handy viewing features provided in Excel, and then we'll enter some data, and then we'll edit that data. When you have a lot of data in your worksheet, it can be useful to zoom in closer to a specific area of the data. The zoom slider at the bottom right corner of the worksheet allows you to do just that. You can either click on the plus and minus buttons or drag the slider to select your preferred zoom value. You also have some zoom controls in the ribbon on the View tab. Zoom lets you pick a predefined zoom level or a custom one. The 100% button zooms the worksheet back to its original size, and Zoom to Selection enables you to select an area of data and then zoom into that specific selection only. If you want to see several areas of your data at the same time while zoomed in, you can use the Split button. This splits the screen into multiple sections, and you can scroll each section separately. If you only want 2 sections, you can remove either the horizontal or the vertical split by double-clicking on it. If you have headings in your columns, like a header row, then you might want those to remain on screen while you move down the sheet. To do that, you need to use Freeze Panes. You can freeze only the top row if you wish, or if that doesn't suit, as is the case here, then you can select the row or even just a cell in the row below the row or rows you want to freeze, and then select Freeze Panes. You can do a similar thing for columns if you want to freeze them too. And you can even freeze both rows and columns at the same time. The trick here is to first select the cell that is both one row below where you want to freeze and one column to the right of where you want to freeze. In this case, that is cell C4. Now we can scroll down the worksheet and across the worksheet, and we can still see the header row and the manufacturer and model columns. Now, if you have multiple workbooks open, notice I said workbooks and not worksheets, then you can switch between them by using View, Switch Windows, or the faster method is to use the Ctrl plus F6 shortcut. Now let's enter some data into our blank worksheet. The easiest way to open a new worksheet from within Excel is to click the New button in the Quick Access toolbar, or Ctrl plus N if you prefer keyboard shortcuts. So let's enter some headings across the top of the worksheet. This is typically referred to as a header row. Note that if you press Enter after typing data into a cell, the next active cell is the one directly below, which is not what we want in this case. But if we press Tab after we enter data in a cell, it selects the next cell along in the row as the active cell. Now we'll enter some headings and press Tab after each entry. Notice that the text is slightly longer in some of the cells, and it either gets partly hidden by the next cell or overlaps it. If you click and hold the divider line between 2 columns, you can drag it left and right to resize it manually. If you want to do that automatically, you can double-click the divider line between 2 columns. As these are going to be headings for our columns, let's make them bold. Now let's add another column between the Parts and Accessories column. Simply select the right hand of those 2 columns, then right-click and choose Insert to put another column to the left of the selected column. Let's call it Servicing Sales. To tidy up our column width simultaneously, we select all the columns from A to E, then double-click any of the divider lines between columns. This automatically reduces or increases each column's width to fit the data in that column. Okay, now we have some headings. Let's enter some month data in column A. So, if we type Jan in cell A2 and press Enter, then it takes us to the cell below, which is what we want in this case. And we can type Feb in cell A3, and so on, until we get to December in A13. Now let's suppose you need to change a couple of your headings. You have several ways of editing existing data in a cell. You can either select the cell and then just start over typing, or you can select the cell and press F2 on your keyboard to put the cursor at the end of the cell and make your changes. Or you can simply double-click somewhere on the cell and put the cursor at that position in the cell and make your changes. And you can even select the cell and then click in the formula bar to edit your cell data. Now let's do the same for the Parts and Accessories column headings. In this video, we learned about some of the viewing options in Excel, and we learned how to enter and edit data in cells. In the next video, we will learn how to copy and fill data and how to format the cells and data in a worksheet. Now that we have learned about some of the handy viewing features provided in Excel and entered and edited some data, let's discuss how to move, copy, and fill data and how to format cells and data to suit our needs. The first thing we are going to discuss is how to move data. So if you select a range of cells, in this case the headings in A1 to E1, and then hover over the top or bottom edge of a selected cell, you will see the Move pointer. Then you can drag the selection to another place on the worksheet. Alternatively, if you want to copy the data instead, you do the same thing, but this time you also hold Control key as you select and drag the selection to another location, and you will see the Copy pointer. If you are not comfortable with dragging, you can also use Copy and Paste menu commands or keyboard shortcuts. If you select some data in column A and copy it to the clipboard, then you simply select the new location and paste the copied data. You can also move or copy between worksheets. So let's create a new worksheet. Then select some data from sheet 1, and this time let's use the Ctrl+C keyboard shortcut to copy it to the clipboard. Then choose the other worksheet and use the Ctrl+V shortcut to paste the data. However, notice that the column widths are not the same as the original source data, so let's undo that and try another paste option. By default, when you paste the copied data, it uses the column width settings of the destination cells. So, to paste it and retain the column widths of the source data, you choose the special option under the Paste command, called Keep Source Column Widths. As an alternative to having to enter data manually in a worksheet, you can use an Excel feature that automatically fills cells with data when it follows a sequential series or pattern. The feature is called autofill, and it can be especially useful when you need to enter lots of repetitive data into Excel, such as date information. For example, if you enter a month in a cell, even using a shortened version of the name, you can use what's called the fill handle to select down to the end of the series, and autofill will work out what the series is based on the selected data. Let's try the same thing with days of the week. If you enter Mon for Monday in a cell, then drag the fill handle to use autofill, it will determine that you want to enter the days of the week sequentially. However, if you also enter Wend for Wednesday in the next cell down and select both cells in the series, that is A16 and A17, and then drag the fill handle down, autofill determines that the sequence has changed to every other day and fills in the data series for you. It's important to select all the cells that determine the pattern when using autofill so that it can best determine what the pattern is, in this case, cells A16 and A17. A similar thing applies to numerical patterns. If you enter 5 in a cell and then use the fill handle to fill the data down the column, because the data is not the name of a day or month, for example, autofill can't determine what the pattern is yet. So in this case, it just copies the value 5 into every selected cell. However, if you enter the value 10 in B3 and then use the fill handle to fill data down the column, autofill determines that the pattern is incrementing by 5 each time, and it fills in the remainder of the data pattern for you. Now we're going to look at formatting our data, and there are essentially 2 distinct parts to this. First, there's formatting of the cells themselves, with a fill color and a bold border, for example, and bold text within it. And then there's formatting the data in the cells, for example, making it text format, number format, or a specific currency or accounting format. Let's open the car sales worksheet we used previously. Then select the headings in cell A3 to P3, either using the mouse or you could use the shortcut keys Ctrl+Shift+right arrow. On the Home tab, click the Styles drop-down arrow and then select a style color for your cells. Then you can make the selected cells bold. Then you select the data in the manufacturer column, either using the mouse or the shortcut keys Ctrl+Shift+down arrow. In the Styles drop-down arrow, select another style color for the selected cells. Again, you can make the cells bold. Then you select the data in the model column again, either using the mouse or the shortcut keys Ctrl+Shift+down arrow. In the Styles drop-down arrow, select another style color for the selected cells. This time you could make the selected cells italic. And you can also change the font size and style. Lastly, you can select all the other cells in the data by using the mouse or the Control plus Shift plus right arrow, then down arrow, and apply borders to the data cells. Now it's time to format the cell data. The sales figures in columns C and D can be formatted to display only one decimal place. Just select the data and click the Decrease Decimal button. We also have an issue with a couple of the car models. If you look in cells B129 and B130, where the model name is supposed to be displayed, you can see there are actually two dates listed instead. And if you look in the number format box, the format type is custom. This has happened because the model numbers are supposed to be the SOB 95 and the SOB 93. But when the files were imported from CSV files, these two cells must have been incorrectly determined to be date values and not just numbers. You can fix this by formatting these two cells as text and then enter the correct values of 95 and 93. The last thing we want to do is format some data as currency. If you look at the heading in column F, it says it is price in thousands of dollars, and cell F4 is using the general format. So let's change the format of this column to American currency format. We select the column, F in this case, then select More Number Formats from the drop-down list. Then we choose the currency option and the correct currency symbol and format, and we're done. In this video, we learned how to move, copy, and fill data, and how to format cells and cell data to suit our needs. In the next video, we will look at the basics of formulas, learn how to perform simple calculations, and learn how to select ranges and copy formulas. Now that we have learned how to move, copy, and fill data, and how to format cells and data, next we will take a look at the basics of formulas, including some basic calculations, selecting ranges in formulas, and how to copy formulas. A typical formula is made of several key components. The equal sign starts the formula off and lets Excel know you are creating a formula in this cell. The next part is the function, which performs the calculation. For example, the sum function adds up the values in referenced cells or cell ranges. Then comes the reference, which is the cell or range of cells you want to include in your calculation, and these need to be enclosed in parentheses. You also have operators, which specify what type of calculation to perform. Common arithmetic operators include addition, subtraction, multiplication, and division, and these are represented by symbols: the plus symbol for addition, the minus symbol for subtraction, the asterisk for multiplication, and the forward slash for division. There are other types of operators too, namely comparison, text concatenation, and reference. You may also use constants in your formulas, which, as the name suggests, are numbers or values which you can enter directly into a formula, and which don't change. This might be a whole number, such as 5, it might be a percentage, such as 10%, or it might even be a date. So a typical formula might be equals sign, sum, open parenthesis, B5, asterisk, 20, close parenthesis, which would take the value in cell B5 and multiply it by 20. Let's start with a few basic calculations. Suppose you want to add up January and February sales of accessories. You would start by typing an equal sign, which lets Excel know you are entering a formula. Then you type in the function you wish to use, in this case, the sum function. Note the description. Next, you type an open parenthesis. Then you select your cell range, which in this case would be E2 to E3. So you could enter that as E2, E3, then a close parenthesis, and press Enter. And if you wanted to add March sales as well, then you would have to extend the cell range to include E4. So you could type E2, E3, E4, as your range, and it will work. Remember, to edit a cell, you select the cell and either edit it directly in the formula bar or press F2 or double-click the cell. However, it's very cumbersome and not very flexible to do it this way, because if you wanted to add up the entire column, then you'd have to type every cell reference, one after the other. So thankfully, there's a better way. Instead of typing each cell to include in the reference, you just put a colon between the first and last values in our range, so E2 colon E4 in this case. And if you wanted the whole column, then you would enter E2 colon E13 in your formula. But there's another way of doing it, and that's by using your mouse to select the range, so you still type =sum, then open parenthesis, but select the range with your mouse or Shift plus arrow keys, and just press Enter. Excel will add the close parenthesis for you. To total these columns up and add some tax, you'll add some headings first for subtotals and tax at 20%. Then your formula will need to multiply the value in subtotals by 20%. If you wanted to add up all the column subtotals and calculate the taxes, then you would repeat the previous process for each column. But that's very time-consuming and you don't need to, because Excel has some neat tricks to do this for you. Just select the fill handle in the bottom right corner of the cell and drag across to the other cells to copy the formula. This is called autofill. Notice how the formula is copied, but the row references change in relation to the cell's position on the worksheet. So what was E2 colon E13 has become B2 colon B13. These are known as relative references, but more on that later in the course. And you can do the same thing for the tax values in row 16. Now, you need a row for showing the totals. The calculation here is simple. The subtotal value in cell B15 added to the tax in B16. And again, you can use the fill handle to copy the formula across. If you wanted to total the sales of all products by month, you'd add a column heading. Notice how the cell style is copied to the new heading automatically. Remember, to widen a column, either drag the divider manually or double-click the divider. Then, enter the formula in cell F2 as you've done before. However, Excel has another trick up its sleeve. It's called AutoSum and is found on the Home tab in the Editing group. This is a great little shortcut for some simple common functions like sum, average, count, max, and min, but you can choose other functions too. You want sum for this particular calculation. Notice that it also has a keyboard shortcut of Alt plus equals, and then press Enter and it's done. Now you can use the fill handle to copy down the remaining values. But hold on, there is one more Excel trick to show, and it's a good one. Suppose your column of data was very long. You might have to drag the fill handle down over several pages, which isn't easy to do and can easily lead to errors when selecting large lists of data values. Rather than needing to drag down to the rest of the column, you can just double-click the fill handle and it will automatically copy the formula to all the remaining cells in that column. This one is a real time saver. Finally, let's format all these values to use the US dollar currency format. In this video, we learned about the basics of formulas, how to perform simple calculations, how to select ranges in formulas, and how to copy formulas. In the next video, we will look at how to use some of the common functions used by data analysts and discover some more advanced functions. Now that you have learned about the basics of formulas, learned how to perform some basic calculations, and how to select ranges and copy formulas, next we will have an introduction to functions, including using some common statistical functions, and then we will learn about some more advanced functions that a data analyst might also use. First, let's look at some common functions used for statistical calculations. We'll add some row headings for average, minimum, maximum, count, and median. Then, in cell B20, let's work out the average of the car sales for the year from the table above. On the Home tab in the Editing group, we click on the AutoSum drop-down list and choose Average. Now, because AutoSum tries to add up the values directly above it in the column, we need to modify the cell range here to B2 to B13. Then we can use the fill handle, as we've seen before, to copy the formula across to column E. For the minimum calculation in B21, we select Min from the AutoSum list. And again, we need to modify the cell range, so this calculates the lowest value in our range. And fill across to column E. And for the maximum calculation, we select Max from the list, and then modify the range. And once again, copy the formula across. This calculates the highest value in our range. In B23, we will calculate the count, which basically just means the number of values that exist in the selected range. So we select Count Numbers from the list. Then modify the range. For the median calculation, we can select More Functions from the AutoSum list. Then select Statistical as the category and scroll down to find the median function. The median returns the exact middle of a range of selected values. Note that if you're selecting an odd number of values, it will return the figure that is the middle value in your selected range. But if you have selected an even number of values in your range, it will return the middle figure between the two middle values in your range. Once again, we need to change the cell range to B2 to B13. And we can then copy this formula across to column E. You've seen AutoSum and some of the common statistical functions in Excel, but there are another 400 plus other functions available. So let's explore just a few of those now. On the Formulas tab in the Function Library group, there are drop-down lists for several function categories. The first is a list of recently used functions, which updates automatically as you use them. Then you have functions related to financial calculations. If you hover over the name of a function, you see a short description for each one. So here we have the accrued interest function, and here is the interest rate function. The logical list has Boolean operator functions such as and, if, and or. There are several functions related to text, such as concat, which is an updated version of a previous function called concatenate, which is still supported, by the way, for backwards compatibility, find, and search. There are also several functions related to dates and times, such as net workdays, weekday, and weeknum. In the lookup and reference list, there are functions such as areas, HLOOKUP, sort by, and VLOOKUP. In the math and trig list, you'll find lots of useful mathematical functions, such as power, SUMIF, and SUMPRODUCT, alongside many functions for trigonometric purposes, such as cosine, sine, and tangent. There is also a More Functions list, which provides several more function categories, such as statistical, engineering, and information. In the statistical list, you'll find functions such as average, count, max, median, and min. We saw some of these used earlier in this video. If you're struggling to find the function you want in these lists, you can also search for a function. Just click the Insert Function button on the Formulas tab, and then either browse the category lists available or choose All and look down the alphabetical list for the function you want. Alternatively, type the name of a function you want and click Go to search for it. Then select the one you want from the returned search. In this video, we learned about the basics of functions, how to use some of the more common functions that a data analyst might employ, and looked at some of the more advanced functions available in Excel. In the next video, we will look at referencing data in formulas, specifically differentiating between relative and absolute references, and error handling in formulas. Now Now that you've had an introduction to functions, seen the use of some common statistical functions, and learned about some of the more advanced functions that a data analyst might use, in this video, we'll look at the difference between relative, absolute, and mixed references and formulas, as well as how to use them, and we'll learn about formula errors in Excel. It's important to understand the difference between relative and absolute references when creating your formulas. By default, in Excel, cell references are always relative references. The term relative is the key here because it means that when you reference a cell, you are in fact referencing the cell's position in relation to the cell that the formula is in. That is why, when we have been copying formulas from one cell to another so far in this course, using either copy and paste or the fill handle, we haven't needed to modify the cell references because Excel assumes you are using relative references. When the formulas are copied, the cell references are changed to match the relative positions of the cells that are being copied to. So now we know that relative references are the default in Excel, but how do we make it so that the cell references don't change when we copy them? For that, you need to use absolute references. In contrast to relative references, absolute references to cells stay the same when you copy a formula containing such references. Lastly, there may also be some instances where you only want one of the cell reference identifiers to be absolute and the other one to be relative. For example, you might want the row identifier to be absolute, but the column identifier to be relative, or vice versa. These are called mixed references, and an example of this would be $A $1 plus $A3, where $A1 has a relative column and an absolute row, or $A3 has an absolute column and a relative row. In contrast to relative and absolute references, when you copy a formula containing mixed cell references, any relative cell references will change, whereas any absolute cell references will stay the same in the copied formula. First, let's look at an example of using relative references in a formula. For example, if we enter the formula equals A1 plus A3 in cell 4, note the blue and red highlighted cells in A1 and A3. These denote the cells being relatively referenced in the formula. If we copy the formula to the cell directly below using the fill handle, we can see that the result changes. And if we look at the copied formula, you can see that the blue and red cell references have changed relative to their position on the worksheet. The formula has been changed to equals A2 plus A4 in the copied formula. That is, each cell reference has moved one cell down. And if we copy and paste the formula to C7, you can see that the result also changes. And again, we can see that the blue and red cell references in the copied formula have changed. Now, let's look at an example of how to use absolute references in a formula. All you need to do to make a cell reference absolute is put a $sign in front of the column and/or row identifiers in the formula. For example, if we enter the formula equals $A $1 plus sign $A $3 in cell E4, note the blue and red highlighted cells in A1 and A3. These denote the cells being absolutely referenced in the formula. When we copy the formula using the fill handle, you can see that the result stays the same this time. And if we look at the copied formula, you can see that the blue and red cell references haven't changed. The formula is still $A $1 plus $A $3 in the copied formula. That is, the cell references haven't changed. Similarly, if we then copy and paste the formula to E7, you can again see that the result stays the same this time. And we can see that the blue and red cell references haven't changed. The formula is still $A $1 plus $A $3 in the copied formula. That is, the cell references haven't changed. Lastly, we'll look at an example of how to use mixed references in a formula. So if we enter the formula equals $1 plus $A3 in cell G4, note the blue and red highlighted cells in A1 and A3. These denote the cells being referenced in the formula. If we copy the formula to the cell below using the fill handle, you can see that the result changes, but it's a different result from the previous examples. And if we look at the copied formula, you can see that the first blue cell reference has stayed the same, but the second red cell reference has changed. If we copy and paste the formula to G7, you can see that the same thing happens. The result changes. And again, we can see that the first blue cell reference has stayed the same in the copied formula, while only the red cell reference has changed. Now we'll have a quick introduction to dealing with formula errors in Excel. Because of the complexity of writing formulas, especially the more complicated ones, there are bound to be occasions when you make a mistake in the syntax or in the data selection, which will lead to a formula error. Errors are typically denoted by displaying, in the cell that is supposed to be displaying the result, one of the error codes in this list. When you see multiple hash symbols in a cell, it's not really an error. It just means the column either isn't wide enough to display the whole word or value, or it contains a negative date or time value. So if we type Control plus semicolon, then space, then Control plus Shift plus semicolon, it enters today's date and the current time. But the cell is too narrow to display it, so what we see is multiple hash symbols. If we adjust the column width, we can now see the cell contents. So as I said, this really shouldn't be considered as an error. However, if we enter the formula seen in cell I7, when we press enter, we see a hash name error. This error was caused by trying to use an X as a multiplication operator, when in fact it should be an asterisk. Note the small green triangle in the top left corner of the cell. Also, note that when you select the cell, an exclamation mark appears, providing you with a hint about what caused the error. In this case, it says the formula contains unrecognized text. When you click the drop-down arrow next to the exclamation mark for an error, you see several options. The first line also gives you a clue on the nature of the error. This one says invalid name error. So it was probably a mistyped cell reference, value, or function name. If you click Help on this error, a help pane opens with specific information related to this error. If you click Show Calculation Steps, a dialog box opens displaying the current syntax with the error underlined, and you can try to evaluate the error. If you are certain the error is incorrect, you can choose Ignore Error. And if you want to edit the formula, click Edit in Formula Bar, and the cursor will be focused in the formula bar so that you can try and correct the formula error. If you click Error Checking Options, the Excel Options dialog box is opened at the section related to error checking rules, and you can modify these options to suit your needs. Each of the errors you make, which generate one of the error codes listed at the start of this video, will have a different reason and a different solution. For more information on each of these errors and typical solutions, visit the link provided. In this video, we learned about referencing data in formulas, specifically differentiating between relative, absolute, and mixed references, and how to use them. And we learned about formula errors in Excel. Data analysis can play a pivotal role in business decisions and processes. In order to use the data to make confident decisions, we must have the right information for the project, and the data must be free from errors. In this video, we will learn how to profile data to discover inconsistencies. Whether we are working with small sets of data or analyzing a spreadsheet with thousands of rows, one of the most difficult parts of the data analysis is finding and keeping clean data. To help with this process and qualify the data, look at these 5 traits: accuracy, completeness, reliability, relevance, and timeliness. Accuracy is the first and most significant aspect to data quality. A data analyst must clean the dataset by removing duplicates, correcting formatting errors, and removing blank rows. Another important aspect of data quality is determining if the information required to complete the dataset is readily available. Why does this matter as a trait for quality data? Let's say we are given the task to calculate the revenues of all sales per region. After collecting the data, we discovered that no regions were specified. This data would then be considered incomplete, and other sources would have to be considered to obtain the data required. Reliability is another vital factor in determining the quality of data. For instance, let's say we are given the task to determine the agent revenue by customer. When gathering the data, we find that agents keep their own records and do not always update the information in the shared company database. With those factors in mind, we would then determine that the data in the shared company database was unreliable, and new processes would need to be established to ensure reliable data. Relevance is another trait of quality data. When collecting information, a data analyst must consider if the data being assembled is really necessary for the project. For example, when reviewing the data related to the sales revenue per customer, information such as customer birthdays and other personal information is also included. By making the determination early to exclude the personal information from the dataset, the analyst would save themselves from having to review unnecessary information. The last factor in determining the quality of the data is timeliness. This trait refers to the availability and accessibility of the selected data. Let's say our sales report is going to be used for weekly employee reviews, but our report is only refreshed once a month. This error in refreshing the data would cause our report to become outdated and would have serious consequences for employee reviews. In this video, we learn the important role of a data analyst in qualifying data. By considering the 5 traits of good quality data, an analyst can save time, avoid serious issues, and have data that is free from errors. In the next video, we will take the collected data and learn how to import it to our spreadsheet. Now that you have learned about the importance of data quality, in this video you will learn how to import data from a text file using the text import wizard, learn how to adjust column widths, and learn how to add and remove columns and rows. As you know, by default, Excel works with .xlsx or .xls files and opens them as workbooks. But Excel can also use data that is in other formats, such as plain text or data that has been comma separated and tab separated. Sometimes these source files will be saved with a .txt extension and referred to as text files, but others might be saved with a .csv file extension and are typically referred to as CSV files. Here in Notepad, I have opened a text file that contains data about car sales, and it uses comma-separated values, or CSVs, to separate each bit of data in a record. Notice that the top line holds headings, such as manufacturer, model, engine size, and so on, and each one is separated by a comma. We want these to become our headers when we import the file into Excel. The line below these headings is the first line of real data, and again, you can see that each piece of data is also separated by a comma. There are 16 headings, and there are also 16 pieces of data on each of the lines below the headings. If we scroll to the bottom, we can see that last data record is for the Volvo S80. Now, to open the file in Excel, we choose File, Open, and then either select the file from the recently used list or click Browse to find the file we want to import. When we open the file, the text import wizard launches automatically, and it will start to try and determine what your file is. Note that it has been detected as being a delimited file, that is, one that has its data fields separated by a character such as a comma or a tab. As we want the headings to become headers in Excel, we need to ensure that we select the option My Data Has Headers. We can see a mini preview of the data in the preview box below. Then we click Next to proceed in the wizard. In step 2 of the wizard, we need to select our delimiter, that is, which character is separating our pieces of data, so we select comma and deselect any others. Note the data preview now starts to show us what the imported data will look like. You can scroll down and across this preview window to ensure that the data is going to look as you want and expect. It all looks okay, so we'll continue with the wizard. In step 3 of the wizard, we can set the data format for each column. For example, you might want to change a column to text or date format. In this case, we can just accept the default general format and finish the import wizard. In Excel, we can see that the headings in the text file have been imported as a header row. But also notice that some of the columns are not showing all the data. Some of the headings are not showing in full, and some of the data is not shown either. All you can see are a number of hashes in the cells. This is because the column widths are too narrow in some cases. If you remember, you can manually adjust a column's width by dragging the divider across, but to change them all in one go, we select all the columns first, then double-click one of the selected column dividers. We can also do a similar thing with rows by dragging them to make them bigger or smaller, or double-clicking a row divider to auto-size it. There are some columns that we have decided we don't really need, namely vehicle type and latest launch. So let's remove those. This can either be done using the Delete drop-down menu in the Cells group on the Home tab and select Delete Sheet Columns, or by selecting and right-clicking a column and deleting it that way. To add another column, you simply select the column to the right of where you want your new column to be. Then right-click the column and choose Insert. And let's give the header a name, such as Year. To delete a row you don't need, select the row, right-click it, and choose Delete. And to add a row, select the row below the place you want to add your new row, right-click the row, and choose Insert. If you want to save the file as an Excel file, you can either choose File, Save As, or you can click Save As in the yellow tooltip that appeared at the top of the worksheet when we imported the file. Then you would choose Excel Workbook or .xlsx in the Save As type box. In this video, we learned how to import data using the Text Import Wizard. We learned how to adjust column widths, and we learned how to add and remove columns and rows. In the next video, we will discuss the importance of data privacy, including sensitive information and personally identifiable data. In this video, we will learn about data privacy and the regulations that govern the collected data. When collecting customer data, specific regulations apply to how that data can be used. By understanding data privacy regulations and getting familiar with the following 3 fundamentals, you can eliminate the risk of financial penalties and keep the trust of your customers. Confidentiality, collection and use, compliance. Confidentiality is an important element in data privacy, and it acknowledges that the customer's personal information belongs to them. The types of information that can be accessed by a data analyst can range from sales forecasts to employee information, or even patient records. When accessing these types of records, the analyst must be able to recognize the different types of personal data. Personal information, or PI, is any type of information that can be traced back to a specific individual. This type of information can include anything from emails to images. Personally identifiable information, or PII, is specific information that could be used to identify an individual. This type of information could include a social security number or a driver's license number. And lastly, sensitive personal information, or SPI, may not necessarily identify a specific individual, but contains private information that needs to be protected because, if made public, it could possibly be used to harm the individual. This type of information can include data about race, sexual orientation, biometric, or genetic information. By understanding personal data and the associated regulations, we can efficiently anonymize our data by removing unnecessary information. This type of action can help build customer confidence and continue to develop the free flow of information. When searching through data, the analyst must know the location of the company collecting the data and the location of the respondent. Knowing where the data was collected is an essential element of data privacy and what regulations must be applied. The General Data Protection Regulation, or GDPR, is a regulation specific to the European Union and only applies to the jurisdiction of the individual. A new law created in Brazil, called the LGPD, will take effect in August 2020. These new data policy regulations apply to individuals within Brazil and ignores the location of the data processor. While the United States does not have one country-wide principal law for data privacy, because of this, individual states began to make their own regulations. For instance, California created the California Consumer Privacy Act, or CCPA, to better protect customer data. There are also industry-specific regulations that govern the collection and use of sensitive and personal data. For example, in healthcare, HIPAA, or HIPAA, privacy rules govern the collection and disclosure of protected health information. In retail, the PCI standards govern credit card data, and failure to safeguard cardholder information can result in hefty fines. With a basic understanding of these policies, we are able to remain compliant when handling any sensitive information. Unfortunately, breaches in customer data is an all too common occurrence, and understanding how to remain compliant is essential. Understanding the data privacy regulations of the European Union, the United States, and other countries as well as industries is key to keeping data safe. Companies must comply with these privacy regulations at all times, and also make sure policies are readily accessible to employees. For example, let's say a data analyst downloads a spreadsheet of sensitive information. In order to complete the report by Monday morning, the analyst decided to take their work laptop home for the weekend. After driving home, the analyst accidentally left the laptop in their car. The next morning, they found their car had been stolen along with the laptop. Because it is the responsibility of the company to keep customer data safe, this was a breach of privacy when the data left the company property. This type of action could not only cost the company large amounts of money in fines and penalties, but could also reduce customer confidence, causing a significant impact to revenue. While data privacy applies to most data that is collected, there are some instances where these regulations do not apply. In order for these laws and regulations not to apply, the particular collection of data must be completely anonymous. To make data anonymous means to exclude all data which ties it back to a particular individual. While this approach might not be practical in all circumstances, collecting data with privacy in mind could remove privacy limitations and make data collections more accessible. In this video, we learned about the importance of data privacy and the challenges that a data analyst can face when collecting and sorting through data. In the videos in the next lesson, we will learn about different methods for cleaning data in a spreadsheet. In this video, we will listen to several data professionals discuss the importance of data quality and data privacy as they relate to data analysis. Let us start with what is the importance of data quality as it relates to data analysis.
Data quality is of the utmost importance in terms of data and analytics. And the reason behind this is because as soon as what you're presenting does not align with what's someone expects, that's the first thing that they tend to go after. Where did you get the data? What's happened to the data? How has it been transformed? Because people like to think that they know and understand their business. And when you start to challenge that, if you don't have the ground to stand on of the data, that it's quality, that it's clean, and that it is from a trusted source, that's when you start to get into a lot of discussions, a lot of debate, and ultimately the plot of what you're trying to present gets lost.
The backbone of any successful data analysis project is good quality data. There's a common term in computer science called garbage in, garbage out, which is essentially if you read in bad quality data, you can expect to get bad quality results. So there's really nothing more important when doing a data analysis than making sure that you're working with good quality data. And it's really important to sense check the data yourself and really feel comfortable that the data you're using is of a really high quality.
Data accuracy is above all garbage in, garbage out. It's a waste of time to analyze data of poor quality, and it might mislead the business direction.
The integrity of the data that you're using or providing for someone else to use is of the utmost importance. Data is used to determine when or where to launch a product, if a division is profitable or not, and it's easy to get things confused if you're not paying attention to the details. Using inventory as an example, if you're looking at inventory at a SKU level and you accidentally pick the wrong SKU to analyze, and then you draw these conclusions that this particular item isn't profitable when in fact it is. So that's a major decision for a company to make, obviously. So the expectation is that there will be lots of due diligence, but in the beginning, if you start off with bad data and then you build on that only to later realize that it wasn't a good idea, you've lost time, energy, effort, and in some cases, trust.
Thank you for those viewpoints. What about the importance of data privacy as it relates to data analysis?
Data privacy is incredibly important, especially when you're working in industries like pharmaceuticals or healthcare. But that's not where it stops. We have to have the ability to make sure that the users are getting the appropriate level of data based on their roles and their permissions. Now we can do this through a number of cuts of the data specific to each geography or each function, or in some tools such as Cognos Analytics, we can start to build out that as part of our model. Within there, you can say who has access to what, whether it's at a granular level of this person can see data in Canada or the US, or whether it's simply this person can see this report in its entirety or not. There's lots of different ways to handle this, but data privacy is of the utmost importance across all industries.
In today's world, data privacy is a huge thing. On the tax side, especially of our business, we have what we call PII, personal identifiable information. We have to protect that, and so we can't just send things through email. We don't send tax returns, or even actually in our business period, we don't send things through email that have sensitive PII data in it. We encrypt it. We make sure the email is encrypted, or we use software, some certain softwares that will allow us to not show the social security numbers or the names or the date of births. And what will happen is it has a certain sequence, and we share that with the client by calling them. We don't put that in an email, and we certainly don't put that in the same email with the encrypted information, because we want to make sure that you're always safe. So we have to make sure we're protecting it at all costs.
Now that we have learned about the importance of data quality and data privacy, in this video we will learn how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. It's very common when collecting or importing data, whether through manual or automated processes, to get errors and inconsistencies in your data. This can be as simple as spelling mistakes, extra white space, or the wrong case used in text, to empty rows or missing values in your data, to inaccurate or duplicated data. Having these errors and inconsistencies in your data can lead to issues with formulas not working, with unsuccessful sorting and filtering operations, and therefore inadequately visualized and presented data findings. These data errors and inconsistencies require you to carry out some form of data cleaning routine to improve the quality and usability of the data. Let's start off with one of the easier of those tasks, which is spell checking. In Excel, this works in pretty much the same way as you may have already encountered in applications such as Microsoft Word or other common word processing applications. I have some data here relating to the sales of toy vehicles, and the first thing we need to do is select what data we wish to check for spelling. In this case, we will try column K, which contains the product line data. Then we click Spelling, which is on the Review tab. Well, that seems to be okay. So let's try the country information in column T. So we do have an error here where a country name has been misspelt, or more likely mistyped. We just click Change if we are happy with the spelling suggestion, or we could choose another suggestion from the list, or even ignore this error if we know the data is correct, but in this case, we will change it. Here's another typo for a country name, and here's one more. So that seems to be all the errors in this column. Let's try the final column now, which is the DL size in column X. Here's a misspelling of the word small, and another for medium, and that seems to be all for this column. The next inconsistency we will look for is empty rows. Empty rows in your data can cause lots of issues relating to moving around your data, working with formulas, and sorting and filtering. Therefore, it's very important to remove them from your data. If you remember from an earlier lesson, when we click Control plus down arrow, it should take us to the end of that column of data. But notice if we do that in this data set, the cursor keeps stopping when we get to an empty row, meaning that the data set is essentially being split into multiple sections, separated by these empty rows. That's not good, so let's resolve that now. We have a couple of options. One option is to just manually scroll down the sheet looking for empty rows and deleting each one, which is easy enough and fine to do if you only have a small amount of data. But imagine if you were dealing with hundreds or thousands or even tens of thousands of rows. That would be a very laborious and time-consuming process. There is a much better way, which involves selecting all our data first, either using the mouse or the Control plus Shift plus End keyboard shortcut. Then we select the filter icon on the Data tab. We can now see that each column has a filter icon next to the column header. If we then select the customer name column filter in column M, then uncheck Select All, then scroll down to the bottom of the list, we can check the item called Blanks, and then click OK. This will now show only the empty rows at the top of our sheet. This can be quite hard to see, but if you look in the row numbers, you can see that rows 28, 29, 65, 73, 74, 75, and 117 are listed at the top and are highlighted in blue text. We can now select these rows either using the mouse or going to the first cell in the first data row, which is A28, and then using the Control plus Shift plus End keyboard shortcut. Then delete the offending empty rows. We then need to clear the filter and turn it off so we can view our data again. Now, if we go back to the first row in the top of the data sheet and try the Control plus down shortcut again to go to the end of the data column, it will work. The next inconsistency we'll look for is duplicated rows of data. It's quite common for duplicate data rows to exist in your imported data, caused either by human input error or an error in the import process. There are two ways of doing this in Excel. The first way includes reviewing the data you plan to remove first before deleting it to ensure you are deleting the right data. This is our preferred method as it provides an additional level of data security. The second method, which we will also show you, is simpler, as you don't review the data to be removed first, but it lacks the security of the first method. It's important to select a column of data that you would not expect to have duplicate values in. For example, if we consider the price each column, which is C, we would expect lots of these values to be repeated because the unit price of some products is the same. So this is a bad example of a column to use to find duplicates. Instead, let's use the sales column in column E because it is far less likely that these values will be duplicated in the normal process of things, as they are the total sales for each order. So we select the column and choose conditional formatting, then highlight cells rules, and then duplicate values. When we click OK and scroll down the sheet, we can see that only a few values have been identified as being duplicates. There seem to be duplicate values in rows 36 to 40 and in rows 74 to 78. Let's zoom out so we can see both duplicate sections together. It seems like these are in fact exact duplicate entries and are likely to be an input error. Let's delete the second section of duplicate rows as they are out of sequence, as they relate to motorcycle sales and are in the ships section of the sheet. So that was the first and recommended method of removing duplicate rows of data, which previews the data to be removed first. Now, let's try the second, simpler but less secure method. Let's go back to 100% zoom and go back to the top of the worksheet. This time, we select the whole datasheet, and on the Data tab, we use the Remove Duplicates button. We then unselect all the columns, then only select the sales column, and the duplicate rows are deleted. The last cleaning process we'll look at in this video is using the Find and Replace feature to repair some misspelt surnames in the Customer Contacts column. Find and Replace tools are under Find and Select on the home page in Excel. If you have used other Office products such as Word, it should be familiar to you already. We've had an email from a Swedish customer informing us that we have her surname spelled incorrectly on her order sheets. So we type the misspelled surname into the Find What box and click Find Next. Then click it again to see there are multiple incorrect entries. If we click Find All instances are listed, and we can open the Replace tab to enter a name to replace the incorrect spellings. Her surname should be Larson with a double S, so we'll replace all instances with that corrected spelling. That looks better, and we are finished. In this video, we learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. In the next video, we will look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. Now that we've learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated rows, in this video we'll look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. When you collect or receive data from various sources, it's quite common to find that your data contains text in mixed case, that is, some in uppercase, some in lowercase, and some in capitalized proper case, also known as sentence case. Some of this may be intentional, but often it's not. Excel doesn't have a change case button like there is in Microsoft Word, so you need to use other methods to perform this data cleaning task. Those methods are functions, namely the upper, lower, and proper functions. You can use these functions to help you change the case of text in your data. You can see that the header row here is using all uppercase characters. So if you want to change that to use proper case, then you need to add another row to put the function in. This is referred to as a helper row. The proper function is simple to use. Just type equals, then proper, then open parenthesis, then the cell reference, in this case A1, then close parenthesis, and press enter. Here you can see that the result in A2 is in proper case. Now you can try and drag the formula right across to column X by using the fill handle on A2. But this can be tricky when you have a lot of columns, so let's try another way. Instead of dragging, you can use Shift plus right arrow to select the columns across to X first. Then press F2 to bring the cursor into focus in cell A2. Then you hold down the Control key while you press Enter, and it fills across for you. You might think that you could now remove the original row, but look at what happens when you do. You get a ref error because the formula is referencing an invalid reference, and the header row cells now contain just the failed formula rather than the actual header text. So you need to undo that, and instead, you copy the contents of the helper row to row 1. But when you paste, you need to choose the Paste Values option. Now the header row cells just contain header text, and you can remove the helper row in row 2. Now let's use the upper function to change text from proper case to uppercase. Insert a column to the right of the column you want to change. This will be a helper column. Then you type the formula containing the upper function in the first data cell in this new helper column. Again, it's a simple formula. You type equals, then upper, then open parenthesis, then the cell reference, in this case T2, and then close the parenthesis and press Enter. You can see the result in the country name in uppercase, and you can then copy that formula down the rest of the column by double-clicking the fill handle cross symbol. As before, you then copy and paste the contents of the helper column to the original column, but use the Paste Values option. Now you can delete the helper column. Next, we'll use the lower function to change text from proper case to lowercase. As before, you insert a column to the right of the column you want to change. This will be another helper column. Then, you type the formula containing the lower function in the first data cell in the helper column. Once again, it's a very simple formula. You type equals, then lower, then open parenthesis, then the cell reference, in this case K2, and then close parenthesis and press Enter. You can now see the result is the product line data in lowercase, and you can now copy the formula down to the rest of the column by double-clicking the fill handle once more. As before, you then copy and paste the contents of the helper column to the original column by ensuring you use the Paste Values option. Now you can delete the helper column. It's quite common to receive data that has a mixture of date formats, or that uses a date format that isn't suitable for your region. Now let's look at how to change the format of some dates. You can see that this date format is currently using a 2-digit day, a 2-digit month, and a 4-digit year value. When you open the number format dialog box, you can see in the locale box that this is an English or United Kingdom date format. You want to use a US date format, so you first change the locale to English, United States. In this list, you can see there are several date options to choose from. Let's choose one that uses the full month name, then a 2-digit day and a 4-digit year value. You could then copy this formula to the rest of the date cells. However, if you want to format these dates using your own custom format, you can do that too. In the number format list, you select Custom and then choose an existing format that is similar to what you want, and simply modify it to create a new custom format. Here we'll have the day, then 3-letter month, then 4-digit year. To apply that new custom date format to the rest of the column, you could either use the Format Painter tool, or you can select the rest of the column and choose the new column format from the custom list in the number format dialog box. You might find that your data has some white space, that is, unwanted spaces in your data. Here you can see that we have some spaces at the start, some spaces at the end, and some unwanted double spaces in the middle of our data. We'll first have a look at what you can do to clean up these unwanted spaces in your data by using the Find and Replace feature in Excel. So you first select all the data, then on the Home tab, you click Find and select, then Replace. To get rid of double spaces, you enter a double space in the Find What box and a single space in the Replace With box. Then you click Find Next and choose Replace for each item you want to change. You could click Replace All to do all the fixes in one go, but unless you are absolutely sure of the changes, it's better practice to check and replace each one in sequence in case there are some valid reasons for these extra spaces. If you have a very large dataset, you might also choose Replace All to save you a lot of time. So using the Find and Replace feature got rid of most of those unwanted white spaces, but not all of them. We removed double spaces using that feature, but we also have some single spaces left at the start and end of some of the cells. You can't use Find and Replace to remove single spaces. Otherwise, you would lose all spaces in your data, including standard spaces between words, which you don't want to remove. But there is another tool you can use to clear spaces from cells, and that's the trim function. To use the trim function, you once again insert a helper column. The trim function is simple to use. Just type equals, then trim, then open parenthesis, then the cell reference, in this case, M2, then close parenthesis, and press enter. You can then double-click the fill handle symbol to copy this formula down to the remainder of the column. Now, you need to copy the contents of the new column N to column M, and remember once again to paste using the Paste Values option. You can now see that those erroneous spaces have been removed, or more accurately speaking, have been trimmed. And lastly, you can remove the helper column. In this video, we learned how to change the case of text, how to change date formatting, and how to trim white space from data. In the next video, we will discuss how to use the flash fill and text to columns features in Excel to help clean data. Now that we've learned how to change the case of text, how to change date formatting, and how to trim white space from data, in this video we'll discuss how to use the flash fill and text to columns features in Excel to help clean data. We used flash fill briefly earlier in the course as a quick method of entering data that fits a specific pattern, such as the names of months or days of the week, but it can also be used as a data cleaning tool. It can split a column of full names into two separate columns for the forename and surname, and it can also help to modify the naming convention used in a column of names. For example, in the Vehicle Toy Sales worksheet, there is a column containing the last names of contacts and another containing their first names. If you want to use the flash fill feature to combine these names into one name column, you first insert a helper column. Let's call it Contact Name. Then, in the first row in the new column, you enter the full name of the first contact in the format of your choice. For example, you might want surname, then a comma, then the forename. Or you might want surname and just an initial, and so on. In this case, let's just enter the name in the standard format of forename, then surname, with a space between them, and then we press enter. Next, you'll start typing the second contact's name, and you'll see that Flash Fill displays a preview of the remaining names for you. If you're happy with what's in the preview, all you have to do is press enter, and it fills in the remaining names for you right down the column. It even works when there are two names in one of the columns, such as Wing C here and Dakuna here. Now you can remove the original columns if you no longer need them. So in the previous task, we saw how to combine two columns of data into one column using Flash Fill. Now let's see how to use it to modify the naming convention in a column. Let's switch to the Customer Contacts worksheet. Then, in the first data row of the next column, that is B2, we type the name of the first contact using whatever naming convention we want. We'll use surname, then comma, then space, then the forename, and press enter. Again, when we start typing the second contact's name in the next row down, that is B3, Flash Fill detects the pattern and fills in the remaining names in column B when we press Enter. You could then copy and paste the column header and delete the original column A. What we couldn't do with flash fill was take a single column with two names in and split that into two separate columns. We need to use the text to columns feature to do that. So we'll close this worksheet and we won't save the changes. Now let's see how the text to columns feature can help with data cleaning too. As the name suggests, and unlike flash fill, the text to columns feature can take a column containing multi-part text and split that text into one or more other columns. This can be useful for splitting any multi-part text, such as names or addresses, into separate component parts. Let's open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. If we then select the data in column A from A2 to A23, and on the Data tab click Text to Columns, a wizard is launched. On the first page of the wizard, ensure that Delimited is selected. On the second page, ensure that only Space is selected as the delimiter. On the third page of the wizard, click the little arrow next to Destination and select B2 on the worksheet. Then click the little arrow again to return to the wizard. We're now finished with this wizard. You can now see that the full customer contact names in column A have now been successfully split into two new columns in B and C. And you could now remove column A if you no longer need it. We'll close this worksheet, and again, we won't save the changes. You can also achieve the same result using functions. This would be required if you were using Excel for the web, the online version of Excel, as this doesn't have the text to columns feature. There's also a bit more flexibility with functions, which can be especially useful if you have names that are complex and mixed, such as having hyphenated names, or some names with a middle name, some with two middle initials, and some with no middle initial. So we open the Customer Contacts worksheet again. Then we'll add column headings for the next two columns and copy the cell format used in the first column header. Then we'll widen the columns. Next, we'll enter the formula in B2 to extract the forename part of the name. This formula extracts 5 characters from cell A2, starting from the left and including the space. Then, in cell C2, we enter the formula to extract the surname part of the name. This formula extracts 7 characters from cell A2, starting from the right. Then we'll double-click the fill handle in cell B2 to use autofill to complete the column. And we do the same to the fill handle in cell C2 to use autofill to complete that column also. In this video, we learned how to use flash fill and text to columns features in Excel to help clean data. In this video, we will listen to several data professionals discuss issues around data quality. Can you tell us your experience with poor quality data and the cleaning of that data?
A large portion of my time is spent cleaning, verifying, checking data before I run an analysis. Working in healthcare, most of the information captured is based off of what someone's put in. So humans can't be calibrated. Two people can have a similar situation and look at things slightly differently. So it's up to me to make sure that if one describes something as navy blue and the other person describes it as dark blue, that I consolidate it and make it blue. That's just an example. We don't normally do that in healthcare. But the thought is that you always have to check the integrity of the information before you do your analysis to make sure that your results are accurate.
No data is going to be perfect. That's an unfortunate reality in the world in which we live in. Databases and data is collected for the broadest possible purpose, but oftentimes there are still things that are missing or not quite in the format that we want, whether that's collecting date and time as a single field, whereas when we're doing our analysis, we want to be able to break it out by day, month, and quarter. these are things that we can take into consideration. There's a lot of different cleansing activities that can be done and can be undertaken to help you get something that's specific and works for you and the way you want to work.
I have had experiences with poor quality data where I'm reviewing financial statements and I'm looking at margins, calculating ratios, trying to understand if what I'm looking at is, number one, directionally correct, but two, am I looking at the right thing? Are all of these costs, current costs, relevant to the period that I'm analyzing? Has all of the data been captured? Do I have all of the revenue for a given month? Then you have to go back and look at the sources, scrub that information to validate that what you're seeing is correct. And from an accounting perspective, if that data is incorrect or out of period, then adjustments need to be made to the general ledger, which houses the data to properly reflect what's happening.
Poor data quality can really come into play and cause discussions that don't need to be happening. They can cause you to be second guessed. They can cause you to not be able to be firm and present your case and your data reliably. Now, if this is the case, there's several different ways we can handle this. One is to go all the way back to the source to ensure that the source data is being pulled appropriately, or simply being able to outline and be very specific and direct in terms of what transformations or changes have been done to the data through tracking this in something like Watson Knowledge Catalog and being able to present that to your audience.
If you're filtering and sorting data and you find that it's wrong, you have to go back and fix things. That time could have been spent working on other deliverables. And again, it can call the data integrity into question if you're constantly having to redo or reiterate certain parts of data. And quite frankly, it can be frustrating at times if you're habitually having to do that. So paying attention to the details and the minutia so that you're not wasting time backtracking on something that you could have fixed early on are just some of the many benefits of ensuring that your data quality is good.
Now that we have learned how to collect and clean our data, it is time to decide the best method for analysis. In this video, we will discuss the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. Deciding how to manipulate our data can sometimes be difficult. Before we make any changes or adjustments, we will need to visualize the final output. Below are some questions to ask before beginning the task. How big is the data set? What type of filtering is required to find the necessary information? How should the data be sorted? What type of calculations are needed? Now that we have visualized the final output, we must decide the best approach to shape our data. The most basic step would be to filter and sort the data. By sorting the data, we are able to organize it based on conditions, such as alphabetically or numerically. For example, if we wanted to check for duplicate order numbers, we could sort the data and quickly see any duplicates. After sorting and removing the duplicate row, we find that the view needs to be more specific to meet our requirements. We now decide that we only want to see the data for the month of November. By adding a filter, we can now choose to only see items with a month ID that is equal to 11. By filtering our data, we are now able to only see the rows that meet the filter criteria, and it allows us to better analyze our information. Becoming familiar with all the tools to analyze data can seem daunting, but one key benefit of using a spreadsheet is the ability to use functions. Functions in Excel are organized by several categories, including mathematical, statistical, logical, financial, and date and time-based. Let's say we wanted to get an average of company revenue for the month of June. We realize there are over 100 items that would need to be calculated. In normal circumstances, to get an average, we would have to create a formula to add each row and divide by the total number of rows. This type of calculation would not only be very long, but can expose the analyst to possibly making a mistake. With the use of a function, We would be able to simplify our calculation in one easy step. Equals average, open parenthesis, B1, colon, B160, close parenthesis. While sorting and filtering data on our spreadsheet can be useful on its own, first converting your data to a table has many benefits. When we convert our data into a table, we are able to filter and calculate the data more efficiently. One example is the ability to easily calculate columns. For the column MSRP, we choose Sum, and we're able to quickly calculate the sum of the column. If we then look at the data, and we only want to calculate the MSRP total based on Japan, we would filter the country column to only display Japan, and the column would then only add the values in the rows that were associated with Japan. While all data may not work in a table, there are quite a few advantages to formatting your data as a table. Automatic calculations even when filtering. Column headings never disappear. Banded rows to make reading easier. Tables will automatically expand when adding new rows. Sometimes data needs to be more organized than what a basic tabular format can give us, and creating pivot tables with charts can be a better way to analyze and display the required information. In Excel, we have the option of creating a pivot table to display and analyze our data, and optionally, an associated pivot chart. For example, let's say we want to know what company ordered products in the month of October. From the original table of data, we create a pivot table to organize and analyze the required data, along with a pivot chart to display the information. By then adding the month filter to the newly created pivot table, we can see the results for the month of October not only in the table, but the changes are automatically updated in the pivot chart. When trying to single out specific information in a large data set, a pivot table is a nice way to show only the information that is required. This allows us to quickly and easily scan the essential information. Pivot charts are a nice accessory to pivot tables, as they allow us to visually process data and in most cases will let the audience grasp the information quicker. The advantages of selecting a pivot table and chart are manipulate data without using formulas, quickly summarize large data sets, ability to display engaging charts and graphs. In this video, we learned about the importance of filtering, sorting, performing calculations, and shaping our data to provide meaningful information. And we learned about some of the tools to begin analyzing our data. In the next video, we will learn more about filtering and sorting our data. In the previous video, we learned how to use the flash fill and text-to-columns features in Excel to help clean data. In this video, we will discuss how to filter and sort our data to enable us to control what information is displayed and how it's displayed in our worksheets. Filtering your data enables you to gain more control over which parts of your data are displayed at any given time in Excel. This can help with the visibility of data by narrowing down the data to within specified criteria and parameters, and it can also help when searching for specific pieces of data. To filter your data, the first thing you need to do is turn filtering on, which is very simple. On the Data tab, click Filter, and that's it. You will now see a small filter icon next to each of the column headers. As a side note, if you want to only filter on one or more columns, select those columns first, then click Filter. As another side note, if you format your data as a table, the columns automatically have filter controls added to them. So now, each column has a filter that can be applied to the data in that column. In the Order Date column, you can filter on the years. In Product Line, you can filter on the different product types. And in Customer Name, you can filter on each customer by name. Let's first filter on the year. We'll select orders from 2004 only by deselecting the other year. And if you wanted to, we could expand the year and filter by months also, but we won't do that for now. If you look at the status bar at the bottom of the worksheet, you can see that there are only 50 out of 114 records now displayed. If you want to clear a filter, you can either click the Clear Filter From option or click the Select All item in the filter list. Now, let's filter on the product line column to display only the rows that hold data for sales of classic cars. And again, we'll clear the filter. Lastly, we'll filter on the customer name column and only display sales to Mini Gifts Distributors Limited. And then clear that filter. So far, we've only applied one filter at a time, but suppose you want to filter down to a greater degree. We can do that too by just enabling all those filters together. And now we are only displaying sales of classic cars to Mini Gifts Distributors Limited in 2004. Remember, if you only want to clear one filter, then click its filter button in the column header and click the Clear Filter From option. But if you want to quickly clear all filters, you can use the Clear button in the Sort and Filter group on the Data tab. So far, we've used what are commonly referred to as auto filters, but you can also use custom filters to specify other criteria to apply to a filter to text or numbers. For example, if you wanted to see sales orders that are over or under a certain value, you can do that with custom filters. For the sales column, let's add a number filter that only displays sales that are over $2,000. If you look in the status bar, you can see that we are now showing 111 out of 114 records. Then let's clear that filter and filter it the other way to display the sales orders that are below $2,000. We can see that there are only 3 orders that are below $2,000. It's important to note that the data rows that we don't see have not been removed. They are still there. They have just been hidden from view by the filters. And this is indicated by the row numbers you see on the left in blue. The row numbers start at 69 and jump in large increments, indicating that there are many more rows of data in our data set than are currently being displayed. Let's clear those filters. If we look at a column filter for a column that contains text, you will see that the menu item changes to text filters instead of number filters, and you can see that there are several text filter options. And if you want to turn off filtering altogether for a worksheet, just click the Filter button on the Data tab. Now let's take a look at the basic sorting capabilities in Excel. Sorting is a very important part of the role of a typical data analyst. You might need to organize your text-based data alphabetically, your number-based data numerically, or your date-based data chronologically. When you sort data using these logical parameters, it makes it easier for you to conceptualize and visualize your data in a more meaningful way. When sorting data, the first thing you need to do is select which data to sort. For example, if you want to sort your customers alphabetically, select a cell in the customer name column first, and then either sort by A to Z or by Z to A. And if you want to sort your sales figures numerically, select a cell in the sales column first, and then either sort from smallest to largest or from largest to smallest. And lastly, if you want to sort your customers' order dates chronologically, select a cell in the order date column first, then sort from oldest to newest or from newest to oldest. But you can also sort your data by more than one column at a time. Simply select a cell in your data, then on the Data tab, click Sort. Then either use the Sort by Column suggested or use the drop-down list to select a different column. In this case, we'll choose the Order Date column as our first sorting criteria, and we'll choose oldest to newest in the order drop-down list. To add a further sorting level, you click Add Level. Then you choose another sort column in the Then By drop-down list. In our case, we'll choose Sales, and for this sort level, we'll choose largest to smallest in the order list. If you have a header row in your data, as we do here, then ensure you select the My Data Has Headers checkbox, then click OK to sort. So, the data is now sorted to list the oldest orders by order date first, then within each order date, if there are multiple instances with the same order date. Then, the next sorting level lists data by the largest order values first, down to the smallest order values. In this video, we learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets. In this video, we will listen to several data professionals discuss the importance of filtering and sorting your data. Why is it important to filter and sort your data?
Filtering and sorting are very important as part of your analysis and visualization experience, because this allows you to create one single view of the data, but then provide a function for people to be able to do their own analysis on it. Now, just to clarify, what we mean by this is sorting tends to be highest to lowest, alphabetical, or in some cases you may want to create some custom sorting where you put your particular product or offering at the start and then have the rest fall in behind it. Or you may want to group a few at the start to show your direct competitors versus others.
I love the filter and sort feature in Microsoft Excel. What it allows me to do is get to the heart of the data. I can drill down and see, for example, how much revenue a client had for a specific time frame, or how much money they made in a specific time frame, without looking through a lot of rows and a whole lot of information. So filtering and sorting really allows you to narrow it down and to get very specific and get the answers that you're looking for, and not just get loads of data that you don't necessarily need.
Now, when we talk about filtering, we talk about this to mean that I have a particular value on which I want to see the data specified by. So for example, if we had a bar chart showing our sales over months, and I want to see it in a particular geography or for a particular product line, I could have that available and allow me to filter down so that my sales would be specific just to one geography or one product line.
Now that we've learned how to use the filter and sort tools in Excel to filter and sort our data to enable us to control what information is displayed and how it is displayed in our worksheets, in this video we'll discuss how to use some of the most common functions a data analyst might use, namely if, ifs, countif, and sumif. First up, let's look at how to use the if function. The if function is one of the most used logical functions in Excel. The if function enables you to logically compare a value against criteria you set in the function, and then return a result based on whether the result of the logical comparison is true or false. And these values can be text values or numeric values. An if function essentially says, if something is true, then return a value or do something. But if it's not true, then return a different value or do something else. For example, in our vehicle toy sales worksheet, if we wanted to have a column that recorded whether the order had been shipped or not, you could add a new column to the right of the existing column, let's call it shipped, and then enter the formula seen in cell H2. This formula is saying if the text in G2 says shipped, then return yes, and if it doesn't, then return no. You can then use the fill handle to copy this formula down the column. You can see that most of the cells do say yes, but some don't, as the order hasn't been shipped for one reason or another. We could also use the if function to emphasize the size of an order. So, if we add a new column to the right of sales and name it 3K plus or minus, then enter the formula seen in cell F2. This formula is saying if the order is over 3,000, then return the text over 3K. But if it isn't, then return the text under 3K. And we can copy the formula down the column. In an ideal world, you would only use the if function to apply one or two conditions, but there may be scenarios where you would want to apply multiple conditions. In these cases, you can use the nesting capabilities of functions to bring together several if statements in one formula. These are called nested if functions. For example, if we add another column here for the order size, and then enter the formula seen in cell F2, you can see that this formula contains multiple if functions. One is needed for each condition, one for large, one for medium, and one for small, and it requires 3 sets of parentheses. So it's a relatively long and complex formula, but it does work. Again, we can copy the formula down the column. Even though Excel technically supports the nesting of up to 64 different if functions in a formula, it is not a recommended best practice. Having multiple if functions in a singular formula can become extremely challenging to manage. For example, suppose you come across a formula like this that you haven't used for some time, or even worse, was created by someone else. It could be quite difficult to work out how and why it is being used. Also, if your conditions increase, then you need to add more conditions to an already quite complex and long formula, which will only complicate matters more. To resolve this issue, a new function was developed called ifs. The ifs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. As the name suggests, this function can replace multiple nested if functions being used in a single formula to simplify matters. So if we add a further column for order size, but this time we'll use the ifs function instead. As you can see in cell G2, this formula only has one set of parentheses instead of 3, and only uses one function instead of 3. Let's copy that formula down the column too. Now let's have a look at another example of using the if function, but we'll combine it with conditional formatting too. If we switch to the car sales worksheet and add a new column to the right of the year resale value column and call it retention percent, then we enter the formula seen in cell G2, which will divide the year resale value by the original retail price. We need to format this as a percentage, and then we can copy it down the column. Next, we'll add a column to highlight the retention value for each car. The formula we add here in cell H2 uses the if function to state that if the percentage in the previous column is greater than 69%, then mark it as good. But if it isn't, then mark it as poor. Once again, we copy the formula down the column. We could also use conditional formatting to highlight the retention value percentages even more. We select H2 and on the Home tab, click Conditional Formatting and make a new rule. The condition in our rule will only format cells that contain a specific text value, and that value is the word good. And if it does match that condition, then format it with a dark green font and fill the cell in pale green. Let's copy that conditional formatting down the rest of the column. You can see that the cells that contain the word good are now formatted as we defined, but the cells containing the word poor are not. Let's add another conditional format rule. This time, we'll select Manage Rules because we are going to add another rule to our existing rule. The new rule will be the same as the previous one, with the exception of looking for a match with the word poor instead, and formatting those matching cells with red text and a pink background fill. And once again, we copy that down the column. Now all the cells that contain the word poor are formatted as red text with a pink cell fill. Let's now have a quick look at how to use the COUNTIF function. COUNTIF is one of the statistical functions provided in Excel. You can use it to count the number of cells that meet a certain criterion, such as the number of instances where an employee's name appears in a list of sales invoices, or the number of occasions a particular part number appears in a list of purchase orders. Let's switch to the vehicle toy sales worksheet. Suppose you want to find out how many of the sales orders in the list went to customers based in the United Kingdom. We enter the formula you see in cell AD7. Note that when we are using text as a criterion, we have to enclose the text in quotation marks. So there were 6 sales orders in the UK. And if you wanted to discover the same thing for French customers, then you would just edit the existing formula or copy it and then edit it. You can see there were 14 orders for French customers. Notice that this time the text entered was in lowercase, and it still works, so names in this function are not case sensitive. And let's do the same for United States customers. There are 41 orders to customers based in the States. There is also a newer function called COUNTIFs, which applies criterion to cells across multiple ranges to count the number of occasions where all criteria have been met. This removes the need to use multiple COUNTIF functions in a long and complex single formula. The COUNTIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. Now let's take a look at how to use the SUMIF function, which is a very commonly used mathematical function in Excel. You use the SUMIF function to sum the values within a specified range that meet specified criteria. For example, you might want to add up only the salaries that are over a specified salary level, or you might want to find the total of all sales of a particular product category. We'll enter the formula seen in cell AD10. This formula will add up each of the sales orders that have a total of more than $3,000. Again, notice that because we have used an arithmetic operator, that is, the greater than operator, we must enclose the criterion in quotes. If we specify a criterion that is only a number, we don't enclose it in quotes. So, the total sum of all orders that were over $3,000 is almost $470,000. You can also use wildcards, such as question mark and asterisk, when searching for partial matches, and you can also specify to extract values from a different column than the column where you have specified the criteria. For example, if we enter the formula you can see in cell AD13, it will sum all the car sales in column E for only those products in the product line column that end in cars. There is also a newer function called SUMIFs that you can use to sum cells based on multiple criteria. This removes the need to use multiple SUMIF functions in a long and complex single formula. The SUMIFs function is only supported on Excel 2019, Excel for Microsoft 365, and Excel for the web. In this video, we learned how to use the if, ifs, COUNTIF, and SUMIF functions. In the next video, we'll look at how to use the VLOOKUP and HLOOKUP reference functions. Now that we've learned how to use the if, ifs, COUNTIF, and SUMIF functions, in this video we'll look at how to use the VLOOKUP and HLOOKUP reference functions. VLOOKUP is one of the most commonly used reference type functions in Excel, and it enables you to find data referenced in a lookup table. It stands for vertical lookup, and therefore is a useful tool when you want to find something in a table or a range by row. Shortly, we will look at HLOOKUP, which stands for horizontal lookup, which looks for data by column instead. VLOOKUP works by using a common shared key between the source data and the lookup data in the lookup table. A typical lookup formula would look like $VLOOKUP, open parentheses, B3, comma, A2 colon B12, comma 2, comma, false, close parentheses, where B3 is the lookup value, that is, the value or word you are looking for. A2 colon B12 is the lookup table or range, that is, the table array or range of cells that contains the lookup value. In a formula, Excel references this as table_array. The lookup table can be on the same worksheet or in another separate worksheet. 2 is the lookup column number, that is, the number of the column in the lookup table that contains the value you are looking for. In a formula, Excel references this as col_index_num. False is an optional parameter that determines whether the match found has to be exact, denoted by false, or can be approximate, denoted by true. In a formula, Excel references this as open square bracket, range_lookup, close square bracket. The square brackets round this argument in the formula signifies that it is an optional argument, whereas the others are required arguments of a VLOOKUP formula. If you don't specify the optional false or true parameter in your formula, it will default to false. That is, an exact match is required. You can also use the number 0 instead of false, and the number 1 instead of true. Okay, now let's see the VLOOKUP function in action. In the car sales worksheet, suppose we wanted a quick price list of our favorite cars. The first thing we need to do is put the column containing the value we want to search for in the leftmost column, as VLOOKUP requires this. Then we can delete the original column. We then enter the formula seen in cell V16, which is looking for the word Corvette in the table array from cell A2 to G156, and then looks for the value in the fifth column, in this case, the price column, that matches the row containing Corvette and returns an exact value of $45,705. Note that in this example, we are using a part of our existing data table as the lookup table or table array. Let's format that as US currency. Then we'll format it to 0 decimal places. In fact, rather than use the reference A25 in the formula, it will be easier to use the reference to the word Corvette in the mini table in this worksheet where our list of favorite cars is. So that is V5, and the formula still works. Now let's copy that formula up to the favorite car table above it in the worksheet. But there's a problem, because when we copied the formula, the cell references changed. This happened because, as we learned earlier in this course, the default state of cell references is relative, and we want them to be absolute in this case. So let's undo that copy operation. To make the cell references absolute, we need to add dollar symbols to all the cell references in the formula. This can either be done manually, or you can put the cursor in each cell reference in turn in the formula and press F4 each time to automatically add the dollar symbols. Let's try and copy the formula again, and this time it works. If we use the fill handle on cell W5 to copy it down to the rest of the cars, it doesn't work. In fact, we end up with the same result in every cell. Why? Because each one is referencing the same cells in the lookup value, because we used an absolute reference. All we need to do now is modify the formula to remove the absolute reference for just the row parameter in the lookup value part of the formula by removing the dollar symbol. So in cell W5, we change $V$5 to $V5, comma. Then when we drag the fill handle down, it will copy the formula correctly, and all the prices will be changed to reflect their correct retail price. Lastly, to show that the two tables are now connected by this VLOOKUP function, if we change the retail price for the Chevrolet Corvette in the main data table in cell E25, the price will also change in the favorite car's price list. Let's now take a look at the HLOOKUP function, which, as we mentioned earlier, does the same thing and works in virtually the same way as the VLOOKUP function, but it looks for data in columns rather than rows. So, HLOOKUP looks for a word or value in the top row of a table, and then returns a value in the same column from a row specified in the table array. Therefore, you would use HLOOKUP if your comparison values were situated in a row along the top of a data table. In contrast, you would use VLOOKUP if your comparison values were located in a column to the left of the data you want to find, as they were in the previous task. Of the two functions, VLOOKUP is used far more frequently than HLOOKUP because of the nature of most data tables. The syntax for HLOOKUP is identical to that of VLOOKUP, except that you specify a row index number, referenced in a formula by Excel as row_index_num. This indicates the number of the row in the lookup table that contains the value you are looking for. Let's create a small lookup table on the right-hand side of our main data table. A few columns have been hidden in this worksheet to make viewing a little easier. So now we've got low HP, medium HP, and high HP in the top row of our lookup table. Next, we'll add wingding symbols as ratings for the 3 horsepower levels. 1 sad face for the low horsepower rating, 2 neutral faces for the medium rating, and 3 happy faces for the high horsepower rating. Now, let's add a new column to the right of the HP level column and call it HP rating. Then in cell L2, we'll enter the HLOOKUP function. This function will look for the value in cell K2, which in this case is medium HP, and it will look for it in the cell range from Y21 to AA22, which is our little lookup table, and it will return the answer it finds in row 2 of the table under medium HP and use an exact value. Note that we've used some absolute references in this formula too. Notice that what is returned is the text KK, so we need to format the cell using the Wingdings font. Now, when we double-click the fill handle, the whole column shows the HP rating symbols relevant to each row's HP level value. And we're done. Although VLOOKUP and HLOOKUP are regularly still used as the de facto functions for lookup references in Excel, there is a newer function called XLOOKUP. This version is only supported on Excel desktop versions from Excel for Microsoft 365 and on Excel for the web, as well as on Excel for iPad and iPhone and Excel for Android tablets and phones. XLOOKUP is an improved and combined version of VLOOKUP and HLOOKUP together. It can work in any direction, vertically or horizontally. It also uses separate lookup array and return array values, instead of a single table array and a column or row index number. In this video, we learned how to use the VLOOKUP and HLOOKUP functions in Excel to find and connect to data referenced in both vertical and horizontal lookup tables. In the videos coming up in the next lesson, we'll start to look at using pivot tables in Excel.